Planning your Microsoft Azure network environment is similar to how you might plan an on-premises environment, thinking about network infrastructure, placement, and configurations for routers, gateways, switches, and ultimately the virtual machines that will be deployed on the networks. We also need to think about whether we're going to be using IPv4 or even IPv6 addressing. We have to wonder, how many networks do we need to support the services that we want to deploy in Azure? Which services will run in Azure networks? We then have to think about connectivity to Azure services from the perspective of perhaps employees that are working remotely from home or traveling to customer sites, or on-premises network connectivity to Azure services. Both of those might occur through a VPN, encrypted tunnel. Also, VNet interconnectivity. We might enable VNet peering so that items appear to be on the same virtual network. And then we have to think, of course, in the case of having things like public-facing web apps, how customers will make a connection and whether we need to place content near those customers geographically, perhaps through a content delivery network or CDN. Azure Virtual Networking consists of VNets or virtual networks, which contain one or more subnets. We can use VPNs, either a point-to-site VPN for individual users to make a connection into Azure or a site-to-site VPN to link an on-premises Office network to the Azure cloud. We have to think about the IP address ranges that will be used. Specifically, a VNet is given an IP address space, and it's important that the subnets within it fall within that IP address space. An Azure Virtual Network, or VNet, is a resource that gets defined in the Azure cloud, and the name of it needs to be unique within the resource group that it's being deployed into. You have to determine the IPv4 or IPv6 address range that you're going to use. I say or, technically you could use both of them at the same time, IPv4 and IPv6. The fact is that by default, Azure VNets use Azure-provided DNS servers. However, you can change that if you need to custom DNS servers if you had custom name resolution requirements. A virtual network can also have DDoS, or Distributed Denial of Service protection, enabled, as well as an Azure firewall. Your VNet in the cloud can be considered an extension of your on-premises network, especially if you're linking it to your on-prem network through a site-to-site VPN or even through a dedicated express route circuit, which does not traverse the internet. The other consideration in planning is regions or locations. Let's say that we've got VNet 1 here on the left that's been deployed in the Canada Central region. When we go to deploy VM1, if we deploy that into the East US region, because that's a different region from Canada Central where VNet 1 is deployed, we will be unable to add VM1 into VNet 1 or any of its subnets because they're in different regions. So this is an important planning consideration. Now, of course, when you're deploying a virtual machine, you can at that time also create a new VNet within that region, but nonetheless, still important for planning. A virtual network consists of one or more subnets, and it has an IP address range within the VNet range. A subnet can also be associated with a network interface. Interface is tied to a VM. You can also associate a network security group or an NSG with the subnet. A network security group is a list of rules that either allow or deny network traffic. You can also associate a route table with the subnet. The route table would have routing entries to control network traffic flow. And we know that the subnet is contained within a VNet, meaning it is not its own Azure resource like a VNet is. We can manage Azure VNets and all related components using the portal, using PowerShell, using the CLI, and also through ARM templates. So when you're planning your VNets, we have to think about things such as data sovereignty. When we deploy services, potentially running app workloads that deal with sensitive data, when we deploy that into a VNet, where is that? Which location, which region? Because there might be certain data sovereignty issues to consider, such as the inability to have data collected in a certain manner, private data, stored outside of national boundaries. So regulatory compliance would come in as well, such as with PCI DSS if you're dealing with credit card holder data. We should think about reducing network latency. We had mentioned that one way you might do that is by using a content delivery network to essentially have a cached copy of data for a web app. Basically, it's replicated to a region geographically near the user. And of course, we have to think about high availability for our VNets. In other words, you might have multiple VNets. You might deploy a virtual machine in a VNet and then replicate that to a VNet in another region for high availability. Azure DNS provides a name resolution service. Normally, we have the friendly name that we need resolved to the corresponding IPv4 or IPv6 address, although there are other uses of DNS beyond just that, but that's by far the most common. So we're talking about VNet name resolution. This is where you can determine whether you want to stick with the Azure provided DNS name resolution or use your own custom DNS server IP addresses. You can also host private or public DNS zones in Azure. A DNS zone is different from a DNS domain name because the domain name is just the name, period. That's it. The zone is the configuration that supports that DNS domain name. In other words, it contains the DNS record, so we can host those in Azure. Common DNS record types that you'll encounter, certainly in Azure, will include the A record. An A type of record resolves friendly names to IPv4 addresses, where a quad A record resolves friendly names to IPv6 addresses. An MX record is a mail exchanger record. This one's used for SMTP mail transfer between SMTP mail servers. A CNAME record, canonical name, is an alias. It points to another DNS record, such as when you want to have multiple ways to refer to a specific resource. Then you've got the PTR or the pointer record. This is a reverse lookup pointer record. And as opposed to an A record, which resolves friendly names to IPv4 addresses, a pointer record means you already have the IP address. You just need to resolve it to the name. So this is an example of just a few common DNS record types. Azure provided DNS name resolution is the default configuration at the VNet level, so it can resolve public DNS names. It can also resolve virtual machine names within a VNet. So the DNS names would be for virtual machines or for network interfaces. Now, custom DNS name resolution can be set at the VNet level. You enter in one or more IP addresses for your custom DNS service. You have to have configured DNS servers of your own somewhere. So this means that you could allow for virtual machine name resolution then across VNets. And for infrastructure as a service VMs that are configured as Active Directory domain controllers, you would have to have your own custom DNS. It would be a domain controller because Microsoft Active Directory it relies upon DNS to locate domain controller servers. Now, if you were to go with custom DNS servers at the VNet level, you can also enable DNS forwarding to Azure name servers as well. Now, when you are configuring custom DNS server settings, as in this screenshot, you will open up the VNet, and in the left-hand navigator, you click on DNS servers. Then in the right-hand panel, you would switch it from default Azure provided to custom and go ahead and add the IP addresses of your DNS servers. Now, you can host DNS zones in Azure, such as public-facing zones. But in order to work with public DNS zones, so it's going to be used for name resolution outside of your Azure environment, then you must already own that DNS name and zone through an external DNS registrar. So you would then manage DNS using your normal Azure credentials because you've hosted it in Azure. That's the benefit of doing it. Whether you want to manage your hosted DNS zone using the portal, PowerShell, or the CLI. Creating a virtual network infrastructure in Azure is similar in ways to what you would plan for on premises. You would think about the number of networks that you need, how they might be subdivided into subnets, perhaps for isolation reasons, the addressing that would be used, and which types of resources you would deploy into those networks. So here in Azure, after having already planned those things in the portal, I'm going to click Create a Resource in the upper left. I'm going to type in virtual network, since that's what I want to create. So I'll choose virtual network from the list, and then I'll click on the Create button. The first thing I'm going to do is deploy this into an existing resource group, although I do have a Create New link if I wanted to create a new resource group. For the name, I'm going to call this VNet1, and for the region, I'm going to specify, in my particular case, a location near where I want these things running and where I'm administering them from, so Canada Central. I'm going to click Next, IP addresses. Now, the IP address space that is suggested here is 10.0.0.0/16. So 16 bits in the subnet mask means that 10.0, the first 2 bytes or octets, identify our network. I could also add an IPv6 address space if I wanted to, but I'm not going to here, and it automatically wants to create a default subnet. But the subnet will use pretty much the entire address space for the 10.0.0 subnet because it's /24 bits in the subnet mask. I don't want that. So I'm going to select the default subnet and I'm going to click Remove Subnet. I'm going to click the Add Subnet button. This way I have more control in things like the nomenclature. I'm going to call this Subnet 1. Now the subnet IP address range must fall within the VNet range. So I'm going to specify a subnet address range here of 10.0 because that's my VNet range, 16 bits, .1, now I'm in new territory, .0/24. So the first 24 bits in this particular case identify the network, or the subnet in this case, which is 10.0.1. Then I'm going to click the Add button, and we'll see that subnet 1 has been added to the list below. And I could continue to add multiple subnets at this time, but I only want subnet 1 for now. So I'll click the Next Security button down at the bottom. We can see that DDoS protection is enabled by default, basic, and the Azure firewall is disabled. I'm going to leave those as they are, and I'll click the Next Tags button. I'm not going to specify resource tagging information, so I'm going to click the Next Review and Create button. And after a moment, the validation will have passed. We will have a message to that effect in the upper left, so I'll click the Create button in the bottom left to create the VNet and the subnet. It'll only take a moment. When we have a message about the deployment being complete, we could click the Go to Resource button to go right into the VNet, or if I click Home in the upper left here, I could also go to All Resources to show all of my Azure resources. I could click Type equals All to filter it here, so I can uncheck Select All and choose Virtual Network and click outside so the filter is in effect. There's VNet 1. I could also click over on the left to open up my left-hand navigation panel. And from there, I also have a virtual networks view. So I could click virtual networks and there's VNet 1. So there are many different ways we could do it. I'm going to click to open up VNet 1. Subnets are not their own resource as a VNet is. And so you'll only see subnets when you drill into the VNet like I'm doing now. If I click subnets in the left-hand navigator, in the right-hand panel, I will have a listing of subnets within this VNet. We've got subnet 1 listed with the appropriate IP address range. If you've done a lot of work with TCP/IP, you might wonder why there are only 251 available IPv4 addresses here, when normally there should be 256, or depending on your environment, if all zeros and ones and binary are not allowed, then maybe 254 certainly. We don't have 254 available IPs. We only have 251. And that's because Azure reserves a couple of IPs for its own internal use. So this is to be expected. And you need to account for this when you design your VNet and subnet layout to accommodate your deployed resources. In Azure, a virtual network or a VNet can contain multiple subnets. And in this example, we're going to use the portal to add a subnet to a VNet that already exists. Now, why would we do this? We would do this because we've planned it out and realized that we might need another network segment to accommodate resources, maybe for testing purposes to keep those resources isolated from production items running in a different subnet. So there are plenty of reasons you might do this. I'm going to start by clicking Create a Resource in the upper left of the portal, and I'm going to type in subnet. And what you'll notice is that there is no such thing. And that's because subnets are not their own Azure resource. They need to be created within an existing virtual network. Aha! So let's open up the left-hand navigator here in the portal, and down on the left, I'm going to go down and choose Virtual Networks. We're going to see that we have an existing virtual network named VNet 1, which I'm going to click on to open up its properties. And in the navigation bar for VNet 1 on the left, I'm going to scroll down and I'm going to select Subnets. Any existing subnets in this VNet will be listed on the right. Subnet 1 is the only one that we have created currently. What's important here is that we take note of the address space. I'm going to click on address space on the left for the VNet. The reason that's important is because any subnets you define in the VNet, their IP address ranges must fall within the VNet address space. So what do we have here? We have a VNet address space for IPv4 of 10.0.0.0/16. The /16 is what's referred to as CIDR notation, CIDR, which implies how many bits starting from the left there are in the subnet mask to identify the network part of the IP address. So 16 bits means the first two numbers, the first two bytes or octets, identify the network, 10.0. That can't change for any subnets within this VNet, but we can go beyond that as we start using bits moving to the right. So, okay, I get it. Let's go back to subnets. I currently have a subnet named subnet1 using the IP address range of 10.0.1.0/24, 24-bit subnet mask. Okay, that's valid, and we can't use that again within the same VNet. So I'm going to click the Add Subnet button at the top. We're going to create a subnet called subnet2, and why don't we use 10.0.2.0/24? Now, if there are any errors with what you're typing in, meaning that if you have IP address ranges that don't properly fit within the VNet range, you'll know it. Let me show you what I mean. Let's start by giving this name. How about we call it subnet2? And let's say I start by identifying the address range or the CIDR block I want to use here as 10.3.0.0/24. Doesn't like it. So to the far right of the address range field, I have a red block with a white exclamation mark. And if I hover over it, it says, your subnet is not contained within the address space for this virtual network. It's not. Because our virtual network has a 16-bit subnet mask, which means the first two numbers can't be changed, 10.0. Well, I've got 10.3 here. Well, no wonder we have an error. So I'm going to change this to 10.0.2.0/24. When I click outside of that, it accepts it. We have a green check mark to the far right of that field. So it's validated. I'm not configuring a NAT gateway or a network security group or a route table or service endpoints. It's just a basic subnet with a valid address range. So I'm going to click OK. Now it doesn't take very long to do, and I can click the refresh button here if I'm getting impatient, and after which I will see that I have two subnets, subnets 1 and subnet 2. Subnet 2 has assumed the address range we specified, 10.0.2.0/24, and as expected, we have 251 available IP addresses. You're not limited to using only the Azure Portal GUI to create and manage VNets and subnets. You can also use command line tools like PowerShell. Now, why would you want to do that? Isn't that more difficult? Not necessarily. It's really in the eye of the beholder. Some people are much more comfortable using PowerShell, and so they would choose that to build and manage their VNets and subnets. In other cases, if you want it to be repeatable, let's say you need to create multiple VNets and subnets periodically for a testing sandbox environment, it's much quicker to deploy that if you have a script that creates the VNets and subnets than having to click through everything in the GUI. So in this case, we're going to use PowerShell. You could use that on premises if you've installed the Azure PowerShell modules on premises, but in this case here in the portal, I'm going to click in the toolbar at the top on the Cloud Shell icon. We can launch Cloud Shell here in the portal and work with PowerShell and the Azure CLI. Now, the first time you run this, and this is what I'm seeing here at the bottom, I have a message stating that I have no storage mounted. When you use Cloud Shell, you need some kind of persistent storage, as in the form of a storage account, so that if you wanted to upload files, maybe an import file to import Azure AD users or whatever the case might be, that there's somewhere to store that gets retained. So, down below, it's suggested the subscription where it should create a storage account. I only have one subscription, so that's an easy choice. I'm going to go ahead and click the Create Storage button. And before you know it, it's done. The Cloud Shell is ready to use, and I could maximize the Cloud Shell screen, and I could begin working with it immediately. In the upper left, I can switch between PowerShell and Bash. PowerShell will let me run not only PowerShell commandlets, but also the Azure CLI command set. So if I type AZ, we can see it recognizes it and it's working. So when should we switch over to Bash Shell? Well, if you want to use that kind of environment, if you're used to working in Unix and Linux and how variables are treated, which is going to be different in a bash shell, for instance, than it will be with PowerShell. But let's just minimize the Cloud Shell for a second. Let's just open up our left-hand navigator so that we can view storage accounts. I'm going to click Storage Accounts. What we'll see is that we've got a Cloud Shell storage account created. The resource group name will be prefixed with Cloud Shell storage. That's what was just created as the result of our actions in launching the Cloud Shell. That's fine. Let's click back on the Cloud Shell icon up at the top and clear the screen, and let's get to work, because what we're supposed to do here is create a virtual network or a VNet using PowerShell. So my plan then is going to be to create a new VNet called VNet2, and I've got the IP addressing in mind for that, and creating a subnet within it called Subnet1. So to get started, I'm going to create a variable called $subnet, which will store the result of running new-AZ virtual network subnet config. -name is subnet1, -address prefix. This has to have been planned ahead of time. You can't just make this up as you go. Well, you could, but you shouldn't. So it's going to be 30.0.1.0/24. That's for the subnet. I haven't identified the VNet yet or its range, so remember that the subnet range needs to be within the VNet IP address space. Now I'm going to press enter and I get all these yellow warning messages. There's nothing wrong here. It's just that some of these items, some of these commandlets in PowerShell will change over time, is really what I'm being told. Now I can suppress those annoying messages. And to do that, I'm just going to clear the screen with CLS, and I'm going to use the set-item PowerShell commandlet, and I'm going to refer to an environment variable. And to do that in PowerShell, what you do is you use the env for environment, env : prefix, then a backslash, and the name of the environment variable. So there's one here that is recognized by PowerShell and Azure. It's called suppress Azure PowerShell breaking change warnings. After that, I've got a space and in double quotes the word true. Excellent. So that'll take care of that. So what have we done? We've defined a subnet. We can check our work by typing in $subnet. That's our variable. And it's got some details about subnet1. Okay, so that's fine. We're ready to move on. When I say move on, we're ready to actually create a VNet and use that subnet configuration. To do that, I'll use the new -AZ virtual network PowerShell commandlet -resource group name. I'm going to deploy this into a resource group that already exists called eStarG1 -location. I want this to go into Canada Central -name. I want this VNet to be called VNet2 -address prefix. This is an important parameter. 30.0.0.0/16 is going to be my VNet range. Remember, the subnets have to be within that range. Finally, the last parameter I'll use as I'm building this VNet is -subnet, where I will pass it as a value our $subnet variable that contains our subnet configuration. So I'm going to go ahead and press enter. Okay, so we have a lot of returned output, and if I scroll back up through it, it looks like everything is working. We can see the provisioning state has a value of succeeded. I'll just clear the screen here. If I were to run get-az virtual network, and I'm going to pipe that to select, because I only want to see the name of the virtual network, so select name. When I press enter, I'll see any existing VNets like VNet1, and the one we just created, VNet2. If I were to take a look in the portal, just for fun, so I'll minimize Cloud Shell, and I'm just going to navigate in the left-hand navigation bar to my virtual networks view, because I'm interested in VNet2, that's what we just created. There's VNet2, and if I click on it to open it up, and if I were to click on subnets on the left, any existing subnets, such as the one we created, subnet1, will be listed in the right-hand panel. So we've successfully used PowerShell then to create VNet2 and subnet1 within it. PowerShell can be used to create subnets and associate them with a VNet. To get started here in the portal, I've launched the Cloud Shell from the Cloud Shell icon, and I'm going to start by creating a variable that will point to my existing VNet. So $VNet equals get-az virtual network -name, and I know I've got a VNet called VNet2. Now to make sure that that worked, I can run $VNet to display back our variable, and we have all the information about the VNet stored in that variable. It all gets returned. That's good news because it means we can proceed. Now we're going to proceed with making sure that we get the existing subnets for that VNet, because I want to make sure I don't create a new subnet with the same name of what's already there. How do we do that? Well, to show subnets, I'm going to run get-az virtual network subnet config. That's a long commandlet name, but it is correct. Config dash virtual network. I have to tell the virtual network or the VNet whose subnets I want to show. So I'll specify dash virtual network in our variable $VNet. What I'm returned here is the fact that we've got one subnet by the name of subnet 1. Perfect. We're going to create subnet 2. Now before we do that, let's take note of the address prefix for subnet 1. It's shown as 30.0.1.0/24. So the first 24 bits, the first 3 octets identify the network. So subnet 1's network address then, in other words, is 30.0.1.0 at the end. So we're going to create subnet 2, and it's going to use an address prefix of 30.0.2.0/24, just to keep in line with things and to keep things nice and clean and organized. To do that, I'm going to use the add-az virtual network subnet config commandlet. Dash name is subnet 2. Dash virtual network is our $VNet variable. Dash address prefix is going to be 30.0.2.0/24, as we had previously mentioned. Let's go ahead and press enter to get that done. And it happens very, very quickly. So we've now got it created. However, we just need to make sure that we commit this or that it's saved. So to do that, I'm going to run $VNet. That's our virtual network variable. And I'm going to pipe the result of that to set-az virtual network, where we are telling it that we want to modify and save the changes to that VNet. And that's important. I'm going to clear the screen. Now let's check our work here. Why don't we run, well, actually, why don't we use the up arrow key and go back to this one, get-az virtual network subnet config dash virtual network $VNet. And let's just pipe that to select. Why don't we tell it we only want to see the name, comma, and address prefix properties. Beauty. So within our VNet, we have 2 subnets, subnet 1 and subnet 2, with their respective address prefixes. You're not limited to using the Azure Portal GUI to create and manage Azure resources. You can also use the Azure CLI, the command line interface. The CLI could be downloaded and installed on an on-premises system, or you can run it in Cloud Shell through the portal, which is what I'm going to do. So here in the portal, I'm going to click the Cloud Shell icon up at the top to open a Cloud Shell session, and I'll maximize that window. It doesn't matter if you've selected PowerShell or Bash in the upper left. The CLI is recognized by both. Makes no difference. So to get started here, I'm going to guess that I would start with AZ. That's how we use the Azure CLI, followed by network. Just a guess. Let's press enter. Well, we have an error, but it does kind of imply below that there are some other subcommands that would follow AZ network. So to do this properly, what we really should do to learn about this is run AZ network -H. Now I could even pipe that through more to stop after the first screen full. So I have an alphabetical listing of subcommands that would follow after AZ network. And as I continue going through the list, I'll eventually come across VNet, which would be the next level command. So AZ network VNet, and I could then ask for help with -H. Same kind of thing. We'd look at the subgroups or subcommands after this, one of which is called create. We get asked for help even on that. I'll use the up arrow key to bring up our AZ network VNet -H command. But before the -H, I'm just going to add a create, space, press enter. Now we're going to get help on how to actually create a virtual network. So that's how we kind of learn or discover what's available in the CLI command set. So I'm going to clear the screen and we're going to get to work here. So you need to have planned your virtual network name and IP address space and any subnets, whether it's one or more, and their address space within the VNet. So here in the CLI, I'm going to create my VNet using the AZ network VNet create syntax. -G, the resource group is East RG1, -N, the name of the VNet here that I want to define is going to be called VNet3, so I've already had that planned out. --address -prefix, I'm going to specify 14.0.0.0/16. --subnet -name. So I'm creating a subnet while I create the VNet. I want to call this first subnet subnet1 --subnet -prefix. So the subnet CIDR range or address block will be 14.0.1.0/24. So it falls within the VNet address range. Let's go ahead and press enter to build both the VNet and the subnet. To list VNets using the CLI, I can use the AZ network VNet list syntax. Now, when I do that and press enter, it's a little overwhelming because I'm seeing all of the properties and the values for the VNets. I don't want that. So I'm going to clear the screen with CLS. I'm going to use the up arrow key to go back to AZ network VNet list. And I'm going to add to the end of that by adding --query space, open close square bracket. Now, what's that mean? Well, we could have multiple VNets returned in the list. It's an array. And so the array notation is shown here with open and close square bracket. And what do we want within each item? We want the .name property. So after the open and close square bracket, we put in .name. It's that easy. Press enter, and all we're going to see are the names of the VNets, or the virtual networks. And there's the one we just created, VNet3. In this demo, I'm going to be creating a subnet within an existing VNet using the Azure CLI. I've launched Cloud Shell from the Cloud Shell icon at the top of the toolbar within the Azure portal. So the next thing I want to do is first figure out, well, wait a minute, what do we have for VNets? I can determine this using the CLI command syntax as follows. AZ network VNet list. And I'll use --query, add a space after that, open and close square bracket, .name. We're going to get a returned list of VNets. We've got VNet1, VNet2, and VNet3. So in this particular case, how about we add the subnet to VNet3? Now, in order to do that, we have to essentially specify the details for the subnet and specify that we want that to be a part of VNet3. In the CLI, we can do that using the AZ network VNet subnet create syntax. -G, the resource group is East RG1, -VNet -name, VNet3 in our case, -N for the name of the subnet is going to be subnet2, and --address -prefixes I'm going to specify here as 14.0.2.0/24. Now, how would I know to use that? I know that VNet3 is using the 14.0 16-bit network address. So I'm going to go ahead and press enter to create that subnet within VNet3. We get a lot of returned output, which indicates everything went well. I'm going to clear the screen. And what I want to do is use the AZ network VNet subnet list syntax, --query space, open close square bracket .name. Don't forget that the open and close square bracket is required here because you could have more than one subnet within the VNet. We're listing the subnets. Well, the way that we tell it that we want to essentially loop through all of the subnets is to use a placeholder for each subnet or array element, and we do that with the open and close square bracket. We're just telling it that we want the name property of each item that we're essentially looping through. So let's go ahead and press enter and see what we get. Well, we have an error message because we didn't tell it some core elements, that being the resource group name and the VNet. Of course, that's going to be important. It's not a problem. I'm going to use the up arrow key to bring up that command. I'm just going to go here after list. I'm going to add space -G, East RG1 for the resource group. And then --VNet -name, VNet3. And then after that, we've got our space with --query and all that good stuff. Let's press enter and see what we get. It's looking good. We have returned a list of subnets within VNet3, and that list includes subnet1 and subnet2. One of the great things about using Azure Resource Manager, or ARM templates, is that it facilitates the creation or modification of Azure resources. An ARM template can be stored in a text file that you refer to locally or over the network, and that text file uses JSON syntax to define details about Azure resources to create or modify. So here in the portal, I'm going to use an ARM template to create a virtual network and some subnets within it. To do that, I'm going to create a resource here in the portal. So I'll click Create a Resource, and I'm going to search for template because I want to create a template deployment. So I'll select that, and then I'll choose Create. Now, Microsoft has made this incredibly easy. At the very bottom of the custom deployment screen, we have a heading labeled Load a GitHub Quick Start Template. GitHub is essentially an online repository for many things, including code samples and, in our case, ARM templates that's available to the public. So I'm going to click on the drop-down list at the bottom to start filtering, and maybe I'll type in VNet. I'll just click that again and type in VNet. And we're going to have all kinds of templates that contain VNet within their name. So I want to use a specific template that will allow me to create a VNet and 2 subnets. So let's just kind of scroll through the list here. What do we have? Okay, it looks like we've got a number of options here. How about, just going to go back up through the list here. How about I select template 101-VNet-2-subnets. Now, there are other variants of using ARM templates to deploy VNets and other items, like a WordPress website and so on. But I'm going to just deploy a VNet with 2 subnets. So I'll select that template. Down at the very bottom left, I can either edit the template. If I click Edit Template, it'll take me into the portal's editor where I'll see the actual JSON syntax that defines that ARM template. Now that's fine. I'm not going to change that. So I'm going to click the Discard button in the bottom left. And let's just scroll back here. Now, what it's done is it's placed us on the screen where we must supply the parameters required by that template. Some ARM templates might not require much of anything. It might have hard-coded things like names of VNets and subnets, or it might require it as parameters, as is the case here. So I'm going to have to specify a resource group where I want to deploy my VNet. So I'm going to choose an existing resource group. I'm going to have to specify a VNet name. I'm going to specify VNet 4. I can also specify the VNet address prefix. I'm going to use 15.0.0.0/16, which means I'm going to create a subnet, subnet 1, which I'm going to define as being 15.0.1.0/24, meaning that the first 3 octets, the first 24 bits, identify the network. Up above, /16 is indicating that only the first 16 bits, or the first 2 octets, identify the VNet address space. Subnet 1 will be the name of the subnet. Well, this particular ARM template allows us to create 2 subnets. That's pretty cool. So I'm going to specify a different IP address prefix or address range for subnet 2. It's going to be called subnet 2. As we look further down below, this template is coded to use the resource group.location property for the location to deploy the VNet, the region. That's fine. I'm okay with that. So at the final item I have to do at the very bottom is to turn on the check mark to say I agree to the terms and conditions stated above, which I do. So I will click the Purchase button to get started. Now, in this case, we're just creating a VNet and 2 subnets, and so as you might imagine, that happens pretty quickly. If we open our notification bell icon towards the upper right, we'll have a message about the deployment having succeeded from a template to the resource group East RG1. Let's check our work. I'm going to open the left-hand navigator, and I'm going to go all the way down in that and click Virtual Networks, rather. And I want to check to see that we've got VNet 4. VNet 4 is showing up in the list, and I'm going to click on it to drill into it further. In the properties of VNet 4, in its navigation bar on the left, I'm going to click Subnets, and it lists that we have subnet 1 and 2 with their respective address ranges in the right-hand panel. So it worked. We successfully deployed the VNet and 2 subnets very quickly and easily using an ARM template. If you've ever managed or been responsible for supporting an on-premises network environment, you've probably been exposed to routes. Now, routers use routing tables in memory to determine the most efficient path to send packets to their ultimate target or destination. Well, sometimes you'll want to control traffic flow in Azure, such as forcing outbound traffic to first go through some kind of a firewall appliance. And so to do that, we can work with route table resources in Azure. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Route, and then I'm going to choose Route Table, and after that, I'm going to choose Create. So I'm going to call this Route Table 1. I will deploy it into a resource group. The location I'll leave as Canada Central. Down below, if you're using a virtual network gateway, such as for connectivity to other networks, you can determine if you want the route entries in this route table propagated to virtual network gateways. It's set to be enabled by default. I'm going to leave that, and I'll click the Create button. And after a moment, if I take a look at the notification bell area in the upper right, if I click on that, the deployment has succeeded for our route table. And I'm just going to click the Go to Resource button to open up its properties because we're not finished. You can think of the route table resource in Azure essentially as being a container. Well, what should it contain? It should contain routing entries that control traffic flow. And then, not only that, we need to associate that route table with a network so that it actually gets used. So we might do it with a subnet, for example, set the association. So let's do those things. First thing I want to do here is click Routes in the left-hand navigator here within the route table. We don't have any routes yet, which means it's not doing anything. Now, why would we add a route here? Well, as we've mentioned, you work with routing tables because you want to control how traffic is routed. You want to control network traffic flow. Let's assume that we have a firewall appliance that we want traffic routed to on its way out of an Azure subnet. So to force or funnel the traffic through that before it just simply goes straight out to the internet, we would add a routing table entry. That's what we're going to do here. So I'm going to click the Add button at the top to do just that. Now, what's the route name going to be? I'm going to call it Firewall Inspection. And the next thing I'm going to do is specify the address prefix. I'm going to specify 0.0.0.0/0. For IPv4, that is the default route notation. So all traffic that's going to the default route, such as to the internet, will be picked up by that address prefix. Now, what's the next hop? What do we want to send the traffic to? A virtual network gateway? A virtual network, internet, virtual appliance? Now I'm like, what do you want to do? Well, in this case, if I have a firewall appliance listening on a specific IP address, I would choose virtual appliance and specify the next hop address. So let's say it's 14.0.1.100. So I might specify that as the address. Okay, let's go ahead and click the OK button in the bottom left, and after a moment, a newly added route will show up here in our route table. However, we need to associate the route table with a subnet for it to be used by anything. So we have to have planned things carefully. We have to make sure we've got resources like virtual machines deployed in a subnet, and we want all of their traffic to be inspected by the firewall. So it's important to place resources appropriately in networks when it comes to stuff like this. So how do we do this? In the left-hand navigator, you'll see Subnets. It's part of the properties of a route table. And there's an Associate button up at the top. I'm going to go ahead and click the Associate button. Then I have to choose from the virtual network list. So let's say I choose VNet 4. And then within that, I can open up the list of subnets, of which there are 2 in this particular case. I want this associated with subnet 1, and I'll click OK. So we've now associated our route table with subnet 1 in VNet 4. That means any resources in subnet 1 VNet 4 will see this as a route. Now let's go ahead and look at this from the perspective of the subnet. If I were to open up my navigator on the left, let's say, and go all the way down to virtual networks, that was in VNet 4. So I'm going to have to open up VNet 4 to get to the subnets in that virtual network. So to do that, I'll click Subnets in the navigation bar. And on the right, I'll click on Subnet 1. When you open up a subnet from this perspective, you will also see the route table association. So down below, the route table drop-down list shows route table 1. Of Of course, we could open up that drop-down list and choose a different route table or select none. But that's what we need to do in order to make the route entries in the route table effective, is associate it with a subnet. The Azure CLI can be used to create and manage Azure routing items. So in this demo, we're going to go ahead and launch Cloud Shell from the Cloud Shell button at the top of the portal, and we're going to use the CLI through here. You can also use it on premises if you've downloaded and installed the CLI on premises. So to get started here in the CLI, I want to create a route table. So to do that, I'm going to use the AZ network route-table create syntax, but I need some parameters here. -G, and the resource group is East RG1. -L for location, in this case I want this created in Canada Central. -N, the name is going to be route table 2. Let's go ahead and press enter to create route table 2. So before too long, the provisioning state will list succeeded. I'm going to clear the screen. We can also view our route tables by using AZ network route-table list --query, open and close square bracket, .name. And we're going to see the names of our route tables. So there's one that was existing already called route table 1, and the one that we've just created, route table 2. But as we know, that's not all there is to route tables, is it? We need to create entries within the route table to control traffic flow. Okay, so to do that, I'm going to use the AZ network route table route create syntax as follows. So AZ network route-table route create -G, the resource group is ESTAR-G1 --route-table-name. That's what we just created, route table 2. -N for the name of this route entry. It's going to be called firewall --next -hop-type is going to be virtual appliance --address -prefix 10.0.0.0/16. That means we're going to look at traffic that's destined anywhere within that address prefix, and then --next -hop-IP -address will be the actual IP address, in this case of our virtual appliance, our firewall. Now for --address -prefix, if you want to capture all traffic, as in the default route, in IPv4, we reference that as 0.0.0.0/0. So I'm going to go ahead and press enter to create that routing table entry. After a moment, the provisioning state is listed as having succeeded. So I'm going to go ahead and clear the screen. The last thing that we need to do to make this effective is associate the route table with a subnet, which in turn applies to all of the resources deployed within that subnet. To do that in the CLI, I'm going to run AZ network VNet subnet update. So I'm doing it from the subnet's perspective. -N, what's the name of the subnet? In this case, subnet 2, -VNet name, VNet 4, -G, East RG1, that's my resource group, --route-table. I want to associate subnet 2 and VNet 4 with the route table named route table 2. So I'm going to go ahead and press enter. And after a moment, it's done. Let's just minimize that. Why don't we go into our virtual networks here in the portal, and let's check our work. So to do that, we're going to go into VNet 4. And within VNet 4, we associated our route table 2, with subnet 2. So we're going to have to click subnets in the left-hand navigator. We're going to have to click to open up subnet 2. And one of the many items we'll see configured for subnet 2 is the route table association. And down below, indeed, it is showing route table 2. You can use PowerShell to create a route table in Azure, add entries to that route table, and then associate it with the subnet. Here in the portal, I'm going to do all of that by launching Cloud Shell from the button at the top of the screen. Now, once I'm in Cloud Shell, I'll be able to run PowerShell commandlets or Azure CLI commands, whichever is my preference. In this case, it's going to be PowerShell. So to get started, I'm going to define the route entry, and then we'll deal with the route table. So to do that, I'm going to create a variable in PowerShell called $route. So variables in PowerShell are always prefixed with the $, of course. The $route variable will store the result of running new-az route config. The name of this route is firewall. dash address prefix, I'm specifying the 10.0.1.0/24 network. So any traffic destined for anything on that network, I'm going to specify the next hop type as a virtual appliance, and the next hop IP address is going to be the IP address of that virtual appliance. So in this example, we want to capture traffic that's destined for 10.0.1.0, anything on that network, and we want it to be sent through this firewall appliance sitting at 10.0.1.240. So let's go ahead and create that route entry. But that's just the route entry hanging around in a variable in memory. We need to have a route table to insert it into. So to do that, here in PowerShell, I'm going to create a variable called $route table. It will store the result of running new-AZ route table. The route table's name, with -name, will be route table 3. -resource group name. I'm deploying this into an existing resource group by the name of EastRG1, -location Canada Central, -route. And I could have more than one route, but here just one. It's the $route variable. Let's go ahead and press enter to create that. But we're not quite finished, because what we need to do is we need to make sure that we specify that this is associated with a subnet. Before we do that, we need to get a handle on the appropriate virtual network, or the VNet. To do that, I'm going to create a variable called $VNet, and we're going to populate that variable using the get-AZ virtual network commandlet. -name is VNet3, that's an existing VNet. -resource group name, where that VNet was deployed, is EastRG1. Let's press enter. So I'm going to clear the screen with CLS, and I'm going to use the set-AZ virtual network subnet config commandlet. So we need to get a handle on the subnet and tell it that we want to use our route table. So after set-AZ virtual network subnet config, -virtual network is going to be our $VNet variable, -name. I know that there's a subnet called subnet1 in VNet3, and I know that the -address prefix is 14.0.1.0/24 for subnet1. And here's the key here. -route table is going to be our $route table variable. To make sure that gets saved or committed, I will pipe that to the set-AZ virtual network command. Let's go ahead and press enter. And after a moment, it's done. So let's check our work just for fun in the portal. I'm going to minimize the Cloud Shell, and I'm going to go to the All Resources view. Let's do it this way. I'll just filter out the view so that we're seeing only the resource types that we're interested in. So currently, type equals all at the top. I'm going to click on that, uncheck select all. I want to see route tables, so I'll select route table and virtual network, and I'll click outside of it. And that puts the filter into effect. So we've got route table 3. That's what we just created using PowerShell. So why don't we open that up, because we should have a route in there. So I'm going to go ahead and click routes, and we'll take a peek. Now the route that we created was really designed to be sent to a firewall. So we've got the address prefix and the next hop address, which is the actual address of the firewall appliance. And if I click on subnets on the left, this route table should be associated with subnet 1 in VNet 3. Microsoft Azure allows you to create DNS zones. A DNS zone is not quite the same thing as a DNS domain, because really, technically the DNS domain is just a name. It's a text string. But the manifestation of that configuration for that text string, that's the zone. It contains resource record sets that do things like resolve fully qualified domain names, or FQDNs, to IP addresses. Let's get started building a DNS zone here in the portal. So to do that, I'll click Create a Resource in the upper left. And we're creating a DNS zone, so I'm going to search for DNS zone. But notice that we can choose a DNS zone and a private DNS zone. That's interesting. So I'm going to create just a DNS zone. In other words, it's going to be a public DNS zone that's going to be used for a DNS domain that I have registered with an external DNS registrar. So I already own it. So I'm going to click DNS zone to do this, and then I'm going to go ahead and click on Create. Now you might wonder, why would I do this? I already have the domain name registered with an external DNS registrar, and by all rights, that means I can administer it through that external DNS registrar. All of that's correct. It's true. However, wouldn't it be great if we could just manage DNS domain names and records that are related to Azure resources in Azure using familiar Azure administrative tools. That's why we're doing this. So I'm going to create a DNS zone. The resource group I'm going to deploy this into, I will select from the list. What do you want to call it? Well, this has to match what it's really called out in the real world, the real DNS domain name that I own. In this case, I've got one called quick24x7test.info. I've already registered that outside of Azure. So I'm going to go ahead and click the Next Tags button. I'm not going to add tag items and values, so I'll click the Next Review and Create button. Validation has passed, it says in the upper left. So I'm going to go ahead and click Create in the bottom left to create my DNS zone. It'll only take a few seconds where you'll get a message that states the deployment is complete. So I'm going to click the Go to Resource button. The next thing I want to do within my new zone is I want to work with the record sets. In the overview blade, over on the right, I've got a couple of default records or record sets. I've got the NS or name server record set. These use Azure name servers for resolution, and I've got the SOA or Start of Authority record. I can click the Add Record Set button up at the top to add records of my choosing. And what I want to do is add an entry with the name of www. Now, after that, it will append the .quick24x7test.info DNS domain suffix in my particular case, because that's the name of the DNS zone I configured here in the Azure portal. From the type drop-down list, we can choose an A record to resolve friendly names to IPv4 addresses, or quad A to resolve friendly names to IPv6 addresses. We can create a CNAME or alias record that points to something else, an MX mail exchanger record for SMTP mail transfer between servers, a name server record, service location record, text or pointer record, PTR, which is a reverse lookup record, meaning I already have the IP, I'm looking for the name. So in this case, it's going to be an A record. The time to live will be 1 hour. I can change that. And then I specify the IP address I want that full name to resolve to. So I'll just pop in an IP address of a web server, presumably that I've got configured and ready to go, that I want referenced using that full name, and I'll go ahead and click on OK. After I've done that, down below, we will have created our record set, and it's shown in the list. We've got our www record that points to the IP address of our website. Now, from a command prompt on my on-premises system, I'm going to go ahead and I'm going to run NSLOOKUP, the built-in name server lookup tool. I'm going to specify the fully qualified domain name for what we've just created, so www.quick24x7test.info, and I'm going to tell it I want to refer to one of my Azure DNS name servers. Now, where did I get that value? Let's take a look back at the portal for a moment. When you're looking at the overview blade of your DNS zone, over on the right, you will have 4 name servers. All I've done is simply copied the first entry. So back here in the command line, what we're doing is saying, I want a test name resolution for this name by looking at this DNS resolver server. And what we're looking for in this case is a non-authoritative answer. We can see that it's being resolved to the correct IP address. However, we want to make sure that the name is resolvable to the IP address without having to specify an Azure name server entry. So what you would have to do then is in your external DNS registrar, make sure that name server records point to the Azure name servers. As an example, I'm in the DNS management tool for GoDaddy for my DNS domain name. That's where I registered it. And I can go down and I can add a name server record where the host is an @ symbol and points to is one of those Azure DNS servers. You can add all of them as well if you want. By doing this, then the name will be resolvable to the IP address globally without having to specify an Azure name server to query. You can use the Azure CLI to create and manage Azure DNS zones. Bear in mind that the DNS zone is the configuration, including record sets, for the DNS domain name. The DNS domain name is just that, a name, nothing more. So the zone is the config of it. So to create this, I'm going to start here in the Cloud Shell. I've launched Cloud Shell in the portal from the Cloud Shell icon at the top. I'm going to run AZ network DNS zone create. Then -G, the resource group will be EastRG1, -N for the name, and I want to call this one callinsure.com. And I'll press enter. That's just going to create the DNS zone. But the next thing we would have to do is create some record sets for name resolution. Otherwise, what's the purpose of creating the zone in the first place? I'm going to add a record set to my newly created DNS zone in Azure. I'll use the AZ network DNS record-set A add-record syntax. That's a lot. Now, the single A that I referred to means that we want to manage A records within the zone. Now, following what we already mentioned, we have -G for the resource group, which is EastRG1, -Z for the zone name, which is callinsure.com. That's the zone we want to add the record set to. -N for the name of the record set, which in this case will be www. Finally, -A for the IP address that will resolve to. So I'll go ahead and press enter to create that record set. If you already have an A record with a different IP address, which I do as a result of seeing the output, it will simply add a second reference to a different IP address. You might do that if you wanted to use some kind of round robin where the first request goes to the first IP, the next goes to the next. If you don't already have that record set created with an IP address, it would simply create it with the IP address you specified. Let's clear the screen. Next thing I want to do is show or list those records. So AZ network DNS record-set list-G for the resource group of RG1, -Z for a zone by the name of callinsure.com. And I'm going to go ahead and press enter. So that will return the DNS record sets in that specific DNS zone, but it returns all of the properties, which can be a little bit overwhelming. Why don't we pare it down a little bit? I'm going to clear the screen and use the up arrow key to bring up that long command, but I'm going to change it by adding at the end --query space, open and close square bracket, because it will list many record sets. It's an array, so open, close square bracket. What do we want to see within each of those? Dot, and then open square bracket again. I want to see name, comma, and also A records. These are properties, two of them that I want to see. And after I've done that, I'm going to press enter. So what we're seeing then is the name, for example, www, and the IP addresses associated with that record set. You can use PowerShell to create a new DNS zone in Azure and also create and manage record sets within the zone. To get started here in PowerShell, I'm going to use the new -AZ DNS zone commandlet. I'll specify -name with the name of permacan.com. That's the DNS zone I want to create. -resource group name in this case will be EastRG1. So I'm going to press enter. But all I've done at this point is created the DNS zone. It's going to have the standard name, server, and start of authority records in it, but that's not all I want. I want to create additional record sets. So I'm going to clear the screen. I'm going to create a record set for resolving a name to an IP address, so an A record. Now to do that, I'm going to use the new -AZ DNS record set commandlet. The first thing I'll do is specify -name, and I want to call this record set www. So I want to resolve www.permacan.com to an IP address. -record type, I'm going to set to an A record. An A record lets you resolve friendly DNS names to IPv4 addresses. We have to tie this record set to a zone. So -zone name in this case will be our newly created permacan.com. -resource group name is EastRG1. I can also set the time to live or the TTL, in this case, for example, to 3600. The TTL is used to specify how long each client will cache the result of querying that item. However, in this case, the TTL is 3600 seconds. You could also specify that in units of hours, which is 1 hour. Then I'll use -DNS records, what's in the parentheses, to be treated as a separate expression and executed first. I'm calling upon new -AZ DNS record config, -IPv4 address, and I'm specifying the address I want this A record to resolve to. So I'm going to go ahead and press enter to create that. Okay, so I've got a zone created and I've got a record set created within the zone. We can retrieve information about record sets in a zone, and I'm going to do that with get-az record set-zone name permacan.com-resource group name eastrg1. And when I press enter, it's going to return all of the record sets, including the www record set that we just created as an A record with its respective IP address. Let's take a look at the DNS server settings for a virtual network or a VNet in Azure. So I'm going to open up my left-hand navigator and click on Virtual Networks, and I'm going to open up one of them. I've got a number of them created already. I'm going to click on VNet 3. Now, when you open up a VNet like this, one of the things that you'll notice in the navigation bar on the left is if you scroll down, you'll see an entry called DNS servers. When you click on that, on the right, the default selection is to use the default Azure provided DNS servers. That allows for name resolution for internet names, of course, public DNS names, but it also allows for name resolution of other resources within the same VNet. But there might be times when you want to use custom DNS servers. Why would you want to add one or more custom DNS servers? Because you're deploying some kind of a service into the VNet, well, specifically into one of the subnets in the VNet, that requires its own DNS settings. An example of this is if you wanted to have your own Active Directory domain services domain controller running in a virtual machine, not as a managed service, but you configure everything just running in a VM in Azure, you would have to make sure that you change the DNS names because Microsoft Active Directory uses DNS service location records to locate domain controllers. So that they can replicate amongst one another, to allow user logon, to allow a station to find group policy, and so on. That's just one example of why you might want to do this. So what you would do is switch it to custom and add the IP addresses, whatever they are. It's going to depend on the addressing used within your VNet. Put in the IP address or addresses of your DNS server or DNS servers. They should never be limited to one, in case one fails, in which case the second one would kick in. So you can add multiple DNS servers here that would be used. After you've done that, you would click Save, and that's all that you need to do. Now, it does say that virtual machines within the VNet will need to be restarted to pick up the new settings. So you want to try to plan for this ahead of time to avoid that issue. So in this course, we've examined how to configure and deploy VNets, configure subnets and routing table entries, and how to create a DNS zone. We did this by exploring Azure networking components and how Azure supports DNS, how to create a VNet and a subnet using the portal, PowerShell, and the Azure CLI. We looked at how to use an ARM template to deploy a VNet. We looked at how to configure routing table entries to control traffic flow, how to create a DNS zone, and how to enable custom DNS servers for a VNet. In our next course, we'll move on to explore Azure network connectivity and security, including VNet peering, configuring VPN and WAN settings, working with Azure Firewall, and managing network security groups. Yet another Azure Virtual Network planning consideration is whether or not VNet peering is required. VNet peering is used to connect Azure VNets directly together. Now, the result of this is reduced network latency. Now, this is especially true if the two VNets that are being peered are within the same Azure region. It also offers seamless network connectivity. Now, what does that really mean? Well, what it really means is that the network traffic is not routed through the internet, but instead through Microsoft's backbone network. That's what you get as a result, as a benefit, when you peer VNets together. And it means that resources on each VNet can communicate directly with one another instead of accessing another resource's public IP address, as an example. So VNet peering. The first consideration is that the VNets that you're peering together do not have to be in the same Azure region. If they are, you get more speed, essentially. The VNets must not have overlapping IP address spaces. This one is important. The inter-VNet VM traffic traverses not the internet, but as we've mentioned, the Microsoft backbone network. Now, even though you might peer two VNets together, once they're paired together, the VNets are still separate entities. They're still separate Azure resources that you manage independently of one another. The other thing to think about is that when you connect VNets together using peering, then VMs on each of those VNets can communicate with other VMs on other VNets using private IP addresses. That's one of the benefits here. You can also go with a hub and spoke topology. Here we have in the center a hub VNet, and we've got two other VNets, VNet 1 and VNet 2. Now, the double-headed arrow between each of the VNets implies that we've got a peered connection. So VNet 1 is peered with the hub VNet, and VNet 2 is also peered with the hub VNet. Note that VNets 1 and 2 are not peered directly together. So what we could do in this example then is place any shared resources that are going to be used by services on VNet 1 and 2, put those in the hub VNet. Now, because, for example, VNet 1 is paired with the hub VNet, resources in VNet 1 will see resources in the hub VNet. They'll be able to communicate with them. And also, VNet 2 resources will be able to talk to those centralized shared resources in the hub VNet as well, because it's got a peered connection with it. Now, if the hub VNet has forwarding options enabled in the peered connection, then it would also allow, as an example, resources in VNet 1 to go through hub VNet to connect to VNet 2 services. Let's talk about some of those configuration options when you set up a VNet peering configuration. One of those options is called Allow Forwarded Traffic. What this does is it allows traffic forwarded from a different VNet to flow into a specific VNet. The other option is to allow gateway transit. Now, in our diagram, as an example to explain this, if we've got a virtual network gateway, sometimes called a VPN gateway, in our hub virtual network, having allow gateway transit enabled would allow traffic from VNet 1 and VNet 2, they were paired with the hub VNet, to go through the gateway, for example, to access services in an on-premises environment, if that's what the virtual network gateway is connected to. There's also an option to use remote gateways. This will be something you would configure when you're peering a connection such as from VNet 1 to the hub VNet or VNet 2 to the hub VNet. What you want to do when you enable remote gateways is understand that it's going to allow traffic from the VNet where you're configuring the peered connection, let's say VNet 1, it would allow traffic from VNet 1 to flow through the gateway in the target VNet. In other words, the hub VNet that we're peering with. The other thing to bear in mind is that if you're not using any of these forwarding or gateway transit type of options, by itself, peerings does not mean that you have transitive connectivity. So if we've peered VNet 1 to hub and VNet 2 to hub, if we haven't enabled any of the above listed options, services on VNet 1 will not have direct access to services in VNet 2, at least not through the private IP addresses. Now you can use the CLI to configure VNet peering. So we've got the syntax for AZ network VNet peering create to create the peered connection. That's a two-way street. It's got to be done in both directions from each VNet's perspective. AZ network VNet peering list to show VNet peering configurations. AZ network VNet peering show to show a specific peering connection as opposed to a list of all of them. And AZ network VNet peering update to make a change to the peering config. And finally, AZ network VNet peering delete to remove the peering configuration. The same type of thing is possible also using PowerShell. We could use add-az virtual network peering to add a peering connection, get-az virtual network peering to retrieve configurations. We can modify a network peering configuration with set-az virtual network peering, and we can remove the peering connection with remove-az virtual network peering. Of course, all of this syntax in the CLI and PowerShell has additional command line parameters and values, but these represent the core syntax that you would have to be aware of. Once you've determined that you do want to enable VNet peering to connect VNets directly together, the next order of business is to do it using the appropriate tool. And one of those tools is the portal. So here in the portal, I've already navigated to my virtual networks view where I have 4 VNets. I want to peer VNet 1 with VNet 2. That's a two-way street, meaning I have to do it from each VNet's perspective. We're going to start with VNet 1. I'm going to click on VNet 1, and in the properties for VNet 1, I'm going to scroll down in the navigation bar on the left, and I'm going to click on Peerings. Any existing peering connections will be shown on the right. We have a listing that states no results, so there's no peering. I'm going to click the Add button to add a peered connection. So there's a few things I'm going to have to specify. First of all, the name of the peering connection. I'm going to call this VNet 1, because that's where it's stemming from, to VNet 2, because that's what I'm connecting to. The next thing I'm going to do is specify the target virtual network I want to peer with. I'm already in VNet 1, so it knows that's the source. So the target here will be VNet 2. I'll select that from the list. And what I have to do is give a name for that peering connection in the reverse direction. So I'm going to call that VNet 2 to VNet 1. All right, so we've got a name for both of those peering connections in both directions. Then down below, we've got some configuration settings to consider. Do we want to allow virtual network access from VNet 1 to VNet 2? Well, yes, that's why I'm setting up the peered connection, so that's enabled. Allow virtual network access in the opposite direction from VNet 2 to VNet 1. Same deal. Yes, that's why I'm doing this. I want that enabled. Do we want to allow forwarded traffic from VNet 2 to VNet 1? That means if we have traffic originating from some other VNet that is in VNet 2 and is being sent to VNet 1, do we want to allow it or not? I'm going to leave that as disabled. Next option, allow forwarded traffic from VNet 1 to VNet 2. Same type of scenario. No, I just want traffic originating in VNet 1 to be able to go to VNet 2 and vice versa. Not anything forwarded. And then I also have the allow gateway transit option. Now, I don't have a virtual network gateway configured in VNet 1, but if I did and I wanted to allow traffic from VNet 2 to go through the gateway, I could allow the gateway transit option. So I'm going to go ahead and click on OK to create the peered connection. I'll click refresh, and on the right in the peerings view, I do see that I have a peered connection, VNet 1 to VNet 2. The peering status is currently, well, it was currently in the midst of being modified, but now it just changed as I was speaking. The peering status now shows as connected. Let's look at this from the perspective of VNet 2. So I'm going to select my VNet 2 network on the far left, and I'm going to go make sure I'm looking at the peerings for VNet 2. Remember when we created this configuration, we had to provide a name for both sides of the connection. So here in VNet 2, we have a peering status of connected, and the name is VNet 2 to VNet 1. So both of those VNets are now peered together. So if we had virtual machines in both VNets 1 and VNet 2, they would be able to communicate with one another using their private IP addresses, which is a result of the VNet peering. Here in the portal, I've clicked the Cloud Shell icon in the top toolbar to launch Cloud Shell, where I can work with the CLI. In this case, I'm going to enable VNet peering using CLI command. I'm going to start by attempting to create a variable called VNet2, but all of my syntax seems to result in an error. Now, the reason for this is because in the upper left here in the Cloud Shell, we're in a PowerShell environment. But the way that this variable reference is coded here, it's only going to work in a Bash shell, not in a Windows PowerShell type of environment. So I'm going to switch from PowerShell to Bash. I'll click the Confirm button to confirm that I do indeed want to make that switch. And we're going to run the exact same statement again. This time it's going to work, because that's one of the differences between choosing Bash and PowerShell. It doesn't mean whether you can use the CLI. You can use the CLI either way. It's how you work with things like variables within that specific environment. So I'm going to paste that exact same code in again. Now, what is that code, by the way? Well, I'm creating a variable called VNet2. Now, I'm not putting a $sign in front of it because this isn't PowerShell. Now, the $sign that appears in front of it is part of my command prompt, not part of my expression. So VNet2 equals $, open parentheses, AZ network VNet show, space backslash to move to the next line, -- resource -- group is east RG1, -- name is VNet2, -- query ID, I want the ID of the VNet, and -- out is in tab separated value format, TSV, close parentheses. All we're doing is storing the ID of VNet2 in the variable called VNet2. Now, to verify that that worked, I'm going to run echo $VNet2. But then I get nothing. Well, that's okay. Remember, we're in a bash shell. Everything is case sensitive. So let's use the up arrow key to bring up that command again, and let's refer to VNet2 in the proper case. I had a lowercase n for net as part of VNet2. It needs to be uppercase because that's how we define the variable up above. Now let's see what we get. We now have the ID of the VNet successfully stored in the variable. Got it. So we're going to do pretty much the exact same thing to set up a variable for the second VNet we want to peer with, which is VNet3. So really the same thing other than the name of the VNet. And if I were to use my up arrow key to bring up our echo statement for VNet3, well, we can see that much like the VNet2 variable, the ID is stored within it as well. That's a good thing. That's required for this to work. So I'm going to use the clear command, not CLS here. We're in a bash environment. Now I have to create the peering connection, and I'm going to have to do it in two directions. So I'm going to start by using AZ network VNet peering create -- name. Well, this is going to be called VNet2 to VNet3 -- resource - group is E*G1. Let's go back up to our command here, see our syntax. The -- VNet - name is VNet2, that's the source VNet. -- remote - VNet - ID, I'm just going to use my $, VNet3 variable. Remember, it's case sensitive. So I'm linking or peering VNet2 to VNet3. And finally, -- allow VNet access. I want to allow traffic to flow between the VNets. But that's from VNet2 to VNet3. So let's clear the screen. We're going to have to do the same type of thing, but in the opposite direction. We're going to need to peer VNet3 with VNet2. We've already got the variables, so that's pretty easy to work with. We're going to use AZ network VNet peering create once again. This time we're going to call it VNet3 to VNet2. The resource group is the same. The VNet name here, the source VNet, is VNet3 this time. And the remote VNet ID is going to be referenced through our variable, scroll back up here, for VNet2. And again, -- allow VNet access. Now, if we were to check our work, let's say in the portal, I'm going to minimize what I'm looking at. I already happen here in the portal to be looking at VNet2's peering. So let's just click refresh. There's a new peering that was added here, VNet2 to VNet3. Notice that a single VNet can have multiple peerings to different targets. That's totally okay and acceptable. Let's look at VNet3 and check out its peerings. Sure enough, we've got a connected peered linked with VNet2, and the name of it is VNet3 to VNet2. So it worked. We successfully used the CLI to enable VNet peering. You can use PowerShell to configure VNet peering. Here in the portal, I've launched Cloud Shell from the top icon, and that's put me into my Cloud Shell environment, and I'm looking at PowerShell here in the upper left, which is fine. So what I'm going to do is set up VNet peering. Now, in order to do this, I need to first establish variables containing the appropriate VNet information. Now, if I just flip over to the portal for a second, here I'm looking at VNet1, and I'm looking at the peerings view, and it says no results. So we don't have a peered connection. Well, we're going to check this afterwards when we're finished in PowerShell because there will be a peered connection there. Let's go back into our Cloud Shell. So the first thing I'm going to do is create a variable called $VNet1 in which I will store the VNet1 information in Azure. So that's going to store the result of running get -az virtual network, -name is VNet1, -resource group name is E*G1. Simple as that. So once that's done, if I just type in $VNet1 and press enter, we can verify that it does contain something. It's not a null variable, and so it's going to serve our purposes quite nicely. We're going to do the same type of thing once again, except for the target VNet that we want to peer with. In this case, I want to peer VNet1 with VNet2, and so in this case, we're making a variable for VNet2 that will store VNet2's information. So I'm just going to press enter to do that. Just to be careful, I'm going to run $VNet2 just to make sure the variable is not null and it contains something, which it does. Okay, so let's get down to the nitty-gritty. Let's set up the peering. So to do that, I'm going to use add-az virtual network peering. Now I have to give a name to this peering connection. So -name is going to be VNet1 -VNet2 -virtual network. That's the source. VNet is going to be our variable, $VNet1. And -remote virtual network, I'm going to refer to our $VNet2 variable, but I'm going to call upon the .id property of it. I need the ID of it. Okay, fine. Let's go ahead and press enter. Now that takes care of one half of the equation, meaning I have peered VNet 1 to VNet 2. Now I have to do the same thing in the reverse direction. So I'm going to use pretty much the same command, add-AZ virtual network peering -name. This one's going to be called VNet 2 -VNet 1 -virtual network. The source in this example is going to be our $VNet 2 variable, -remote virtual network ID is our $VNet 1 variable, .id property. Let's go ahead and press enter to set up the peering connection in that direction. Okay, that won't take long. Clear the screen. Now we're going to run this long command, get-AZ virtual network peering -resource group name eastrg1 -virtual network name VNet 1, and I'm piping that to select. I want to select the peering state property. Now that entire expression is within open and close parentheses, and then I'm calling upon .peering state outside of the parentheses. Now I'm doing that twice, once for VNet 1 and once for VNet 2. I want to see the state of the peered connection. And I can see that it returns connected and connected, which means that the peers are linked together. Now we can verify this, of course, for VNet 1 and VNet 2 in the portal. If I go back to the portal here in VNet 1's peerings and click refresh, indeed I'll see that we've got our connection VNet 1 -VNet 2, which has a peering status of connected. There are various ways to connect to Azure services, and it's important to evaluate all of them and to plan the design of the appropriate solutions that meet business needs. So one type of connectivity is through an encrypted point-to-point network tunnel, such as a point-to-site or P2S VPN connection. That would be useful for users working from home, as an example. Or a site-to-site or S2S VPN, which would be useful to link an on-premises network to an Azure VNet, or you might even use an express route circuit, which is a dedicated network link, to connect an on-premises network to a VNet. So we have a number of options available then. Now with the site-to-site VPN, we have to have an on-premises VPN appliance. So whether it's a Cisco VPN appliance or Juniper systems, or whether it's a Windows server with routing and remote access services, RAS, it doesn't make a difference. You need an on-premises VPN configuration with a public IP address. Now from the Azure configuration perspective, because we have to create a resource in Azure, and that resource is a local network gateway. It just represents that on-premises VPN appliance. We configure the public IP with it. Now a site-to-site VPN is an encrypted IPsec VPN tunnel that uses an IPsec pre-shared key. You can either let Azure generate it, or you can specify it. Either way, same result would ensue. Now on the Azure side, you have to define a resource called a virtual network gateway. This is the VPN configuration on the Azure side that you control. So the local network gateway is the on-prem representation of the VPN appliance. The virtual network gateway, or sometimes it's called a VPN gateway, is the Azure VPN side of the equation. Now, why would you do this? Well, the benefit of a VPN is clear. You have an encrypted tunnel through which traffic is sent. So while it's traversing the internet, it's protected with the encryption of the tunnel. It also would let computers, for example, on your on-premises network communicate directly with Azure virtual machines. And the opposite would also be true through the VPN tunnel. So there's connectivity then between on-prem and Azure services. Then we have to think about routing, making sure that traffic knows to go through either the local network gateway, if we've got traffic leaving the on-prem network destined for Azure, or in the opposite direction, we've got to make sure traffic in Azure knows to go through the virtual network gateway to get to the on-prem environment. So how does that work? Well, let's say that we've got an Azure virtual machine that's transmitting to an on-premises resource. So what would happen is the traffic would be routed to the Azure virtual network gateway. Well, how would that happen? Because you would have a routing table entry configured that maps to the target destination network range used on premises. And when that traffic is encountered, the routing table entry would be directed to target that to the virtual network gateway. So then the traffic would cross the VPN from Azure, across the internet, to the on-premises VPN appliance. Now that on-prem VPN appliance needs to know what to do with that traffic. So the on-prem VPN appliance would then route that traffic to the destination. And the same type of thing would happen in reverse. So there's some routing configuration required to make these things happen. That's to be expected. There are some considerations when it comes to firewall rules for your on-premises VPN device. So you need on-premises perimeter firewall rules that would allow inbound traffic from the internet destined for your on-prem VPN appliance, which we're going to call VPN 1. So that would have to allow IP protocol 50, which is encapsulating security payload, or ESP for IPsec, and also UDP ports 500 and 4500. UDP port 500 is the first phase of tunnel negotiation and setting up the VPN tunnel itself, whereas UDP port 4500 is used with IP protocol 50 for encapsulating security payload. The other thing to consider is VPN 1 and its outbound traffic sent to the internet. So the source IP address of the VPN 1 appliance, of course, and IP protocol 50, and again, UDP ports 500 and 4500. Now, a point-to-site VPN, as we see in the left part of our diagram, references clients, individual clients that need to have a secured way to connect to Azure resources through an encrypted VPN tunnel. Now, those clients could be running Windows, Linux, Mac OS X, any type of those operating systems with the appropriate VPN client. And they would make the connection through an encrypted SSTP or IKEv2 VPN tunnel. SSTP simply stands for Secure Sockets Tunneling Protocol. Now, you don't need a local network gateway. There's not an on-premises VPN appliance required by clients, but you do need the virtual network gateway, which represents the VPN in Azure. You still need that configured for this connection to work. So this means that clients don't need a VPN device or a public-facing IP address, which you would need in a site-to-site VPN environment. Now, with point-to-site VPNs, you don't need that public IP. The client device authenticates to the Azure Virtual Network Gateway. That's the VPN appliance in Azure. And what you need to do is configure in Azure a VPN client address pool. This is a range of IP addresses that are available after VPN clients make a successful connection to the tunnel. And then the clients would get one of those IP addresses automatically. You can also configure PKI certificate authentication by uploading the root certificate public key to Azure, and then have the client device with the client certificate that authenticates to the VPN. In Azure, a point-to-site VPN, or P2S VPN, is used for remote workers that need an encrypted VPN tunnel to access Azure's services. In order for that to work, we need to first have created a virtual network gateway. I'm going to go to my All Resources view, and I already have one, but I'm going to filter out the type listing here. I'm going to click on Type, uncheck Select All, and I'm interested in virtual network gateways, so I'll turn that check mark on. The mere fact that that's in the list tells me there's one here in Azure. It's called Azure VPN 1, so I'm going to click to open that up. Now, if you don't already have one, you need to create a virtual network gateway, not a local network gateway, a virtual network gateway resource, and that can sometimes take up to 20 minutes to create. Now, in the configuration, any site-to-site VPN configurations would show up under Connections. And here I've got one, although it's got a status of not connected. But we're not here for a site-to-site VPN, we're here for a point-to-site. So I'm going to click Point-to-Site Configuration in the left-hand navigator. On the right, it says Point-to-Site is not configured, underneath which I have a Configure Now link. I'm going to click on Configure Now. First thing I have to do is specify an address pool of private IP addresses that will be dynamically assigned as we get individual VPN clients connecting to this virtual network gateway. I'm going to specify an IP address pool here that I want to use to allocate IP addresses to connecting VPN clients. So I'll specify 192.168.100.0/24. For the tunnel type, I'm going to choose IKEv2 and OpenVPN SSL. Now, depending on the type of VPN tunnel type that you select will determine options available down below. So in this case, I'm just going to go with IKEv2 and OpenVPN because I want to use a PKI certificate on the client device to authenticate here into Azure. So here on my Windows client device, I've already got a root certificate that was issued from a private or self-signed certificate authority, and a client certificate generated from that. I'm interested in the root certificate. I'm going to open that up so we can see the validity period. So we know that it's still valid as long as we haven't gone beyond the target date. So I'm going to right-click on the root cert, going to choose all tasks and export. Going to continue on through the wizard. I don't need the private key exported. I need the public key to complete the point-to-site VPN configuration in Azure. So I'll click Next. I'll choose base 64 encoded for X509 format and Next, and I'll specify a file name. So I'm going to put it on the root of drive D on my on-premises system, and the file is going to be called rootcert public key. Then I'll click Next and Finish, and it successfully exported the root certificate public key. If I open that root certificate public key file here in WordPad, this is what it looks like. So I'm going to go ahead and highlight the whole thing. And in this case, I'm going to select begin certificate and end certificate as well. We're going to see what happens. I'm going to go ahead and copy that to my clipboard. Back here in the portal, I'm going to call this root cert pub key down under the root certificate section. And over on the right in the public certificate data, I'm going to paste in what I've just copied. And when I click outside of it, it has accepted the root cert public key. Now, of course, we've got the client certificate on our device that was generated from that root cert, so we've got an authentication chain established. So I'm going to go ahead and click the Save button up at the top to save that configuration. Now, that was a little too quick. If I open up the notification bell, it says it failed to save the virtual network gateway config because of a certificate error. Well, remember how I copied the entire certificate, including begin and end certificate? That was the problem. So what I'm going to do is go back and select the root certificate public key, but I'm not going to highlight the begin certificate line or the end certificate line. So let's copy that again, and let's try this once again, a second time. So back here in the portal, I'm going to click the context menu, the three dots to the right of the public certificate data. I'm going to choose remove. We're going to do it again. Root cert pub key, but this time when I paste it in, it's only the required public certificate data. Everything else is the same on this page, so I'm just going to go ahead and click the Save button again. This time it's taking longer, which is a good thing. Now, if we go back into our bell notification icon in the upper right, we can see it's saved the virtual network gateway, which also means we can download a VPN client config file, which I will do. I'm going to click on that button. So you can then save this file on a local client device. That's going to give you a zip file that you can extract, which I've done, and then you get these folders for Azure VPN, generic, OpenVPN, and Windows for 64-bit and 32. I'm going to go into the Windows 64-bit where I've got a little VPN client setup file and executable. I'm going to go ahead and right-click on that and run that as administrator. Depending on your machine's config, will determine if it's allowed to run. I'm going to go ahead and choose yes to let it run. And so I'm then asked if I wish to install a VPN client for VNet 1. VNet 1 would be the VNet linked to my virtual network gateway where we configured the point-to-site client config. So I'm going to click yes. Now, if I navigate into my control panel where I've run that installation and go to Network and Internet, Network Connections, I will have a new network connection for VNet 1. Of course, I could go ahead and double-click on it to authenticate. Now I've got my VNet 1 VPN connection showing in the bar on the right, so I can go ahead and click on that to open it up. There's VNet 1. I can select it. I could even click on Advanced Options if I wanted to make any changes to its configuration, or I could then click the Connect button to make a connection to the Azure VPN. That opens up this screen where I could click Connect to complete the connection. After a moment, I will be connected. If I go to a command prompt and issue the ipconfig command on that same machine, I will have a PPP or a point-to-point protocol adapter. In this case, it's VNet 1, and I will have an IP address that was assigned from the IP address pool we configured within the virtual network gateway. So here in the portal, I've got a Windows virtual machine running, and it's got a private IP address of 10.0.1.4. Now that we've connected to the VPN, we should be able to connect to the private IP address. And I'm going to do that through Remote Desktop. So I've started the Remote Desktop Connection client. I've popped in the private IP address of that host. Let's go ahead and click Connect. I'll specify the credentials for that Windows VM and I'll click OK. And I'm just going to go ahead and authenticate. So we are actually making an RDP connection to the private IP address of a virtual machine running in Azure, which is only possible after having authenticated to the VPN. You would configure a site-to-site VPN to Azure to link an on-premises network to Azure. And so to get started here in the portal, I need to define a local network gateway, which represents the on-premises VPN appliance. And secondly, I need to define a virtual network gateway, which represents the Azure VPN appliance. Let's get started here in the portal by clicking Create a Resource. The first thing I'll do is search for local network, and then I'll choose Local Network Gateway, and I'll choose Create. So I'm going to need to know the public IP address of the on-premises VPN appliance. So if I don't have that information, I'm going to need to talk to somebody that does to complete this configuration. So for the name, I'm going to call this on-prem VPN 1. And for the IP address, let's assume I know it's 200.1.1.1. That's a public IP address. And the next thing I have to do is specify an additional address range. Now, this is going to be the address space used behind the VPN appliance on the on-premises network. So let's say it's 192.168.1.0/24. And I can add additional IP address ranges. I could also enable the checkbox for configure BGP settings, border gateway protocol, for route propagation, route sharing between these devices. However, I'm not going to do that with my configuration. I'm going to specify a resource group to deploy the local network gateway into, and the location here, let's say, is going to be Canada Central. So I'm going to go ahead and click Create. While that's happening, let's do the Azure side by defining the virtual network gateway. So I'll click Create a Resource. Once again, go to search for virtual network rather, and I'm going to choose Virtual Network Gateway, and I'll choose Create. So for the name, I'm going to call this Azure VPN 1. And for the region, now remember that not every service is supported in every region in Azure. So I'm going to scroll up and choose the region of my choice, which in this case is going to be Canada Central. That's where I want that defined. And then the gateway type is going to be set to VPN, but notice we could also define a virtual network gateway to link to Azure via an express route dedicated circuit. It's not what we're doing here. We're going over the internet with a VPN encrypted tunnel. I'm going to leave it on a route-based VPN type, and I'm going to specify the virtual network I want to link to, which in this case will be VNet 1. Now, VNet 1, that's what I'm linking my VPN to, needs to have a gateway subnet. And if it doesn't, it's going to create one and use the gateway subnet address range shown here, which was automatically selected. That's great. Let's let it do it. Now, we need a public IP address for our Azure VPN appliance, just like your on-prem VPN appliance has to have a publicly visible IP address. So I'm going to call this Azure VPN 1 _ pub IP. That's a pretty clear resource name as to what its purpose is. I'm not going to enable active mode for high availability of this VPN connection. And I'm also not going to enable BGP or Border Gateway Protocol autonomous system numbers. We're just going to use the defaults. So I'm going to leave that as disabled. And I'll click Next for tags. Now, when you talk to your on-premises network people, you'll know if you should be enabling these BGP options and what the value should be configured as. So no tagging information. I'll click Next, Review, and Create. And after the validation is passed, I will click Create. So we're now in the midst of creating a local network gateway as well as a virtual network gateway. So respectively for the on-prem VPN config and the Azure side of the VPN config. Okay, it can take up to 20 minutes or so to create your network gateways, but after that's done, you can go to the All Resources view and filter the type here for virtual network gateways and local network gateways, which I've done. Now, the next order of business is to link the two together so that we have a configuration to allow site-to-site connectivity from an on-premises network into Azure. So I'm going to go into the on-premises VPN configuration, that local network gateway config. I could just as well configure it in the virtual network gateway. It really doesn't matter which end we do it from. So I'm going to go into the on-prem VPN gateway, and I'm going to click on Connections in the left-hand navigator. And I'm going to click on Add over on the right to add a new connection. So the name will be Site to Site VPN 1. Down below, I have to link this local network gateway with a virtual network gateway. So I'm going to click to select one, and there it is, the one we created, Azure VPN 1. So I'm going to go ahead and select that. It adds it to the list. The local network gateway is already selected because that's where we came to do the configuration to begin with, so it already knows that. The next thing I'm going to do is specify a pre-shared key to be used to link the tunnels together, to establish the tunnel. Once I've put in a complex shared key, a pre-shared key, PSK, then I'm just going to scroll all the way down and click OK to set up the connection. Now there's a refresh button you can click on at the top here. I've got my site-to-site VPN 1 connection listed with the status of updating. Now until we configure our on-premises router accordingly for this connection, it'll never change from updating. We're never going to have a connection. So I'm going to click directly on that connection to open up its properties, where at the top, I've got a download configuration button. So from here, I can choose the device vendor for my on-premises VPN appliance. Let's say it's a Juniper appliance. I would choose the device family, the firmware version, and then I could download the configuration by clicking that same named button at the bottom, which I will do. I'll just save this locally on my on-premises machine. When I open up that downloaded config file, it is a configuration script file that can be used for our on-premises, in our case, Juniper type of VPN device. So all of the settings are stored within here. So this we would apply to our on-premises VPN appliance to complete the site-to-site VPN configuration. Azure Virtual WAN is a software-defined WAN, otherwise called SD-WAN solution. A traditional wide area network, or WAN, would allow you to interconnect different branch offices together, or even to link users working at remote sites to an office network. And that's really what this is. The difference being it's done through a software configuration, and it's done using the Microsoft Global Backbone Network. So it's essentially a global WAN solution that's used by enterprises. Now, there are many different spokes that can connect to the Azure Virtual WAN. It's a hub and spoke topology where the hub is the Azure Virtual WAN. Now, spoke types that can make the connection include VNets, point-to-site VPNs, site-to-site VPNs to link on-prem networks to Azure, and even ExpressRoute dedicated circuits. When you configure your virtual WAN, there are two primary types, standard and basic. So with the standard virtual WAN configuration in Azure, it'll allow connectivity for spokes such as point-to-site VPNs, site-to-site VPNs, ExpressRoute, and you can even interconnect multiple virtual WAN hubs together if you need that kind of global reach. Basic supports essentially site-to-site VPNs, that's it. Now you can upgrade if you want to after the fact from basic to a standard tier, but not in the other direction. You can't revert from standard back to basic. In our diagram, at the top we have two VNets, Azure VNet 1 and VNet 2, and they would be connected to the Azure Virtual WAN Hub. That's our software-defined WAN configuration that uses the Microsoft Global Backbone Network. At the bottom of our diagram, we've got two branch offices that might have site-to-site VPN links to our Azure Virtual WAN Hub. So we've got four spokes here in the form of VNets and site-to-site VPNs. Now, the key here is that the Microsoft Global Backbone Network is faster than if you just created your own WAN links between all of these different connections around different regions around the planet. So when it comes to connecting to services in Azure that are related to infrastructure as a service or platform as a service, this makes sense. Now, some other client-based services like Office 365, so software as a service, you're better off still just using internet connectivity for that type of purpose. The way that this works is that Microsoft has points of presence, or POPs, located around the globe to allow local connectivity to the Microsoft Global Backbone Network. Even if there's no local Azure data center there, you still have a network connectivity point or a point of presence. So when you configure the Azure Virtual WAN, the first thing you would do in Azure is create an Azure AD application and service principal to allow the configuration. That allows you to configure the virtual WAN. Now, what this means is that you would create a virtual WAN resource in Azure, but you also have to make sure that you have connectivity available with a local network access point provider, whether it's Arioka or some other local provider. Next, you would add a virtual hub and an address space, add the connectivity type for spokes, such as a VPN gateway link. Next, you would add a VPN gateway as a connectivity point for your spokes. And you would link the spokes to the hub, whether the spoke is a point-to-site connection or, for example, a site-to-site VPN connection. Depending on the network access provider that's allowing the connectivity, you'll have to connect to their web-based portal with the service provider to complete the configuration. And then you work with the service provider to complete the connection. The Azure Firewall is a managed service type of solution. And so that means we don't have to manually set up a virtual machine and configure firewall software and so on. So it's also considered to be a stateful firewall. Stateful firewalls have the ability to look not only at individual network transmissions, individual packets that are coming in or leaving to determine if it's allowed or not, but it has the intelligence to be able to look to see if there is a session, which could consist of many packet transmissions, to determine if something should be allowed or not. So we're really talking about using Azure Firewall to control inbound and outbound network traffic. Now, the Azure Firewall has to have a static public IP address, and it's part of the configuration. It also allows you to control traffic flow by configuring a variety of different types of rules, which we'll talk about in detail in just a minute. It also supports threat intelligence, so this can alert on and even actively deny traffic that looks suspicious. So you can configure Azure Firewall network rules. This is the first type of rule. Now, these can be based on protocols like TCP, UDP, ICMP, or you can be more broad when you configure it and just choose any. You can specify source and destination IP addresses, destination port numbers. So this would be useful if you need to control communications between subnets. And of course, you have allow or deny actions based on this. So this feels like a standard network security group, kind of like OSI layer 4, transport layer type of capabilities where it can look at IP addresses and protocol types and port numbers. Then you've got Azure Firewall application rules. This is for outbound connectivity, and it supports looking at fully qualified domain names or FQDNs. Now, this is above layer 4 in the OSI model because we're not limited to looking at packet headers. We're looking at the content of the request. You can even use wildcards, so you could use the asterisk to specify certain subdomains within a parent domain, or just an asterisk by itself for every fully qualified domain name. You can specify a protocol and port number like HTTPS:443. You can allow or deny it. So as an example, maybe I want to block social media from my employee base using Azure Firewall application rules. The Azure Firewall also supports rules related to network address translation. There are two variations on that. The first one is called Source Network Address Translation, or SNAT. So this is for outgoing traffic that will assume the public IP address of the Azure Firewall. So that's what most people think of when they think of NAT, Network Address Translation. But the second variation is called Destination Network Address Translation, or DNAT, which can translate a public IP address and port number to private internal IP addresses and port numbers. So it's kind of like IP address and port forwarding. What you're doing is protecting the true identity of the host on the inside. Yet you're still allowing connectivity to be initiated from outside. So in order to do this, in order to work with the Azure Firewall, you need to make sure that when you deploy into a VNet, that VNet has a subnet created called, all one word all together, Azure Firewall Subnet. Okay, so in this screenshot for Firewall NAT rules, we have an example of DNAT, Destination Network Address Translation. So what we have in the destination address field is the public IP address of the Azure Firewall. Next to that, we have the destination port. So this is the public IP address and port number being exposed out, let's say, to the internet that would allow connectivity. Then to the right of that, we have the translated or internal IP address and internal port number of a host. So this is Destination Network Address Translation, or DNAT. The other thing to bear in mind is that when we have our Azure firewall configuration in place, to finish that config, we need to have a route table entry. So subnet traffic then needs to be routed to the Azure firewall appliance. You simply build a route table if you don't have one already. That's an Azure resource, and a rule within it, maybe to capture all default route traffic of 0.0.0.0/0 for IPv4, and forward it to the private IP address of the Azure firewall. Now, when it comes to working with the Azure firewall, we know it needs at least one public IP address, but it can have up to 100. And that would be useful if you want to be able to support DNAT, or Destination Network Address Translation. Azure Firewall is essentially a virtual firewall appliance that you can deploy in Azure to control network traffic. To get started here in the portal, the first thing we should do in terms of a prerequisite is go take a look at our virtual networks. You need to deploy Azure Firewall into a resource group and a virtual network. Now that virtual network, in my case it's going to be VNet 1, needs to have a subnet in it called Azure Firewall Subnet. All one word, no spaces. So if I click the subnets link on the left here in VNet 1, over on the right, I can click the Add Subnet button to add my Azure Firewall subnet, because that's a requirement. So I'm going to go ahead and call it Azure Firewall Subnet. That's all one word. I'm going to leave the default address range that it suggests. I'm not going to configure anything else about it. Just going to click OK. So now I'm going to go to the home link, and I'm going to click Create a Resource. What are we creating? A firewall. So I'm going to search for firewall. I'll choose firewall from the resultant list. And of course, I'll click on the create button. I'm going to deploy this into an existing resource group, and I'm going to call this Azure FW1. So Azure FW1 for firewall 1. I'm going to specify a region here that I know where my VNet is deployed. So Canada Central. And I'm going to use an existing VNet. I'm going to select it from the list, VNet 1. And I have to either select an existing available public IP address to associate with the firewall. It has to have a static public IP, or I can choose Add New, which I'm going to do here. I'm going to call this Azure FW1 Pub IP. And I can't even select it from being static to dynamic. It has to be static. So that's fine. It's grayed out. No problem. Easy for me. I will then click OK. Then I'll click Next for tags at the bottom. Not going to add tags. Next, Review and Create. Validation has passed. So in the bottom left, I will click the Create button to deploy the Azure Firewall. But we're not finished, because we need to create firewall rules, whether they're NAT rules, network rules, application rules, or any combination thereof, within the Azure Firewall. Not only that, traffic needs to be routed through the firewall. So that means we're going to need a route table entry to make that happen. If I go to the All Resources view, I'll be able to see that I've got my firewall, Azure FW1, my Azure Firewall deployment. So I'm going to click on it to open up its properties. Now, there are three primary types of rules you can work with in here. In the left-hand navigation, if I click on Rules to open up the Rules blade, then on the right, I have links across the top for NAT rules, network rules, and application rules. So I could click the Add NAT Rule Collection to add a network address translation rule. For example, if I want to have a public IP address and port listening on the firewall that gets translated to a translated internal private IP address and port number. So I could specify that information. However, I don't want to do that. That would protect the true IP address and port number of my server. Could be a web application, for example. I could also go to Network Rule Collection and click Add Network Rule Collection. And it's very similar at this point to configuring a network security group rule based on things like a protocol and source and destination IP addresses, and also port numbers. So that's fine. We can do that as well. We can also configure application rules, and that's what I'm going to focus on. That's what makes this a little bit different than a standard network security group. Certainly the NAT rules do as well. So I'm going to click Add Application Rule Collection. This will allow me to look at fully qualified domain names and requests, such as for outbound traffic, of course. And in this case, I want to limit user access to social media. So for the name of this application rule collection, I'm going to call it Limit Social Media Access. I can specify a priority number, just like I would specify a priority number for rules within a network security group. So a priority value of 100 means a rule is checked before an item with rule 101. But having done that, that's fine. The next thing I have to do is determine whether I want to allow or deny traffic. I want to deny certain types of traffic. Down at the bottom under target FQDNs, I'm going to put in just Facebook as a name. For the source type, I could specify an IP address or an IP group. I'm going to leave it on IP address. I'm just going to put in asterisk. For protocol and port, I'm going to put in HTTPS://443. And for the target FQDN, I'm going to put in *facebook.com. I want to block access to anything in facebook.com. And I'm going to go at the bottom and click the Add button to add that application rule collection. If I click the refresh button, it won't take long before the application rule shows. So you can configure NAT rules, network rules, and as we've just seen, application rules, but none of it matters if you don't have a routing table entry to route to the private IP address of this firewall. Let's go to the overview blade for our Azure firewall. It's got a firewall private IP, so I'm going to go ahead and copy that, and I'm going to go to my All Resources view, and I'm going to filter by clicking Type at the top. I will unselect, select all, and I want to see route tables. So I'm going to click route table and click outside the list. Now I'm seeing our route tables, one of which is called route table 1. I'm going to click on it. Then in the left-hand navigator, I will click routes and I'll click the add button up at the top. I want to add a routing table entry. Basically, I want to force outbound traffic from a specific subnet. We'll deal with the subnet association after, but I want the traffic to be forced through my Azure firewall appliance first for inspection. So the route name is going to be, let's say, send to Azure FW1. The address prefix is going to be all traffic, 0.0.0.0/0. So that's the default route in IPv4. And the next hop is going to be a virtual appliance. And the next hop address, I'm just going to paste in the private IP address of our Azure firewall, not the public, the private one. Then I'll click OK. The next thing I need to do is click on Subnets. I'm still in the properties of the route table to ensure that it's associated with one or more subnets that I want it to be associated with. Otherwise, I could click the Associate button. So therefore, I've got it associated already with the subnet called Subnet 1 in VNet 4. So any virtual machines deployed in that subnet, in other words, where their network interfaces are in Subnet 1 and VNet 4, will have their outbound traffic first sent through our Azure firewall. Microsoft Azure ExpressRoute provides a dedicated network link from your on-premises network directly into Azure. Now that might sound a lot like a site-to-site VPN, and I guess it does, but what's different is that the traffic does not traverse the internet. It's a dedicated private network link, as opposed to a site-to-site VPN, which traditionally does go over the internet. Technically, you could have a site-to-site VPN through your Azure ExpressRoute circuit as well. So with ExpressRoute, it links your on-premises network to an Azure VNet and Azure public IP addresses, even to Office 365 or services like Dynamics 365. You can also provision more than a single ExpressRoute circuit. Now, you would do this in some cases if you've got services that are spread out across multiple geographical locations. Now, when you configure Azure ExpressRoute, which you can do directly in the portal, you get a circuit GUID, which is a service key. And the key, for example, would look like a long code with letters and numbers separated by dashes. So that would be what would be used to set up the circuit with the service provider. So you can have from 50 megabits per second up to 10 gigabits per second for an individual circuit. And these details are changing all of the time. So how do we set this up? You create the ExpressRoute resource in Azure. You provide the service key to the network connectivity provider in your region that supports ExpressRoute. Then, after they do their configuration, the provider status will change to provisioned, and then you can configure things like network peering to continue on with the configuration. Now, you've got ExpressRoute Direct and also ExpressRoute Global Reach as additional connectivity options. So, ExpressRoute Direct allows you to configure dual 100 gigabit per second links. So, it's still a private, dedicated network, but it does require an enrollment email that you would send to Microsoft. Next, you would have to specify the details along with that email, like your subscription ID and locations where you want this connectivity. You also have the global reach option, which links multiple ExpressRoute circuits together. The purpose here is to form a private network between your on-premises networks, except it's going ExpressRoute through Microsoft's global network. So in other words, to interconnect your office locations around the world. In this demonstration, I'm going to go through the steps that would be required to configure an ExpressRoute circuit here in the portal. To get started, I'm going to click the Create a Resource button, and I'm going to search for Express, from which I'll then choose ExpressRoute. Then I'll click on the Create button. The first thing I have to do is specify a circuit name. I'm just going to call this Circuit 1, and I have to choose a partner or provider provides the local network access point that would allow connectivity directly into the Azure cloud. So for example, if I were to scroll down the list, let's say, and I'll choose Bell Canada, because that's where I'm located, I could then look at the peering locations based on that provider. For example, Montreal. Then I could select the bandwidth. So maybe, for example, I'll just leave it on 100 megabits per second. And I'm just going to scroll down and deploy this into an existing resource group, and then I'll click Create. After a moment, if I go to my Bell notification icon in the upper right, I'll see that the deployment succeeded, so I'll click the Go to Resource button. That's going to open up the properties of our ExpressRoute circuit resource. The key here is to note on the overview blade on the right that the provider status is currently reporting not provisioned. If I go to the Properties blade, so by clicking on Properties in the left-hand navigator, on the right, one of the properties I have available is the service key. Now, normally, to complete the provisioning of the ExpressRoute circuit, you would have to go to the network provider's web portal and sign in, if you don't already have an account, and then specify this service key to continue the provisioning process. After which, when you go to Connections, you'll be able to click the Add button. It's currently unavailable because the circuit is not yet provisioned. A network security group, or NSG, is an Azure resource that really is a collection of firewall rules. It's an ACL, a firewall access control list, that determines what traffic is allowed in or out, or it could even deny specific traffic. So here in the portal, I'm going to create a network security group. I'm going to start by clicking Create a Resource in the upper left. Now, you should plan this ahead of time because you might realize that you have a collection of virtual machines that have the same inbound and outbound network traffic requirements. And so you might want to put those on a subnet, create a network security group with the appropriate rules, and then link the network security group to the subnet, which in turn would apply to all the virtual machines deployed in that subnet. So to get started here, I'm going to search for network security group. I will choose it from the list, and then I'm just going to go ahead and click on Create. I'll specify the resource group I want it deployed into, and the name here, I'm going to call this Windows Standard NSG, something like that. And for the region, I'm going to deploy this, in my case, in the Canada Central region, where I'm deploying most of my resources. Then I'll click Next for tags. I'm not going to add tagging information. I'll click Next for Review and Create. After the validation has passed, as shown in the upper left, I'll click on the Create button. So I'm creating the network security group, but what I'm not doing yet is creating the rules. I have to go into it and add the rules after it's created. It's only going to take a second here to build this. Once the deployment is complete, I will click the Go to Resource button, which takes me into my network security group's properties. In the left-hand navigator, I'm going to click Inbound Security Rules, where I'm going to see some default rules. Each rule is listed here with a priority numeric value. So for example, priority 65,000 means that rule is checked before rule 65,001, which is checked before rule 65,500. So in this case, for inbound traffic, each rule is processed in the order in the list based on the priority number. So priority 1 would get checked before priority 100. When there is a match, if the traffic matches one of the rules, then that rule is applied and no further rule checking occurs. So we can see there's a name column for the rule, port number, protocol, the source of where it's coming from, whether it's coming from another virtual network or an Azure load balancer or from anywhere, the destination, and then the action, which is going to be either to allow the traffic or to deny it. Now I can click the default rules button at the top so they're removed from the list. Well, removed visually, they still exist and they're still active, but it's a toggle button depending on whether you want them listed or not. The same goes for outbound security rules. So there are outbound rules to allow VNet outbound traffic, allowing internet outbound traffic, and then denying everything else. So the same type of thing applies. We have a default rules toggle button to display or remove from display those default outbound rules, and they all have priority numbers that work in the same manner as we discussed for the inbound rules. Now, if I go back to inbound rules, I want to create one. So we've got the default, which is fine. I'm going to click the add button up at the top. Because this is for Windows, I want to make sure port 3389 for Remote Desktop Protocol, or RDP, is allowed. So for the source, I could choose any from anywhere or specify IP addresses, an Azure service tag, or an application security group. You can think of an application security group as really being a group of virtual machines used to support an app. And so you could specify them essentially as one unit instead of their individual IP addresses. In this case, I'm going to leave it on any. Same with the source port range. It's got an asterisk for any. The destination can be a specific IP address, a virtual network, or again, an application security group. I'm going to leave it on any. And the destination port range, it could be one or more port numbers, in this case, just 3389. I could specify the protocol. I could leave it on any, or I could choose TCP, UDP, or ICMP. The action, whether to allow or deny the traffic, I want to allow it. The priority number. This priority number is important because it controls the order in which the rules within the network security group are checked, and a name for it. I'm going to call this allow inbound RDP, and then I'll click the add button. So after a moment, we're going to have our allow inbound RDP rule added to the list. We have a little yield symbol because we are allowing a source from anywhere, any. So what we could do is open that rule back up, and to tighten it down a little bit, we could change where traffic is allowed to come from. For example, even by IP addresses, we could specify a source IP addresses or an address range. So for instance, if I know that technicians will be using VMs that they have a connection to already in Azure to RDP into other ones, then we could specify a range. So for example, I'll just specify an IP address range. Of course, we got to make sure that it's formed correctly. And I'll leave everything else as it was. This time I'll click Save. Now this time when I save the rule will still appear in the list as it did previously, but we've lost our little yield symbol because we have a specific source as opposed to just from anywhere. So that's the process that we would go through to add rules using the GUI for inbound and outbound purposes. However, all we've got is a network security group, the default inbound and outbound rules, and one custom rule we've added. Until you associate it with either a network interface, which by extension is linked to a VM, or when you associate it with the subnet, until you do that, it's not in effect anywhere. So you could assign this to specific network interfaces for VMs, but it's easier on a more broad scale for management to specify a subnet where you've got VMs in that subnet that have these needs, the need to allow inbound RDP, for example. So I'm going to click on subnets. Just like if you clicked on network interfaces, you have to associate it with a subnet. So I'm going to click associate, and I'm going to go through and select a virtual network. let's say VNet 3, and a specific subnet that I want this network security group to be associated with, and I'll click OK. So this means that all the virtual machines in my example in subnet 2 within VNet 3 will have this network security group association. So it will allow inbound RDP traffic from the specified source. You can use the Azure CLI to create and manage network security groups. So to get started here in the portal, I've already launched the Cloud Shell. So to create a network security group, I'm going to start with AZ network NSG create -G. I want to put this in a resource group called East RG1. Add a space after that, -N for the name, and I want to call this network security group app3 _ firewall _ rules. So you have to have planned how many of these network security groups you're going to need, which security rules will be within them to control traffic flow, to allow or deny traffic, whether you're going to associate them with subnets and network interfaces, and so on. So let's go ahead and create this network security group. After which, we're going to check our work. We're going to list network security groups to make sure it shows up in the list. We can do that with AZ network NSG list, but if I leave it like that, it's going to bring back all of the properties, which is hard to look at. So instead, what I'm going to do is add -query, open and close square bracket, .name. Now there's a space between query and the open square bracket. This way, I'm only seeing the names of the security groups. And here we see app3 _ firewall _ rules. Now, the next thing we need to do is create one or more rules within the network security group. To do that, I'm going to run AZ network NSG rule create -G for the resource group -NSG name to specify the name of the network security group I want to add the rule to. I'm just going to change it here to make sure it's correct. It should be app3 _ firewall _ rules -N for the name of the rule. I'm going to call this rule 1 -- priority. I'll set to a value of 500. This determines the order in which the rules are assessed. -- source address prefixes. So where do I want to look at the traffic source? Where's it coming from? In this case, I'm going to use the keyword internet. -- destination port ranges. I've included ports 80 and 443 separated by space. -- destination address prefixes. I'm going to specify here as just an asterisk. So looks like I've got a little typo in here. Now the asterisk needs to be within single quotation marks, which means any destination address. Now the rule can either allow or deny. In this case, -- access is set to allow. -- protocol parameter set to TCP, and -- description. I've provided a description within the open and close double quotation marks. So I'm going to press enter to create this rule within our network security group. It doesn't take long before the provisioning state is returned with the value of succeeded. So we can also view this information after the fact by typing AZ network NSG rule list. I'm going to specify -G. East RG1 is the resource group where the network security group was deployed. -NSG name is app3 _ firewall _ rules. And if I press enter, it will list out any rules within that network security group. As I scroll back up to the output, it is reflecting our configuration with the priority of 500, the rule name of rule 1, the destination port ranges of 80 and 443, and so on. In this demonstration, I'm going to use PowerShell to create a network security group and then create a rule within that security group. So to get started, I've launched Cloud Shell in the portal. I could just as well be using PowerShell on premises. It makes no difference, other than on premises I'd have to first connect to my Azure account to authenticate. So I'm going to use the new -AZ network security rule config commandlet to create the rule and store it in a variable called $RDP _ allow _ rule. So after new -AZ network security rule config, the name parameter, I'm going to call this allow inbound RDP. That's the name of the rule. -source port range will be an asterisk, any port. Dash protocol will be TCP. Dash source address prefix will be internet. That's a keyword. Dash access is going to be allow. Dash priority is 110. Dash direction is inbound. And dash destination port range, in this case, will be 3389. Dash destination address prefix will be asterisk. Now, you want to be very careful with this kind of a rule if you're allowing access from the internet to something like port 3389. You certainly don't want to do that on a production server. You might do it on a sandbox server, and certainly you might do it if you're setting up a honeypot where you want to essentially lure malicious activity to this host and then monitor it. I'm going to go ahead and press enter to build that rule. But the rule itself doesn't do anything. It needs to be in a network security group. We could use an existing one, or we could actually create a new one. I'm going to create a new group. To do that, I'm going to use the new -AZ network security group commandlet -name. I'm going to call it serve rules 1 -security rules. Now, this is going to be where I'm going to reference my variable from above, the $RDP_allow_rule variable. -resource group name, ESTARG1 -location. I'm going to set that to Canada Central for the new network security group. Let's go ahead and create that. Now, that should only take a moment, and the rule will have been created within that new network security group. I'm just going to minimize the Cloud Shell, and why don't we just go to our All Resources view here. I'll just refresh that. I want to check out our newly created network security group so that we can see if the rule is created within it. So as I scroll down, we'll eventually come across in the S's the Serve Rules 1 network security group. If I open that up, not only will we see the default inbound security rules when we click inbound security rules on the left, but we should also see that we've got our allow inbound RDP rule configured according to our PowerShell statements. So in this course, we've examined how to configure Azure network connectivity and security using VNet peering, VPNs, ExpressRoute, Azure Firewall, and network security groups. We did this by exploring when to peer VNets together, how to use the portal, CLI, and PowerShell to link VNets using peering. We looked at the use of VPN solutions in Azure and how to configure a point-to-site as well as a site-to-site VPN connection. We looked at the benefits of using Azure Virtual WAN. We looked at the security problems addressed when using Azure Firewall and how to deploy and manage Azure Firewall, and how to enable ExpressRoute circuits. We looked at when to use ExpressRoute, and finally, how to use the portal, CLI, and PowerShell to manage network security groups and rules. In our next course, we'll move on to explore Azure storage accounts for cloud storage and key vaults for centralized storage, including their deployment and management. One factor that can feed into the design of your Azure storage solutions is compliance with laws and regulations, which can also feed into data residency, such as ensuring that data is stored in a specific geographical region. Now in Azure, we have storage accounts, which can serve as a storage facility, but also we have database solutions and key vaults. With storage accounts, we can store blobs, binary large objects, which are essentially files that might be stored there as a result of being used on a website or by users uploading them. There are NoSQL tables. Now in a storage account, when you build a table, it's a NoSQL table, but it's a basic key attribute store. You also have the option, and this would be of interest for developers, of building message queues to store messages transferred between software components. And then there's Azure Files, which serves as shared folders stored in the cloud. You can use Azure File Sync as an on-premises appliance to make the contents of those shared folders in the cloud available on-premises, and any changes would be synced back into the cloud. Server-side encryption is enabled automatically with Azure storage accounts, although using Microsoft managed keys. There are a couple of database solutions available in Azure, one of which is Azure SQL Database as a managed service, meaning you don't have to worry about the manual deployment of the virtual machine and the manual installation of the database software. Transparent data encryption, or TDE, is supported for protection of data at rest. Then we've got Key Vault resources that we can build in Azure. A key vault you can think of as being a centralized storage location for secrets. Secrets being things like PKI certificates, database connection strings, passphrases, that sort of thing. Now, when we plan out our Azure storage environment, we have to think about what we might already be running on premises and how it might map to an equivalent solution in Azure, especially when it comes to a hybrid solution. An example of this would be, as we previously mentioned, Azure Files. This is a shared folder in the cloud. Well, if you already have on-premises file servers, this would be an equivalent that you could run in the cloud. And in a hybrid environment, so linking our on-prem network to an Azure environment, we could use the Azure File Sync service to make shared folders in the cloud available to on-prem clients. Then there are RBAC roles, role-based access control, such as storage account contributor, storage data blob contributor, storage queue data sender, SQL DB contributor, to name just a few. Now, these roles can be assigned to users or groups, Azure Active Directory users or groups, and they can apply to a scope, like the entire Azure subscription, perhaps just a resource group or a single resource. As you might imagine, these give different levels of permissions. So the storage account contributor gives access to an entire storage account, whereas the storage blob data contributor would allow only the reading, writing, and updating of blob items within a storage account. Storage queue data sender would allow the writing of messages to a storage queue, and SQL DB contributor would allow full management of SQL databases, but not access to the content stored within them. Every storage account in Azure comes with 2 access keys by default. You can keep one as it is while you refresh the other one. It allows for periodic key rotation, but you can use either of those 2 access keys to gain full access to the storage account. Then there are shared access signatures. This allows limited access to a storage account. And what I mean by that is perhaps only access to read, let's say, blobs in the storage account, and it can also have an expiration date and time. Another consideration is storage account lifecycle management. We can create data retention policy rules and actions that might move blobs after a certain number of days since they were last modified. For example, we might move blobs after 30 days and no activity, so after modification, to cool storage to save on costs. We might also move them into longer-term archiving storage for even less cost. We can also configure blob snapshot deletion a specific number of days after the blob was created. When you configure storage account lifecycle management, you've got data retention policy rules and filter sets. Now, you can filter by container or by blob. So if we want to, for example, move items to archive storage after a period of time, we might filter it by certain containers or by certain types of blobs, by file names, in other words. Then we've got Azure Key Vaults as yet another storage solution in the cloud. This is not within an Azure storage account. It's a separate type of resource. So we said it was the centralized secure storage of security items. Now, what's interesting is that access to these secrets in the Key Vault, let's say access to a passphrase and a database connection string, is possible using managed identities. Now, a managed identity is an Azure Active Directory item that can be assigned, for example, to an entire virtual machine. And so whatever code is running in that virtual machine would have access to something in the Key Vault, as opposed to writing credentials into your code itself. That's what managed identities are for. It prevents you from having, as a developer, to put credentials within your code. We also have Key Vault policies that determine which entities are authorized to perform specific tasks in the vault, such as the creation of PKI certificates versus the reading of passphrases and so on. FIPS-compliant HSM support is also available in a Key Vault. FIPS stands for Federal Information Processing Standards, and this is used by basically American government contractors to ensure a certain level of security. HSM is Hardware Security Module, so you can use FIPS-compliant HSM support to securely store keys and items in the Key Vault. This is as opposed to using software protection. So the secrets in the Key Vault then can be imported, they can be restored from a backup, or you can generate them directly in the Key Vault, including generating PKI certificates, so secrets, keys, and certificates. Much like planning the use of Azure virtual networks, with Azure storage accounts, one consideration is how many storage accounts will be required, how they will be used, and the location of them in terms of geographical region. We have to think about the types of items that we can store within a storage account, like blobs, Azure files, which are shared folders in the cloud, tables, and queues. We might have a storage account that stores all of those types of items, or we might spread it out across multiple storage accounts. For example, if we have a need for blob file storage in the eastern part of the United States, we might have a storage account for that purpose deployed in that region. But on the West Coast, if developers need message queues for software components that will be used only in that location, it might be better to have a separate storage account deployed in the West region for that purpose. Then we have to think about replication for high availability, so that if we have a regional outage, it makes sense to have important data having been replicated previously to another secondary region that we could then use to access that data. Storage account replication is configured either when you create the storage account or at any time thereafter, but the account kind and the region determine available replication options, and this you'll see as you're creating a new storage account. So we have the drop-down list in this screenshot for replication opened up with all of the replication options available, like locally redundant storage or LRS versus geo-redundant storage, GRS. We'll talk about all of these in a moment. But the point is this. When you look at some specific locations, when you select a location like Canada East, you might only have a subset of replication options available compared to what you might see when you choose West US. So storage account replication comes in the form of locally redundant storage. This is one possible option, LRS. This means that you get 3 copies of the data in the storage account replicated, but within a single physical location. Zone redundant storage, or ZRS, means you have 3 copies of data across 3 availability zones. In Azure, an availability zone, or AZ, exists within an Azure region. Every region has at least one availability zone, usually more than one. And these availability zones are used for replication purposes, for zone redundant storage. Now, it's not to say that every availability zone is one data center, because that's not quite the correlation. The other type of replication is geo-redundant storage, or GRS. So after locally redundant storage occurs, data gets copied using asynchronous replication to a secondary region. Asynchronous replication means only after the initial write in the primary region occurs does the copy begin to the secondary location. We've then got geo-zone redundant storage, GZRS. So this means zone redundant storage occurs first, then async replication to the secondary region. Next, we have read access geo-redundant zone storage, or RA GZRS. So the secondary region then is readable without even initiating a failover at all. With storage account replication, in step number 1, a user or an application would write to primary storage in the primary region. So they're writing to a storage account. Now, that primary region storage would then allow for locally redundant storage, for example, LRS. So we have 3 copies of the data in that region. Next, we would have replication configured to replicate to a secondary region. Now, that would only occur asynchronously after, in the primary region, LRS, or locally redundant storage, has completed. In the event of a disruption in some way of the primary region, the secondary copy of the storage account would then become the primary. So we could initiate a failover to make that happen. So really what happens to make this redirection possible is some changes in DNS records. So this means that as a cloud customer, you would enable failover to the secondary region. So in other words, the secondary becomes the new primary. Now, as you allow access to the secondary region over time, if you want to, you can configure replication on the secondary region, which is really now, we're going to call it the primary, and enable geo-redundancy back to the original primary region, which now would be the secondary. I know that sounds strange, That's how it could work if you want to enable replication after the initial failover. Storage is a very important part of cloud computing. In this demonstration, I'm going to use the portal to create an Azure storage account. So you have to have first thought about how many storage accounts you'll need, in which regions, and what they will be used to store. So to get started, I'm going to click Create a Resource in the upper left, and I'm going to search for the words Storage Account. Then I'll choose Storage Account from the list, and of course, I'm going to go ahead and click on Create. I'll specify the resource group that I want this deployed into, and I'll follow organizational naming standards. You should have a standard naming convention so that it's easy to determine when working with lists of resources like storage accounts, what is what. So I'm going to call this Store Account Abbreviated, YHZ for my airport code, and then numbers to make it unique. For the location or the region, in my case, I'm going to place this one in Canada Central. That's where I want my storage account. Now, the default performance type is set to standard. However, I could also choose premium. Now, notice what's changing down below. With the standard type of storage account, for the account kind of storage version 2, you have the cool and hot access tier. Hot is enabled by default. The cool access tier uses older disk technology, which is slower and is designed for less frequent access, and so it's cheaper. But if you need frequent access and you want it to be timely, then you should be using the hot access tier. From the account kind drop-down list, I can also choose, for example, blob storage. When I do that, I can scroll down and I still have my cool and hot access tiers. However, I can't change from standard to premium. It's stuck on standard. Then I have the replication type. Now let's go back to where we started, meaning I'm going to set the account kind to storage v2. When I do that, I also have the replication option down below. Replication would be to keep copies of the contents of the storage account elsewhere. The default is locally redundant storage, or LRS, to have 3 copies within a physical location. Then geo-redundant storage to replicate the storage account contents after LRS occurs to a secondary region. We can also have read access geo-redundant storage to have a readable secondary replica that's always readable. You don't have to initiate failover. But those are the only 3 items I see. Well, I thought there were more replication types. There are. The reason that we're having a limited list here is because of the location of the region. And be aware of this in Azure. Not every option, every feature is available in every region. You might see a distinction when you are working in one region versus another, and that's normal. It's to be expected. So if I were to change, let's say, my region from Canada Central, why don't we put it on East US? And let's just take a look at the replication. Oh, it's a bigger list now. So we have the standard stuff we mentioned, like LRS, GRS, read access GRS, but we've got zone redundant storage, geo-zone redundant storage, read access geo-zone redundant storage, many other options. So be aware of that affiliation with the region and the options that will be available. However, I do want to go back and specify Canada Central here. Now, I don't have a need at this point for having a copy stored in a secondary region. So I'm going to leave it on LRS. You still have 3 copies within one physical location. However, it's important to understand that if there is a disruption or a failure in this region, Canada Central, then you won't have access to the contents of the storage account. You can always come back and change the replication options after you've created the storage account. It's not a problem. So I'm okay with these options. I'm going to click Next for networking. We can determine if we want this storage account to be accessible to all networks or selected networks. We can go down and choose that, or we could configure a private endpoint. I'm just going to leave it on its default of public endpoint if that's what our needs dictate. For example, if we are allowing access to some documentation to the public for our products or services that are stored in this storage account. I'll click Next for advanced. Here we have a number of options, such as whether we want to enable options like blob soft delete, it's disabled by default, or versioning, also disabled by default. Blob soft delete is an option, as you might guess, that allows you to recover or undelete deleted blobs. Versioning stores multiple versions of blobs. You can configure those after the fact as well. You can also enable a hierarchical namespace for data lake storage. That's disabled by default. I'm going to leave it as such. I'll click Next for tags. Not going to add tagging information, so I'll click Next, Review, and Create. The validation has passed. So to create the storage account, I'm simply going to click the Create button in the bottom left. It won't take long before the deployment is complete, so we can check out the storage account either by clicking Go to Resource. Of course, what we could also do in the left-hand navigator is open up that navigator, and then we could scroll down and click Storage Accounts. There are many ways that you can get to it. We could actually also go to the All Resources view, couldn't we? And then filter it by storage account types. So I've got a new storage account that I've just created shown here called Store Account YHC456. When you're looking at the storage account view, you'll see the storage account kind, in this case storage v2, the resource group it was deployed into, and the location as well. I'm going to click to open up that storage account. In the overview blade of the storage account, if I scroll to the right, then I have a reflection of my configuration options, such as whether it's a hot access tier, which it is, the replication type, which is locally redundant storage, the account kind, and so on. If I scroll down in the navigation bar on the left, I can also click Configuration. Remember we said that you can change the replication configuration for a storage account after the fact if your needs change over time. So the replication drop-down list currently reflects locally redundant storage, but from the list, we'll be able to choose other options like geo-redundant storage or read access geo-redundant storage. Remember, the other replication options are not shown because of the region this account was deployed into. If I click Access Keys over on the left, what's noteworthy here is that there are two access keys with every storage account. You have a key and a connection string, so two of each. And the purpose is to allow access to the entire storage account, such as for developers writing code. You also have the option of regenerating the keys. There's a regenerate icon. You would do that periodically on one key while keeping the other one as is for security reasons. You would basically rotate the keys over time. Notice also, if I go to the encryption item in the navigation bar on the left, that by default, encryption is already enabled using Microsoft Managed Keys for your data at rest in your storage account. If I scroll down further in the left-hand navigation bar, then I'll come across the point where I have blob service, binary large objects, essentially files that you want to upload and store in your storage account. You can build containers, which are kind of like subdirectories or folders on a disk to organize files. I can also go further down in the left-hand navigation bar under File Service. Azure Files allows you to build file shares, shared folders like you might on premises to allow people to map or mount to that over the network. We've got a simple table service here inside the storage account. The tables we're talking about here really simply allow you to make a table definition for a key value type of NoSQL document store. You've also got queue service queues. These are message queues developers might be interested in that software components they build will use to communicate amongst one another. So there you have it. We've deployed our storage account in the Azure portal. You can use PowerShell to create and manage all aspects of an Azure storage account. To get started, here in Cloud Shell, I'm going to use the new -AZ storage account PowerShell commandlet. With -resource group name, EastRG1 is the resource group I'm going to deploy the account in. -name, I'm going to call this store account 64845. -location is Canada Central. And -SKU name, I'm going to use standard_LRS. That's for the replication type, and I can change that after the fact. So I'm going to go ahead and press Enter to create that storage account. After a moment, we'll have some returned messages that indicate that it succeeded. The account was created. To retrieve a list of storage accounts, I can run get-az storage account. So this will give me a listing of these storage accounts. I'll see the name, I'll see the resource group that the account was deployed into, the primary location or the Azure region, the SKU name, whether it's using LRS for locally redundant storage, or as in another case here, read access GRS for geo-redundant storage. All of this information is returned when we run the get-az storage account commandlet. Now, what we can also do is use the get-az storage account key to return the keys that are stored within a storage account. Every storage account has 2 access keys that are used to provide full access to the storage account. This would be very useful when using some command line tools, even some GUI tools like Azure Storage Explorer, and even in some cases when writing code to gain access to the storage account. So get-az storage account key resource group name is E*G1, in my case, account name, and I'll give it the name of the storage account whose keys I am interested in returning. And it will return key 1 and key 2. We can also take a look at other properties of a storage account. For example, if I were to run get-az storage account, and as usual, I'll use -resource group to specify the resource group, -account name for the name of the storage account. If I pipe that to select, I can tell it I want to see only specific properties. In this case, I want to see the access tier property. So what we're getting returned here is for the named storage account, the access tier is currently set to hot. Well, we can also use PowerShell to modify properties such as that. So in other words, I want to change the hot access tier to cool. To do that, I can use set-az storage account. So I'm going to specify the resource group name. So I'm just going to modify that. In this case, the resource group is called East-RG1, -account name with the name of the storage account. And then I just use the -access tier parameter. And in this case, I'm going to pass it a value of cool. It asks me to confirm it. I'm going to press the letter Y for yes. Now I'm just going to clear the screen, CLS, and I'm going to use the up arrow key to go back to the get-az storage account statement where we were piping it to select and asking only for the access tier for that account. And this time it returns cool instead of what we originally saw returned, which was hot. Finally, the last thing we should know is how to remove it. So we can use the remove -az storage account commandlet, -account name, and give it the name of the storage account, -resource group, give it the resource group, and I'm going to use -force so we're not prompted to make sure that we want to confirm this action. And after a moment, it's done. The storage account is removed. You can use the Azure CLI to create and manage storage accounts. To get started, I'm going to run AZ storage account -h for help. What would the next level command be? Well, by reviewing the help, it would seem that create would follow that logically, because we want to create a storage account. Okay, so I'll use the up arrow key to bring up my help command, but I'm going to add create before the -h for help. Let's take it the next step further to see what we could do in terms of syntax. So we have some syntax examples at the bottom of the help screen, and as we go up, we'll see all of the parameters that we could specify in the command line and what kind of values that they might expect. So as I go up far enough, I'll eventually come across, for example, --SKU, where I can specify the replication type, like LRS for locally redundant storage or GZRS, and so on. So having done that, we now have a sense of what we can do syntax-wise to get this done, to create a storage account. So we're going to do that with AZ storage account create -n for the name, and then I'll specify the name of the storage account, which must be lowercase letters. Can also include numbers, as mine does. -g for the resource group, -l for the location, in this case Canada Central, and then --SKU. We saw that in help. I'm going to specify standard _LRS. I'm going to press enter to create that storage account. After a moment, we'll have some output where the provisioning state is set to succeeded. I'm going to clear the screen with CLS, and now I'm going to list storage accounts. I'm going to do that by typing AZ storage account list, and I'm going to run --query as a parameter, followed by a space, followed by open and close square brackets, .name. So I want to see the name property for all returned storage accounts. That's all I want to see, nothing else. And I have a listing of all of the storage accounts, including the one that was just created. So that is shown in the list. Now we can also ask for specific details for a storage account using the AZ storage account show syntax. So I'm going to specify -n for the name of the storage account, and I'll specify the name of it. And after I'm done that, I'll specify -g for the resource group. I'll specify that, and I'll press enter. So when I do that, if I scroll back through the output, I have access to all of the details within that storage account, its configuration. So listing will list all of the storage accounts, whereas if you want to zoom into a specific storage account and get some of its details, you would use show. You can enable storage account replication through the Azure portal, either as you're creating a storage account or after the fact. If we were creating a storage account, such as by clicking Create a Resource, and then by searching for Storage Account, and then selecting that and choosing Create, we would have the option of specifying upon creation whether or not we want replication and which type of replication. On the first page of the wizard, the basics page of the wizard for creating a new storage account, if I scroll down, I have a replication drop-down list where I can open it up and select, in this case, from LRS, locally redundant storage, where we get 3 local copies, geo-redundant storage, which replicates to a secondary region, and read access geo-redundant storage, which replicates to a secondary region, but we always have read access to the secondary copy of the storage account, even without initiating a failover. But there are only 3 replication options here. Well, let's take a look at our location. It's set to US, West Central US. What if I were to change that, say, to East US, and then open up the replication drop-down list? Then I get additional options like zone redundant storage. So depending on your selection of the region or location will determine the replication options available. Now that's for creating a new storage account, which I'm not going to follow through with. So I'm going to click the X in the upper right. I'll click OK. When it informs me, my unsaved edits will be discarded. Let's take a look at an existing storage account. So I'm going to click to open my left-hand navigator, and I'm going to go down and click in that navigator on storage accounts. Let's open up an existing storage account. When you open up an existing storage account and you're in its properties, you can scroll down in the navigation bar to configuration. That's where you want to go to view or change the replication setting for the storage account. In my case, in the right-hand panel, the replication is currently set to locally redundant storage. Now, if I were to click on geo-replication in the left-hand navigator, in the right-hand panel, that'll present me with a map of the world. And in the map of the world, I've got one blue pinpoint down at the bottom in the legend. That's for the primary location, which in this example is for Canada Central. There is no secondary. That's because currently it's set for locally redundant storage. Let's go back to configuration on the left, and we're going to change up the config of the replication. So from the replication drop-down list, I'm going to choose geo-redundant storage. Then I'm going to click Save up at the top, and we'll give it a moment. Then I'm going to go back to the geo-replication blade by clicking geo-replication. The map looks different. We used to have a single blue pinpoint for the primary region, but now we have a second green pinpoint, which in the legend is for the secondary location. Here it was selected as being Canada East. So this is how we can enable this in the portal. Up at the top, we do see that the replication reflects our current configuration, geo-redundant storage, GRS, and there is no listed last failover time because the account was never failed over. PowerShell can be used to modify storage account replication settings. Before we go ahead and check that out in PowerShell, here in the portal, I'm going to open up an existing storage account. Now, when I open up an existing storage account, if I go in the navigation bar to configuration, here I will be able to not only view, but also change the replication type from the replication drop-down list. This storage account currently has replication set to locally redundant storage, or LRS. So we're going to change that using PowerShell. So let me just go ahead, click the X in the upper right to close out of that storage account. And here in the portal, I'll just click the Cloud Shell icon at the top, where we're going to run some PowerShell commandlets to modify aspects of a storage account, such as its replication, I can do this with the set-az storage account PowerShell commandlet. -resource group name is the parameter, -g1 is the value, -account name, and then the name of the storage account, -SKU name. And then I'm going to specify standard_RAGRS, because in this example, I want to enable read access geo-redundant storage. I'm going to go ahead and press enter. Now, after a moment, it appears that everything has worked. Now, we can check our work in a number of places. We can, for example, minimize Cloud Shell, go back into the portal and open up that storage account and click on configuration. Now, if you don't see the change that's taken effect immediately, it's only because it's not been refreshed here in the GUI. All I'm seeing right now is it's still set to locally redundant storage. So does that mean it didn't work? No, it means it's just not up to date yet. So if I click on something else like another storage account and navigate back in, it still might take a few minutes. And if I go down to the configuration blade once again, we can check to see if it picked up the change. It still hasn't, so I'm just going to wait a moment. And after a few moments, the replication setting will have been changed through PowerShell. Let's go back into Cloud Shell here for a moment. You might wonder, how do you know to use the -SKU name parameter and what the value is that you should pass to that? The answer is help, as in check the help. So as an example, here in Cloud Shell, I'm going to type get-help set-az storage account. That's the commandlet we used. Now you could use the get-command commandlet to discover the commandlets available. And you would eventually discover that set-az storage account exists. And by putting 2 and 2 together, you'll figure out that that's probably used to modify a storage account. I'm going to ask for detail and pipe that to more. You can't just magically make up these values. You have to have some way of knowing, either by researching on the internet or by looking directly at help. So as I go down through all of the various parameters, I will eventually come across the -SKU name parameter. And then below that, I'll start to see some of the values like standard_ZRS for zone redundant storage, standard_GRS for geo redundant storage, and so on. So that's how we can quickly find out what the parameter name is for a commandlet and what values it might expect, especially when those values are special keywords. The CLI can be used to modify a storage account's replication settings. Now, to get started, let's take a look at the current replication settings for a storage account. We could do that in the portal, but for fun, why don't we just go ahead and do it here in the CLI? To do that, I'm going to run AZ storage account show -- name, and I've specified the name of an existing storage account, -- resource -- group, specify the name of a resource group, -- query, and I'm asking for SKU, and within SKU, .name. Let's go ahead and press enter and see what we get. So it returns standard_RAGRS, so read access geo-redundant storage. That's the current replication set for that named storage account. Well, I want to change it, but I have to know what the values are that I can specify for the SKU. For example, how do I know if I'm supposed to use a value of standard_RAGRS? How do I find that information out? One way to do that is to use the help system that's built into the CLI. So for instance, I'm going to type AZ storage account update, because I know that's the syntax to update a storage account, -h for help. So when we look through the help related to that syntax, we'll eventually come across looking at the SKU, just keep scrolling up here, where we can then specify the values. So --SKU is a parameter, and allowed values are listed. I want to set this back to just standard LRS, locally redundant storage. So the value then for the --SKU parameter apparently will be standard_LRS. Got it. So I'm going to clear the screen with CLS and I'm going to make the change. So I want to make an update for my storage account. So to do that, I can use the AZ storage account update syntax. That's the help that we just looked at. In action, it's going to look like this. AZ storage account update. Now I need to specify --SKU. I'm going to make sure that that is --. The value for that parameter in my case, because of what I want to set it to, is standard_LRS. Then I'm going to specify --name for the name of the storage account, --resource-group, and then the name of the resource group where that storage account was deployed. Let's press enter, and we'll give it a moment. So the provisioning state is being shown as succeeded, so I'm going to go ahead and clear the screen with CLS, and I'm going to use the up arrow key to go back up a few commands where we were running AZ storage account show, and we were querying for skew.name. Let's press enter to do that for the same named storage account. This time, it's returning standard_LRS for locally redundant storage. Storage account failover provides high availability in the event that there's a disruption of some kind in the primary region that's currently hosting a storage account. Now, in order to work with storage account failover, you have to first have enabled geo-replication. You have to have it replicated to a secondary region. So to get started here in the portal, I'm going to open up an existing storage account. And what I want to check out in the properties of it is the geo-replication blade. So I'm going to click geo-replication over on the left. On the right, we will have plotted two teardrop icons or location icons. One is blue, and if I scroll down far enough, it tells me in the legend that that is the primary location, which in this case is Canada Central. That's the primary copy of the storage account. And the green location marker, the secondary location, is for Canada East, which is currently the secondary. Now, at the bottom of that screen, if I keep scrolling down, we have a Prepare for Failover button. So I can initiate storage account failover if for some reason the primary region is inaccessible. So I'm going to go ahead and click Prepare for Failover. That's going to open up a new blade where it gives me some information about my last sync date and time for synchronization, and some details about what's going to happen, such as the fact that after I have completed the failover, the secondary will become the primary, and it will be converted to use locally redundant storage, LRS. That's fine. I'm going to type in yes in the box to confirm that I want to enable this failover, and I'll click Failover. After a few minutes, if we check our notification icon in the upper right, we'll have a message stating that the failover succeeded. Now we can check our work here in the properties of the storage account by going back to the geo-replication blade. Where we used to have a primary and a secondary location or endpoint, we'll now only have a single item. It's only a primary location now. What used to be the secondary was the Canada East region for this storage account, but it is now configured as the primary. In addition, if I scroll up to the top, the replication is now set to locally redundant storage or LRS. That's the default behavior when you initiate failover from a primary to a secondary region for the storage account. But the benefit is now we have read and write access to the contents of this storage account, even though the primary region might be inaccessible. You can configure custom DNS domain names to be used when you refer to blobs stored in a storage account. Let's explore this in the portal by opening up an existing storage account. The first thing I want to do here is scroll down in the navigation bar until we get to the properties of the storage account. The reason we're doing this is because one of the properties, the blob service property, contains the URL that is used to access this storage account, and by extension, blobs within it. So the URL is https:// the name of the storage account, and what follows after that is the default DNS domain name suffix for storage accounts in Azure, and that works out to be .blob.core.windows.net. What if I don't want to use that URL to refer to blobs in the storage account? Well, that's where storage account custom DNS domain names come in, and we can get to that by scrolling down in the navigation bar on the left. And under blob service, I'm going to click on custom domain. The first thing I have to do is specify the domain name that I want to use down at the bottom, such as www.quick24x7test.info. Quick24x7test.info is a DNS domain name that I already have registered with an external registrar. So in order to use this properly with the storage account, I have two methods listed above. The first of which is to create a CNAME or an alias record that points to my existing storage account URL. So we can do that. The second option is again to create a CNAME or alias record that points to the AS-Verify subdomain for my storage account. I'm going to go with option 1. Either way, when you create these CNAME DNS records, you're creating them in your external DNS registrar tool, which I'm going to do right now. So here in my external DNS management tool, I'm going to add a record to the domain name that I own. So to do that, I'm just going to go ahead and scroll down and click the Add button. The first thing I have to do is determine the type of DNS record. And we were told in the Azure portal that we need to create a CNAME record. I'm going to add www for the host, and in the points to field, I'm going to paste in the reference to my storage account blob URL, and I'm going to click Save. Back here in the portal, I'm going to click Save, where we specify the domain name down below. To test my work, here in a command prompt on my on-premises system, I'm going to run the NSLookup tool. This is built into Windows. It stands for Name Server Lookup. It's used to test your DNS environment. What I'm going to do is simply type in www.quick24x7test.info. That's the custom domain name I configured on my storage account, and we created an alias record that should redirect that to the storage account URL, so a CNAME or alias record. If I press enter, it returns the fact that indeed we have an alias for the name that we just specified, our custom domain name, that does point or will redirect to the original storage account URL. Back here in the portal, I'm going to open up my storage account where I've created the custom DNS domain name, and I'm going to scroll down in the navigation bar under Blob Service and choose Containers. I've already got a projects container in this account with some sample files that I've uploaded. If I were to click on any of these files to open up its properties, over on the right, I would have a URL that I could copy that would allow access to this blob. Let's open up another web browser tab and plug in that URL just to see what happens. Okay, what happens is we get some returned message about resource not found. The resource does not exist. Well, recall that the default permissions for a storage account container are such that no anonymous access is allowed. Let's go back into the portal, and over on the left here, I have a change access level button. That's for the container. If I click it, it's currently set to private, no anonymous access. Let's say we were to switch that to blob, anonymous read access for blobs only. And I'll click OK. That'll just take a minute to put into effect. We can track the progress by looking at our notification icon in the upper right. It won't take long before we'll have a message stating that it successfully changed the access level for the container. Let's go back into our other web browser tab where we had pasted in the URL, and I'm going to go ahead and refresh it. And this time we can see the contents of that URL for that sample project text file because we changed the container access level. However, we're still referring to it using the original URL, which is the storageaccountname.blob.core.windows.net. What would happen, I wonder, if we put in our custom DNS domain name in place of that? So when I try to connect to www.quick24x7test.info, my custom DNS domain name, and I still have the suffix including the container name and the file in the container, the blob, I get a message saying the site is not secure, which is expected because it's trying to connect over HTTPS. So I'm going to go ahead and click the details button at the bottom, and then I'll click the go on to web page link. And indeed, it is opening up that file. We have access to that file using our custom DNS domain name that we've enabled for our storage account. A content delivery network, or a CDN, is a method that allows you essentially to copy or replicate content to different geographical locations, making it thus closer to users that request it and reducing their network latency to it. Now, this would be done, for example, for content for a web app, and it improves the user experience because it's quicker for them to access the content they need. So to enable a CDN, we can do this in a storage account. I'm going to open up an existing storage account here in the portal, and I'm going to scroll all the way down in the navigation bar for that storage account under the Blob Service section, where I have an option called Azure CDN, which I will click on. Now that's going to give me the ability over on the right to work with CDN or Azure Content Delivery Network settings. Now, currently, there are no endpoints listed because it's not yet been configured. So I'm going to scroll down a bit where I can either create a new CDN profile or use an existing one. Well, I can't use an existing one because I've not configured this before. So I'm going to have to leave it on Create New. And I'm going to call this Quick 24x7 Content. This is the name of my CDN profile or configuration. For the pricing tier, I'm just going to choose Standard Microsoft. The pricing tiers, besides affecting your bill, also determine the capabilities that are available. So I'm going to choose Standard Microsoft. If you search the Microsoft documentation for Azure CDN features, you'll get a listing of the various pricing tiers listed in a table where you'll have the features listed down the left-hand side. And as you scroll down, you can see the feature sets supported by each of these various types of pricing tiers. So if I want real-time alerts and real-time stats, that's the rightmost column here. And if I scroll up, I can see that's for premium Verizon. So I'd have to choose that pricing tier if I needed those types of capabilities. I don't need those types of capabilities, so I'm going to leave it on Standard Microsoft, and I'm going to specify a CDN endpoint name. I'll specify Quick 24x7 Test, and it will append the .azureedge.net DNS domain suffix by default. And I'll click the Create button to create our CDN endpoint. And before you know it, if you check your notification icon in the upper right of the portal, you'll have a message stating that it successfully created the CDN endpoint. If I were to go into the All Resources view, I would be able to locate the newly created CDN profile. So it's its own separate, independent Azure resource. Let's click on it to open it up for a second. In the Overview blade over on the right, we have some status information stating that currently our CDN endpoint is running, and we have the host name for that endpoint, which is available over HTTP and HTTPS. Now, what this means is that instead of referring to the origin URL of that content, files that are stored in that storage account, blobs, instead we can use the endpoint name for our content delivery network to retrieve that from cache. As an example, why don't we go back into our storage account just for fun, and let's pick on a specific blob file that's already stored there. Let's open up the storage account. In the properties of it, I want to scroll down under Blob Service and choose Containers. I already have a container in the account called Projects. So I'm going to open up the Projects container, and I'm going to click Change Access Level. Currently, the access level for the container is Blob, which allows anonymous read access for blobs. Perfect. I want that right now to test this out. If I were to click on Project A.txt, that's a blob file that was already uploaded there, I have the URL that points to that blob. All right, well, let's see if that URL works to open it up, and then we're going to modify the URL to reflect our use of the CDN endpoint. First things first, I'm going to copy that, and we're going to open up a new web browser tab and paste in that URL, and it opens up the sample project file, which is just some sample text. That works fine. Let's change the URL to reflect our CDN. So everything really looks the same because we're opening the same file, but we're referring to it with a different name. In the URL or address bar, I'm now referring to quick24x7 test.azureedge.net, and what trails after that is the container/projects and then the blob itself /project_a.txt. So now we have a way to access that using our content delivery network instead of the origin URL. The benefit being that we are pulling it from the CDN cache. Back here in the portal in the All Resources view, the CDN profile is a new Azure resource that gets created when you configure it the way we did through the storage account. So if I click to open up the CDN profile, we can configure it further if we want to. Now in the Overview blade, we're going to have a list of all of the CDN endpoints on the right. Ours is currently listed as running and supports protocols of HTTP and HTTPS. The origin type is storage as opposed to some other web app URL. And I'm going to click on that listing, that endpoint, to open up its properties. One of the things I can do here is click Origin in the left-hand navigator. And what we're going to have the ability to configure if we wanted to change it is the origin type, which is currently set to storage, and it's pointing to our storage account. We can even specify a path within that storage account that we want it to refer to, a container. HTTP and HTTPS are both enabled by default, respectively for ports 80 and 443, but we can turn that off. If we turned off HTTP, it would mean that we have to use HTTPS to connect to the CDN URL. If I were to click, for example, on caching rules on the left, I could add some rule settings that would determine how long content gets cached in the content delivery network. For example, if I choose cache every unique URL, we can go ahead and enable that. But we have more details related to that if we go to Rules Engine on the left. So I'm going to switch over to the Rules Engine on the left, where we can add rules and specify details like hours, minutes, seconds. Here I have a rule, set if missing. That's the cache behavior. So if we have an item that is requested and is missing, then once it gets cached, it'll be cached for 5 days according to my configuration. So you can add rules to control these types of items. I can also configure other details that I might be interested in, like geofiltering. So I'll click geofiltering over on the left, and what I can do in the action drop-down list is specify if I want to allow or block specific country codes. So if I wanted to block a certain country code from the country codes drop-down list, I could scroll down and, for example, put check marks by the countries I want to exclude from using this CDN. You might do this depending on the nature of your content, where it might apply to certain cultures, certain languages, or certain countries, and you can either allow or deny it. But either way, we've got some further fine-tuned details we can configure for our CDN endpoint if required. Software developers will often build software components that can exchange messages with one another through some kind of a storage or message queue. This allows for decoupling and independence of those components. So for example, if one software component needs to send a message to a second software component and the second one is unavailable for some reason, maybe it's not running, maybe it's inaccessible over the network, we need a way to temporarily store that message so that the second component can read it and process it when it becomes available. That's exactly where storage queues come in as being useful. So here in the portal, we're going to define a storage queue within a storage account. I'm going to go to my storage accounts view, and I'm going to open up an existing storage account. One of the considerations when planning the use of this in the overview blade is taking note of the location of the storage account, in this case, Canada East. Now, I've got this storage account in Canada East, but if I've got software components that need to talk to one another, and those software components are in the Western US region, it wouldn't make sense to have the storage or message queue stored in Canada East. So think about the placement of your storage accounts and how they will be used, such as with software components and storage queues. So in the navigation bar for the storage account, I'm going to scroll all the way down until I get to the queue service section, where I'll then click on queues. I have the ability to work with or manage existing queues, or I can add a new queue. So I'm going to click the Add Queue button up at the top, and I'm going to call this Q1, and I'll click OK. So you can add multiple queues to the storage account. The first thing that we need to be aware of is that there is a URL that is generated for the queue. This is going to be important for software developers so they know what to connect to. If we actually click on the queue to open up its details, we'll have the ability to test it out by clicking the Add Message button over on the right. So I'm going to add a message, Hello World. I can set the expiration, let's say, to 1 day, and it's going to be encoded in base 64. All of this is normally done programmatically. This just allows us to test it out. I'll just go ahead and click OK, and we've got our Hello World message that's been queued up in this queue. And of course, we have an expiration date and time based on what we specified when we added the message to the queue. Now, developers can do the same thing when they add items to a queue programmatically. There's also an access policy over on the left for determining who or which components have access to the queue and what they can do. So on the right, I'm going to click the Add Policy button, and I'll just add an identifier here of Policy 1. And we have permissions here. For example, the ability to read, add, update, or process messages in queues. We can specify a start, date, and time when this would be in effect. So for example, let's say I want to allow the ability to read messages in the queue. I can specify a start date and time and an ending date and time by specifying the time zone as well for both of those respectively. And then I can click OK. So you can control access to what is stored in the access policy in this manner with the access policy. Now, let's not forget, though, that the storage queue is in a storage account. So if I go back to the storage account, so I'm not going to save that policy. I'm just going to go back to the storage account itself. I'm interested in looking in the storage account properties at the access keys. If software developers are using one of the access keys or connection strings here, they will have full access to the account, including the queues within it. If you need to limit that access in another way, you could also do that with a shared access signature, otherwise called a SAS, an SAS, where you could allow access, specific access, to only storage queues. An Azure Key Vault is a centralized storage location to store secrets. Now, these secrets might include connection strings for databases, names, passwords, EKI certificates, whatever you might need in your environment. And you can determine which software components or Azure resources or users have access to each of the types of secrets stored in the Key Vault. Let's get started here in the portal. I'm going to click Create a Resource in the upper left, and I'm going to search for Key Vault, and I'm going to choose Key Vault, and then I'll click on the Key Vault. So the first thing I'll do is deploy this into a resource group. Then I'll scroll down. I'm going to call this KVYHZ, and then some numbers to make it unique. I'm going to deploy this in a region, specifically in my case, Canada Central. And down below, I'm going to leave the default settings for the pricing tier, soft delete, which is enabled, the retention period, which is 90 days. I could also enable purge protection. Purge protection prevents anything in the vault from being permanently purged or removed until after the retention period, which of course is related to the soft delete option. If I disable soft delete, all that goes away. If I enable soft delete, those things become available once more. So I'll leave the defaults. I'll click Next. Every Key Vault has an access policy. So you can have users with specific key permissions. So I can open up the list and see which key permissions are set. I can also see which secret permissions. You can create keys in the vault or import them. You can create or bring in secrets like connection strings and so on, or certificates. And you have permissions for each. You can also allow things like Azure disk encryption for volume encryption, let's say. If you know you want to be able to access keys in here from VMs to encrypt volumes, and you can enable that. So I'm going to click Next for networking. From where would we like this Key Vault accessible from a network standpoint? Public, so public endpoint, all networks, public endpoint, selected networks, or private. Very much like what you would encounter when you set the network access settings on a storage account that you're creating. I'm going to leave it on the default of public endpoint, and I'll click Next for tags. I'm not going to add tags. Next for review and create. And once it's passed the validation, I will click the Create button to create the Key Vault. But once it's created, I want to go into it for a moment so we can look at the access policy again, as well as the different types of secrets, so to speak, that can be created or imported into the vault. It won't take long before you can click the Go to Resource button to open up your newly created Key Vault. So the first thing I want to point out here, if I scroll down in the left-hand navigator, if I go to Keys, we'll have the option of working with keys in the vault. What do you mean working with? Generate or import, as the button says at the top. If I click Generate or Import, from here, I would have the option of doing just that, generating a key or importing or restoring from backup. So let's say I want to generate a key. I'm going to call this VM encryption key 1. I can determine if it's an RSA or an EC type of key, the RSA key size, which defaults to 2048 bits. I'm going to leave that. You can also set an activation date when I want this key to be available, a date and time, and the same for expiration, a date and time. It's enabled by default, so I will click Create. And after a moment, our VM encryption key 1 will have been created in the Key Vault. If I go to Secrets, we can also do the same type of thing, generate or import something stored in the Key Vault, except in this case, it's not actually a key. It would be a secret of some kind with a value. So for example, secret connection string. I'm going to leave it on manual in the top drop-down list as opposed to certificate. So I'm going to call this secret connection string, and then I'll just put in a value for that. I'm not going to set activation or expiration date and times. It's enabled, which is good. Create. And finally, we can also generate certificates if we have a need for PKI digital security certificates that we want to work with here in the vault. If I click the Generate Import button for that, as you might guess, we'll have the option of importing existing certificates. If you've already got certificates that might have been issued by a certificate authority already, you can reuse those. So you can go under the Method of Certificate Creation drop-down list and choose Import. However, we can also generate them. When you generate them, you can specify the certificate name, whether it's signed by a self-signed certificate or some other CA, certificate authority. You can specify the subject name and DNS names and so on in the validity period. So there's a number of items that you can import or generate in the Key Vault. If I click Access Policies on the left, we saw this upon creation, but you can change it at any time. So for example, I could click Add Access Policy to determine who or what has access to certain types of items in the vault, what they can do to those certain types of items. Now you can choose from a template for permissions up at the top for key management, certificate management, SQL Server connector, Azure backup, and so on. I'm just going to leave it empty and do it from scratch. So we have key permissions we can select from the list. We can select them all, or we can cherry pick individual key permissions that we want to allow. Same with secret permissions, such as getting the value of one or listing them all. Same with certificates. We can do all of that. And we can specify the principal. Now, when I click on Select Principal, that opens up a new blade where I could select, for example, an Azure AD user or group and add them as members that can enjoy the benefits of being added to this access policy. So I'm just going to go ahead and click the X to close out of that. So at this point, we've created a Key Vault as a centralized secure storage mechanism in the Azure cloud. Not only can we use the portal to create and manage a Key Vault and the secrets stored within it, but we can also do this using PowerShell. Here in PowerShell, I'm going to create a new Key Vault using the new -AZ Key Vault PowerShell commandlet. -resource group name is the first parameter, whose value will be a resource group that already exists, in this case, EastRG1. -name, I'll specify the name for the new Key Vault. -location, I want to create this Key Vault in Canada Central. So I'm going to go ahead and press Enter to create the Key Vault. Now, creating the Key Vault is only one part of what is required. We need to first of all verify that it was created, and next we want to make sure that we can create something in it, such as a PKI certificate or some kind of a key, that kind of item. Next, I'm going to run get-az Key Vault. And when I press Enter, it will list any Key Vaults in my subscription, including the Key Vault that we would have just created a moment ago. I'm going to minimize the Cloud Shell, and here in the portal, I'm going to go to the All Resources view, which I will filter for Key Vaults. I'm doing this because I want to go in and take a look at the access policy that was mentioned when we created our Key Vault with PowerShell. So I'm going to click Type, which is currently showing all objects. I'm going to deselect, select all, and I want to scroll down and select Key Vault and click outside of that to put that into effect. So our newly created Key Vault shows up in the list, which I will select. Now, when I open up the Key Vault, I do have, if I scroll down in the navigation bar, access policies. Now, the access policies portion is important because I have to determine what kind of access should be allowed to different types of secrets, whether it's keys that are stored in here or secrets, which would be things like connection strings or passphrases, and PKI certificates. So on the right, I'm going to click Add Access Policy. I can choose from a template for standard usage, like key and secret management versus only key management, or certificate management, and so on. Or I could do my own thing, meaning I could select the very specific individual key permissions that I want to allow in the access policy, the secret permissions, and the certificate permissions. I'm just going to choose a template here. Let's say key and secret management, and I have to assign this to a security principal. So I'm going to go ahead and click on Select Principal, that'll open up a Select a Principal blade over on the right, where I can search or manually scroll through and take a look at my Azure Active Directory users and groups. So I could select a specific user, click Select, and then I could click Add. So we can do that. We can also make sure that applications or software components have access to the key vault. But let's go back into the Cloud Shell, because the next thing I'm going to do is create, let's say, a key within here. Now, to do this, I'm first going to have to create a couple of variables. I'm going to start by creating a $expires variable. That's what I'm calling it. It will store the result of running get-date, but get-date is within parentheses. And outside of that, I'm calling on the .addYears method. And in parentheses after that, I have a 1. I'm adding 1 year to the current date. And then pointing to the toUniversalTime method. So .toUniversalTime, open close parentheses. I'm going to go ahead and press enter, and I'm going to type in $expires so we can check out that variable. Okay, it looks like it's got the correct date and time of year from right now. I'm also going to create a variable called $notBefore. Basically, I can set a date and time when the key can be used, as well as when it expires. So the notBefore variable will store the result of running get-date, which again is in parentheses, and outside of the parentheses, I'm calling on the .toUniversalTime method. So I'm going to press enter. I'm just going to check that by typing $notBefore, and I'll press enter. Okay, so it's returning our current date and time information. Now, the next thing I want to do is use both of those items to determine when the key that we're about to create in the key vault can be used and when it will expire. So for that, I'm going to use the add-az key vault key commandlet -vault name. I will specify our vault name that we just made. I'm going to have to make sure after that we have a space before the next parameter, which is -name. I'm going to call this key 3. -destination is software, as opposed to having it protected with a hardware security module, a FIPS-compliant HSM. -expires, I'm going to use my $expires variable, and $notBefore, I'll use my $notBefore variable. Let's go ahead and press enter to build key 3 in the vault. Now notice I get a return error that says this is forbidden. Why would that be? Because of the access policy. Let's minimize this and go back into the access policy section for our key vault. We know that we can add a policy. For example, I'm going to click add a policy, and I'm going to make sure I add a policy and make sure it applies to the correct user. Now we're talking about key management, so I'm going to choose key management, and that basically enables all of the permissions, including creation of keys, which is what we're trying to do in PowerShell. So down under Select Principal, I'm going to go ahead and specify a different user this time. I'm going to select my user account that I'm logged into Azure with currently. So I'm going to select that, and I'm going to click Add down at the bottom. I'm just going to go ahead and click Save to save the access policy. Now back in my Cloud Shell, if I run that same command again, this time the key will be created because I have the appropriate permissions. And if we were to minimize Cloud Shell and go back and look at the keys within the key vault, we'll notice that we now have a key by the name of key 3 that is showing up in the vault. In this demonstration, I'm going to use the Azure CLI to create a new key vault. To do that, I'm going to use the AZ key vault create syntax. I'll then specify --name with the name value, then --resource group. I want this deployed into a resource group called eStarG1, --location, which in this case will be Canada Central. So I'm going to go ahead and press enter to create the key vault. After a moment, it will have been created. So I'm just going to clear the screen. The next thing I'll do is run AZ key vault list. This will list any key vaults that we've got created. Now, what I could do instead of returning all of the properties for the key vaults is run AZ key vault list --query space open close square bracket .name. I only want to see the name property. That's a little bit more digestible if all you're looking for are the names of the key vaults. Now, the next order of business is going to be to create a key within that key vault. So to do that, I'm going to use the AZ key vault key create syntax, --vault -name. I will specify the name of my existing key vault, the one that we've just created, --name will be for the name of the key that we want to create within the vault. I'm going to call that key key2. --protection, I'm going to specify software. Now, I could alternatively use HSM or hardware security module if I need that kind of FIPS compliant storage of secrets, but I don't need that, so software protection will work just fine in this particular case. I'm going to go ahead and press enter to create that key in the vault. It won't take very long to do it. So what I'm going to do is clear the screen. We're going to check our work with AZ key vault key list. I want to list the keys in the vault, so I have to tell it the name of the vault. --vault name, and that vault was called KVYHC789. That's the one we just created. So I'm going to go ahead and press enter. And what should be returned is the fact that we've created a key in that vault by the name of key2. Of course, that will only work if I've spelled the vault name correctly, which I have not. Let's try that again with the correct vault name. And then it's very quick, and we get the returned output that we expect, where the name of the key is key2. So in this course, we've examined the services of the Azure Storage Platform, including how to deploy and manage storage accounts and key vaults, how to enable account redundancy, and how to create and manage storage queues. We did this by exploring the Azure Storage Platform, including its core services and features, and when to use a particular configuration. We looked at how to use the portal, PowerShell, and the Azure CLI to create a storage account, and we examined how to use those same tools to enable storage account geo-redundancy. We also explored how to force failover for a storage account and how to enable a custom DNS name, how to configure a CDN profile, and how to create and manage storage queues, and finally, how to use the portal, PowerShell, and the CLI to deploy a key vault. In our next course, we'll move on to explore how to upload and manage Azure Storage Account blobs, including enabling blob versioning and change feeds, using the AZ copy command, and enabling blob lifecycle management. Azure Storage Explorer is a free Microsoft tool that allows you to make a connection to a storage account using many different methods. So here in my browser, I've navigated to the Azure Storage Explorer download web page. So I can go ahead and download and then install the tool, which I've already done on my on-premises system. Once you get into the Storage Explorer tool, when you launch it after installation, if there's an update, you'll be prompted to install it, which I've just done. In the left-hand navigator, if you click on the Manage Accounts button, from here you'll be able to add an account. Now that would be useful if you want to use your Azure account credentials to connect to Azure Storage. You could also click the Open Connect dialog or the plug icon in the left-hand navigator, which pops up a screen where you can select to connect with an Azure account or a variety of other mechanisms, using a connection string or a shared access signature URI or a storage account name and key. However, I'm going to cancel those. I'm going to go back to my Manage Accounts screen because what I want to do is add an account. So I'm going to click that link. I want to add an Azure account, so I'll just go ahead and click Next. And I'm going to specify my sign-in credentials to sign into Azure. And then I'll click Sign In. Once I've authenticated, I'll see my account and my subscriptions listed in the left-hand navigator. So if I were to click on the icon in the left-hand navigator that's labeled Toggle Explorer, so I'm going to click that, it opens up an Explorer type of hierarchy where I can start to browse through my subscription and I can see the storage accounts that I can then expand and drill down into to get down into things like storage blob containers, file shares, queues, tables. I can even see disk objects by resource group and so on. So what I'm going to do at this point is drill down into an existing storage account where I know if I expand blob containers, I've got some containers created already, one of which is called projects. If I click on that, I'll see the contents of that blob container shown on the right. And I can right-click on any of those blobs, those files, and I could choose standard options such as opening the item, downloading it, copying it, deleting it, copying the URL, even changing the access tier of that selected item, maybe from hot to cool or archive. I can also right-click on blob containers and I can choose Create Blob Container. For example, I'm going to create one here called Budgets. Then on the right-hand side of the screen, I could click the Upload button and choose to upload a folder or files from on-premises into this blob container. So I'm going to choose Upload Files. Then on the Selected Files field to the right of it, I'm going to click the Context button, the button with the 3 dots, to select files I want to upload. After I've done that, I can determine from the blob type drop-down list whether I want these uploaded and treated as block blobs, page blobs, or append blobs. Because these are Excel spreadsheet files, I'm going to treat them as block blobs. And I'm going to click the Upload button. Because I've already authenticated to my Azure account, so I have access to the storage account. After a moment, the files will be transferred, they'll be uploaded, and they will be available within the budget's container. So the Azure Storage Explorer tool, then, is a GUI tool that we can use to make a connection to Azure for managing storage accounts. One way to upload and manage blobs, binary large objects, in an Azure storage account is to use the portal. So here in the portal, I'm going to open an existing storage account. What I want to do is I want to create a blob container, which is really just a subdirectory or a folder to organize blobs, and then I want to upload some blob content into it. So in the properties or the navigation bar of my storage account, I'm going to scroll down until I come across blob service, then I'll click containers. In the right-hand panel, any existing containers will be shown, but what I want to do is create a new one, so I'll click the Add Container button up at the top. I'm going to create a container called Projects to organize some project files. The default public access level for a newly created container is set to private, which allows no anonymous access, but from the drop-down list, I can choose to set it to a value of blob, which allows anonymous read access for blobs only, or I can set the public access level to container, which would allow anonymous read access for the container, so we could list the contents of the container, as well as access individual blobs directly. I'm going to leave it on private, no anonymous access, the default, and I'll click Create. Now, after a moment, the project's container is created, so I'm going to click to open up the project's container, and to get content in here, I'm going to click the Upload button up at the top. That's going to open a new upload blob over to the right where I can click the selector icon to choose some on-prem files to upload. So I've selected a handful of files. I have an option to overwrite if files already exist in this container. They don't, it's currently empty. And under Advanced, I can determine if I want to use the storage account key as my authentication type to connect to the storage account, which is what I'm using in this particular case since I'm logged in through the portal. Also, I can select Azure AD user account. The blob type can be specified as either a block blob, a page blob, or an append blob. Now, page blobs are used for larger files that have the characteristics of dealing with random reads and writes throughout the file. Not always at the beginning, not always at the end, just random. And that's how virtual machine hard disk files are treated. So there's an option down below here, a check mark, to say upload.vhd virtual hard disk files as page blobs. Otherwise, standard files like spreadsheets and documentation can be uploaded as a block blob. And you also have the option of an append blob. The append blob, as the name suggests, is used normally for files that have a characteristic of always being added to at the end, like log files. In this case, they're just standard text files, therefore the best choice is to upload these as block blobs. I can also specify at this point, and change it after the fact, the tier that I want to store this in, the access tier. The hot access tier costs more than cool and archive access tiers because it allows for frequent and quick access. But if you only need, or if you only require infrequent access, you might choose the cool access tier. The tier can be changed after the fact as well. So I'm happy with this. I'm not changing anything. I'm going to go ahead and click Upload to get these text files into the container. I'll click the Upload blob blade in the upper right by clicking the X. And we now have our project.txt file stored within our newly created blob container. We click the Upload button up at the top to get that content here. Next to the Upload button, we also have a Change Access Level button. These are the access levels that we had available when we created the container. So private, blob, or container access. I'm going to leave it as it is, but just pointing out that yes, we can do that. We can also click on a specific uploaded blob or a file that's stored in this container, which will open up a properties blade on the right with properties for that selected file. we have details like the URL that would be used to access the blob, the creation and modification date and timestamps, the access tier that this blob is pertaining to, in this case, the hot access tier. Also, the fact that it's server encrypted, which is a default for storage accounts. I also have the edit link up at the top where I can edit this actual blob file. Now, depending on the nature of the file, you might have to download it to make changes to it, but because this is a text file, when I click edit, it just shows me the contents of that file. So we have a number of interesting options that are available once we get content into our storage account. Now, when I close out of the properties blade for that blob, I can also, instead of clicking on it, click the checkbox to the left of that uploaded blob and click the context menu to the far right. That's the 3 dots icon. And when I click it, I'll have a lot of the options I would otherwise see when I click on it, such as the ability to download or view and edit, go to the properties, even view and create snapshots, change the tier, delete the blob, and so on. You can manage blobs and blob containers using PowerShell commandlets. So the first thing I'm going to do here in PowerShell is I'm going to create a context variable. Essentially, I want to have a pointer or a handle to a specific Azure storage account. So to do that, I'm going to use a variable I'm going to call $CTX for context, and it will store the result of running get-az storage account. -R for the resource group will be east RG1, and -name, I'll specify the name of a storage account. I'm going to go ahead and press enter. And if I type in $CTX to view the contents of the variable, it will indicate that we've got a handle on that specific storage account because it's providing some details about the storage account. What I'm going to do is then run $CTX equals $CTX.context. What does this mean? We are storing the context property of our current context variable into the context variable. So we're just updating the same variable with more detailed granular information, specifically the context property. So now if I type in $CTX, we've got some context details related to that storage account. Specifically, it's showing us that we've got a lot of endpoint information and connection string information for the account stored in that variable. Now that that's taken care of, I'm ready to build a storage account container. To do that, I'm going to use new-az storage container -name. I want to call this headquarters. That's the container name. -context. I'm going to specify my $CTX variable. So I don't have to worry about specifying the storage account and the resource group every time I want to work with it. I can just use my context variable instead. So I'm going to go ahead and press enter. So at this point, we've got a container called headquarters. We could even verify our work if we really wanted to by minimizing the Cloud Shell and then going into the storage account. So here in the portal, I'm going to open up the storage account where we've created that container. I'm going to click on containers in the navigator for the storage account. And in the list of containers, we will have our newly created headquarters container. So back into Cloud Shell, what are we going to do next? Well, the next thing we want to do is actually upload a blob from our cloud account, specifically our Cloud Shell account, into our storage account. Now, Cloud Shell technically uses a storage account, but you could do the same thing if you were running PowerShell on premises. You could upload on-prem files directly into the cloud. So what that means here is in the Cloud Shell, I'm going to go ahead and click the Upload and Download Files button, and I'm going to choose Upload. I've uploaded a file called regional_spending_2016.csv. And here in Cloud Shell, if I go to Home and then go to my Home account, and if I do a dir, it will show that the file is stored here, regional_spending_2016.csv. Now what we can do is have that uploaded directly as a blob into a storage account of our choosing. To do that in PowerShell, I'm going to use set-az storage blob content. That's what you use when you want to upload blobs. -file is going to be the file name. Now the thing I have to do is specify the container I want that stored in. So -container here is going to be our newly created headquarters container. Dash blob. What do we want the blob to be called in that container in the storage account? I want it to be called the exact same thing. So I'm just repeating the file name. I don't have to, but that's what I'm doing. Finally, it has to know the storage account and the resource group the storage account is in, and we can just do that with dash context, and we can pass it as a value, our $CTX variable. And let's minimize the Cloud Shell. We can go back into the portal. We could open up the headquarters container to verify that our regional spending file has been uploaded as a blob, and indeed it has. But we can also verify this back in Cloud Shell using PowerShell commandlets. So for example, we could run get-az storage blob dash context $CTX dash container, let's say headquarters. Show me what is in the headquarters blob container. And it will return everything in it, which in our case is going to return our regional spending file. The Azure CLI can be used to upload and manage blobs in a storage account. The first thing that I'm going to do for the Azure CLI here is I'm going to get a list of storage account keys. Now, I don't necessarily need the key to access the storage account in every circumstance, but I am going to use it in this particular case from the CLI. So to get started here, I'm going to run AZ storage account keys list. Now notice that keys is plural because every storage account, as you know, has two keys. --account -name is the first parameter. The value is the name of the storage account in question. --resource -group, and I'll specify the resource group where that storage account was deployed. And finally, --output table, just to control the output. I don't have to output it in table format, but it makes it easy to look at. What gets returned are both key 1 and key 2. We can use either one of these keys to authenticate to and access the storage account. Now, the next thing I'm going to do is create an account variable that stores the name of my storage account. The variable will be called $account, and it will store the name of my storage account. I'll just press enter. That's just basically a string variable. But the next thing I'm going to do is create a key variable to store one of the keys, doesn't matter which one, that we had viewed previously. I can bring up that command using my up arrow key again, where we viewed the storage account keys list. So I'm going to create a variable called $key, and within quotation marks, it will equal, let's say, the value of the first key, which I'll just paste in here, and I'll close the double quotes. So we've got our account name in a variable and a storage account key in the variable. So what I'm going to do now is create a storage container within my storage account. To do that, I'm going to run AZ storage container create --name. I want to create a container called East Data --account -name. I'll just use my $account variable. --account -key. I'll use the $key variable that we just created. We get returned created with a value of true. So it succeeded. Now, the next thing I want to do is upload a file into that specific container. I'm just going to go into my home directory here in Cloud Shell with the change directory command and type dir. I've got a file here called regional_spending_2016.csv. I want to upload that to the new container I just created. So to make that happen, I'm going to run AZ storage blob upload --container -name. The one we just created is called East Data --name. So what I want to do here is specify the name that I want this to be called inside of my storage container. I'm going to call that, let's say, regional spending. That's all I want it to be called, regional spending.csv, so different name. Next thing I'm going to do is specify --file. This is where I have to refer to the local file name that I want to upload, and that's going to be my regional spending 2016.csv. So that's the origin file name that I want to upload. Next, --account -name. Well, this is easy because we can just use our $account variable. Doesn't matter if the variable name is uppercase or lowercase when you're working in PowerShell. Now, I'm in PowerShell. What I mean by that is that's where we are in the upper left. We started a Cloud Shell and we're in a PowerShell environment, although we can still issue CLI commands. So the last thing we have to do here is specify --account -key. And for this, I'll just use my $key variable. So I'm going to go ahead and press enter. And before we know it, the file will have been uploaded. We can check our work. So for example, what I'm going to do is minimize the Cloud Shell, go back into the portal. I'm going to open up the storage account in question. And in the navigation bar, I'm going to scroll down under Blob Service Containers. We've created a container here called East Data, so I'll click to open that up, and in it, I will find the regional spending.csv file as I've renamed it when I uploaded it as a blob. Microsoft Azure Storage Explorer is a free GUI tool that you can download from Microsoft, and it allows you to manage your storage account contents using a friendly GUI. You can run this on an on-premises station. I've already got it up and running, and I've already authenticated using my Azure account. So in the Explorer left-hand navigator, I can drill down under my subscription. And what I'm presented with is storage accounts and disks. So if I expand disks, I'm then presented with resource groups. So if I were to select a specific resource group, I would then get a list of the disks in that resource group shown in the right-hand panel. I can also drill down under storage accounts, where I am then presented with the storage accounts in this subscription. I can drill down within a storage account to be exposed to the blob containers, file shares, queues, and tables in that storage account. If I were to expand blob containers, I would see existing items that I can then select on and manage the existing blobs. But I can also right-click on blob containers and choose Create Blob Container. I'm going to create one called HQ Data in this example. I'll press Enter. Once I press Enter, I've selected the HQ Data blob container. So on the right, up at the top, I'm going to click the Upload button, and I'm going to choose to upload a folder. This is going to be an on-premises folder that contains many files. So in the selected folder field to the right of that, I'll click the button, which will allow me to select a specific item, such as the projects folder on premises that I have locally. When I click Select Folder, I can then determine what blob type it should be uploaded as, the contents. Block blobs are normally used for standard Office productivity files like spreadsheets and word processing documents and presentation files and so on. Page blobs are used for files, larger files that have random read and write throughout the file, like virtual hard disk files, and append blobs are normally used for logs, where we have continuous appending to the end of the file. So I'm going to choose Block Blob, and I'll click Upload. The first thing that it will do is in the activity window at the bottom, we'll have a listing as to whether the transfer was successful or not. We have a listing indicating that 7 items were transferred, and what it will have done is recreated that entire folder and everything under it here in the container. So it's created a folder or container called Projects, and if I open that up, the files that existed in that folder on premises were also uploaded automatically because we selected to upload a blob folder. I could then right-click on a blob file and choose to open it to modify it. When I do that, in this case, we'll have the ability to see what's inside that file. In this case, because it's a TXT file extension, it opens up in Notepad and I can see the contents. We can also right-click on a blob and download it from the storage account to our on-premises environment. We can choose to delete it. We can copy the URL if we're testing URL access to blobs, for example, and maybe in a web app. We can change the access tier, for example, from hot maybe to archive if the file should be archived because it's no longer really needed, at least not for frequent access. Now I can also right-click on a file and create a snapshot of it. I can view its properties, but notice if I select multiple files, such as by pressing Control-click, when I right-click on any of those selections, many items are grayed out, including the changing of the access tier. I can also right-click on blob containers in the left-hand Explorer navigation window, and I can configure the soft delete policy for this Azure storage account if I want to enable soft delete. And I can then set the retention period in numbers of days, the default of which is 7. Soft delete is handy. When you've deleted something, a blob from the account, you want a period of time where you can recover it if it was done mistakenly. However, I'm going to cancel out of that. We can also get into the storage account and manage other items beside blobs, like file shares, queues, and tables. If you have experience with document management systems, including Microsoft SharePoint Server, you'll be familiar with the concept of document versioning. where you can have multiple versions of a single document stored, and you can view those versions or even revert to it if needed. Now, in order for us to work with blob versioning in a storage account, we need to make sure that we issue the appropriate PowerShell commandlets to register the feature. So I'm going to go ahead and open Cloud Shell here within the portal by clicking the Cloud Shell icon up at the top. I'm going to go ahead and use the register-az provider feature commandlet -provider namespace is Microsoft.storage -feature name is versioning. So I'm enabling this feature. So I'm going to go ahead and press enter. The next thing I need to do is I need to refresh the storage namespace, in this case, Microsoft.storage. To do that, I'm going to use register-az resource provider -provider namespace Microsoft.storage, and I'll go ahead and press enter. And it's done. Now, if I check any of my existing storage accounts, because this is a newer feature, bear in mind that if your storage account is deployed into a specific region where this feature is not supported, you won't have the option to use the feature. So I'm going to go ahead and open up an existing storage account where I know that the region is supported for this particular feature. The region in this case is Canada East, and I know that versioning is available here. Now, versioning you can get to in the portal when you're looking at the properties of a storage account by scrolling down in the navigator, going down under blob service, because this is a blob service type of feature, and going under data protection. And what we're going to see is that we've got a number of options available, such as blob soft delete, if we want to be able to recover deleted blobs for a period of time. When you enable that, you can specify the retention period before data is permanently removed or purged. We also have a blob change feed option, which is in preview. This is a newer version that we can enable. Blob change feeds are used to track changes to blobs in a hidden container stored within the storage account that you can access using the List Blobs API. And finally, what we're looking for here, versioning, which is currently shown as disabled, but we can click enabled. So I'm going to turn that feature on by selecting enabled, and I'm going to click the save button up at the top. In our notification icon in the upper right, after a moment, it will indicate that it successfully updated the data protection settings, in this case, enabling versioning. Once I've done that, I can then navigate to blob service containers where I have content already uploaded. So I'm going to open up an existing blob container I've created called projects, where I've got a couple of project sample files. I'm going to click the checkbox to the left of one of these files, and over on the far right, if I click on the context menu for that blob, one of the options I will have here is to view previous versions. If I click on that, it'll open up a new blade to the right where any previous versions will be shown. In this case, there are no previous versions found because this file was uploaded and never modified. So what I'm going to do for my sample project file is click the context button again, and I'm going to choose View and Edit because I want to make a little change and save it. So in line 1 of this sample file, we see the word original. I'm going to have that say changed, and I'm going to click the Save button up at the top. So we've made a change. We've edited that blob. Now I want to go back into viewing the previous versions for that same file. So I'm going to go back in the exact same way. This time, it lists a previous version of that file, and I can select it, download the version using the button at the top with the same name, make it the current version, or I can delete the version if I no longer need it. Another command line tool that you can use to get blobs or files into a storage account or out of it is by using the AZ-copy command line tool. This is a free Microsoft command line tool. If you search up AZ-copy in a web browser, it won't take you long to get to the page that I'm on, where if you scroll down a little bit, you can download a copy of AZ-copy for Windows 64 or 32-bit, for Linux, or for the Mac OS. I've downloaded the zip file, and I've chosen to extract it on my machine on premises on drive D in a folder called AZ-copy, where I have the azcopy.exe file. In a command prompt on that same machine on drive D, I'm going to change directory to azcopy, and I'm going to type azcopy-h for help. So this is giving me some output on how to use this AZ-copy command, how to use the syntax to work with blob management. So the first thing I'll do here is I'm going to run copy login to authenticate the AZ copy command to Azure. I'm going to press enter. Now I'm given a message that states I need to use a web browser to navigate to Microsoft.com/devicelog and enter the code, the unique code that was generated and is listed here. So I'm going to go to that URL in my browser and enter that code. When I go to that URL in the browser, I'm prompted to enter the code. So I'm going to enter the code and I'll click next. After I've successfully signed in, and I sign in with an Azure AD user account set of credentials, it will tell me that I have signed into Azure Storage AZ copy on my device and that I can close this web browser window, which I'm going to do. Back here in my command prompt, the login has succeeded. Here in the portal, I've navigated to Azure Active Directory to show that we have a user by the name of Lucas Brenner. Now, this is the user I've just signed in as for AZ copy purposes, but I need to make sure that this user has the appropriate privileges to work with storage account contents. So to do that, I'm going to go click the home link in the upper left of the portal. I'm going to go to my storage accounts, and I'm going to open up a storage account where I want the user to have privileges to upload blob content using AZ copy. So I'm going to open up a storage account. Let's say store account YHC 889. When I open up that storage account, I'm going to click in the navigation bar on Access Control IAM. From there, I will be able to add a role assignment for Lucas Brenner so he can read and write to and from the storage account. So I'm going to click the Add button over in the upper right. I'll choose Add Role Assignment. And what I want to make sure Lucas Brenner has the ability to do is contribute to the storage account. And there's a role for that purpose. So from the list of roles, I'm going to filter for storage, and immediately I see storage account contributor. I'm going to select that role, and I'm going to go down in the select field below and type in Lucas to filter the list of users. And then I'll click on Lucas Brenner, click on Save. And at this point, Lucas Brenner has the storage account contributor role for the particular storage account we're looking at, store account YHC 889. I'm going to add a second role assignment. So I'm going to click the Add button at the top. I'll choose Add Role Assignment. This time, I want to add a role assignment. And specifically, the role in this case is going to be for storage blob. And then I want the storage blob data contributor role. Again, for the same user, Lucas Brenner, that's who we're using in our example. So I'll select that Azure AD user account. That's an account I've created previously. I'll choose Save, and then it's done. I'm going to scroll down in the navigation bar in the storage account properties until I can actually get down to properties. I'll click that, open that blade. The reason I want to look at this is because I want to look for the primary blob service endpoint. On the right, that's a property labeled as blob service, so I can go ahead and copy that because I need to refer to this storage account blob service endpoint when using the AZ copy command. Back here in the command prompt on my on-premises system, now I'm going to run AZ copy make, and in double quotation marks, I've placed my primary blob service endpoint URL that I copied, but what I've added to the end of it is a slash, a front slash, and the name of the container I want to create. I want to create a blob container to organize the uploaded blobs. And I'm going to call that container East Projects. So I'm going to go ahead and press Enter to create it. It says it successfully created the resource. Back here in the portal, I can list blob service containers. I'll have to click refresh, but after a moment, we can verify that it did create the East Projects blob container. The next thing I'll do is run AZ copy because I want to upload some on-premises files into my blob container that I just created a moment ago. So for that, I'll use AZ copy, copy, and in double quotes, I'm going to specify a local drive letter and path for files. Here, I'm going to use a wildcard so that I gather all txt files in the local sample files projects folder hierarchy on drive D on my on-premises machine. The next parameter is where that is to be stored in the storage account. So in double quotation marks, I've once again specified my primary blob service URL that I copied previously, and at the end I've added a front slash and projects because I want to upload the project.txt files into the East project's newly created blob container. So I'm going to go ahead and press enter to make that happen. We then get some statistics listed below. We're looking for the total number of transfers that completed. In this case, it's 3 files. There are no failed or skipped transfers. Let's go back into the portal for a second and check to see that those blobs are there. So here in the portal, I'm going to open up the East project's blob container. And sure enough, after a moment, we'll have a listing of the project.txt files that were uploaded as a result of using the AZ copy syntax. The final aspect of the AZ copy command that we will examine is copying blobs from a storage account and downloading them to an on-premises device. So for example, I can use AZ copy, and the first parameter here in double quotation marks is going to be a reference to the storage account blob URL and the folder, the container, which in this case is East Projects, and the file within it that I want to download. In this case, it's a file that we uploaded previously. It's called project_a.txt. That's the first parameter. What is the URL path that points to that file in that blob container that you want to download? The next parameter, also in double quotes, is going to be where you want it stored locally and what you would like it to be called. So I want it to be stored locally on drive D under the TMP folder, and I want it to be called downloaded_project_a.txt. Let's go ahead and press enter to make it happen. It won't take very long because it's just a tiny text file. But as we had previously, when we uploaded content, uploaded blobs to the storage account, we can refer to our statistics to determine if the transfer completed successfully or not. So we don't want anything for failed or skipped. We want those to be values of 0. But we do want our number of transfers completed, in this particular case, to be a value of 1. So now if I do a dir of drive D _TMP and \down, let's say for downloaded, *, make sure I spell the folder correctly here, we get verification indeed that that file has been downloaded from the storage account down onto our local on-premises device. Over time, you can end up with a lot of content, a lot of blobs in your Azure storage account. So it makes sense then to enable lifecycle management to automatically move items after a specific period of time since they were created or modified to a different type of storage, such as the cool access tier to save on costs, or maybe into the archive tier. To get started here in the portal, I'm going to open up an existing storage account. What we want to do is enable lifecycle management for the blob service. And what that's telling me is I need to go under the blob service section in the left-hand navigator. So I'm going to go ahead and navigate or scroll down to blob service, under which I will have the option of clicking on lifecycle management. So I'm going to go ahead and do that. What we have to do here is add a rule and then determine the scope that it applies to. Do we want a rule to look at blobs in the entire storage account, or maybe only in specific storage account containers or only certain file types? It's up to us. So let's begin by clicking Add Rule up at the top. I'm going to name this rule Rule 1, and down below I have options to move blobs to cool storage a specific number of days after they were last modified, or to move blobs to archive storage for long-term storage. Cool storage is used for infrequent access at a lesser cost than the hot access tier, but archive storage is for long-term storage. So same thing, certain number of days after the blob was last modified. Deleted blobs. We can delete blobs automatically a specified number of days after they were last modified. So we have a number of different things we can do since a blob was last modified. We can also delete blob snapshots a specific number of days after the blob is created. What I want to do is move blobs to cool storage if they haven't been modified after 60 days. I want to do that because they can't be that important if they haven't been touched in 60 days. Have them hang around. We might be forced to do that for regulatory compliance. So I'm going to move it to cool storage to save on costs. I'm going to click the next filter set button at the bottom. The filter set is used, as it implies by its name, to filter which items, which blobs in this storage account that you want affected by your lifecycle management rules. Now, if you leave everything empty, every blob will be checked to see if it meets the criteria such as the 60 days after modification. Otherwise, you can specify a path and even use wildcards for certain file types. I want the entire storage account, its contents in terms of block blobs, to be checked against my rule. So I'm going to click the Next Review and Add button down at the bottom, and I'll click the Add button in the bottom left to add this rule. So the rule is enabled. At any point in time, I can select the rule and disable it, for example, temporarily if I don't want it applied for now, or I can delete the rule. And we can also add additional rules if we have requirements for different settings for lifecycle management for the blobs in the storage account. So in this course, we've examined how to use the GUI and command line tools to upload and manage storage account blobs. We did this by exploring how to use the Azure Storage Explorer tool to manage a storage account, how to use the portal, PowerShell, and the Azure CLI to upload blobs, and also how to use the Azure Storage Explorer tool to manage blobs. We also examined how to enable blob versioning and how to use the AZ copy command line tool to manage blobs. Finally, we examined how to control the migration of storage account data over time using lifecycle management. In our next course, we'll move on to explore methods for securing storage account data and network access, including account encryption, access keys, and container access levels. To protect data at rest within an Azure storage account, you need to think about the available security options and which ones should be configured and how they should be configured. So when it comes to Azure Storage Account Security Planning, the first consideration is network access. From which networks? That would include VNets and or the internet or on-premises IP addresses. Where should we allow access from to access the storage account and its contents? This can be configured when you initially deploy the storage account, and you can set it up after the fact as well. 2 access keys are provided with every Azure storage account. Either one can be used to authenticate to the entire storage account, whether from code or using GUI or command line tools. The keys can also be rotated, which they should be periodically, to enhance security. We can also generate a shared access signature or a SAS, an SAS, for the entire account, meaning we might enable a shared access signature to allow the reading of blobs in the account, but we could also go to an individual specific blob and enable a shared access signature. Shared access signatures can have an activation date and time of when they are effective, when they can be used, and also an expiry date and time after which they are no longer valid. We can also configure container access levels for blobs to determine whether we want to allow anonymous access or not. So for example, for a static website, you might want to allow anonymous access to a container that holds files that are designed to be made publicly available without users authenticating. And then there are RBAC, or role-based access control, roles, both built in, and we can also define our own custom roles, that can be used for managing Azure resources, including various aspects of a storage account. So if you have an assistant Azure technician that should only have the ability to work with blobs in a storage account, you can do that through an RBAC role assignment. Advanced Threat Protection, or ATP, is available in the storage account as it applies to blobs. The purpose is that it will look for and detect abnormal or suspicious activity, and notifications as a result of that are sent into the Azure Security Center. Encryption of data at rest is actually automatic with Azure storage accounts. It's enabled using AES 256-bit encryption, but the default configuration is that it is Microsoft managed keys that are being used. You can change that up after the fact if you want to by configuring customer managed keys, such as those that you might import or generate within an Azure Key Vault. We can also add immutable blob storage configuration policies to a storage account. They come in 2 forms: time-based retention and legal hold. When you configure time-based retention, as the name implies, you are setting a time period where content is locked, and you can't remove that once the lock is turned on. Whereas legal hold means that you are associating your policy with one or more tags, and the tags are used to identify items for the legal hold. So usually it would be something like a case identification number, although it doesn't have to be for legal purposes. You might use legal hold as a policy type in your storage account simply to adhere to organizational security policies that require data to be submitted, but then not modified after it's been submitted. However, when it comes to a legal hold, when the related configured tags are deleted, then the legal hold is no longer in effect. And you can have both time-based retention and legal hold policy set for the same blob container, in which case the way it would work is after the time-based retention has expired, if you remove the tags for the legal hold, then data is no longer immutable. It's no longer read-only. Storage account encryption is enabled by default in Azure, but that's using Microsoft keys. In some cases, you might want to or might require, due to regulations, to use your own customer-managed keys to encrypt the contents of a storage account. And so the first thing we're going to do here in the portal to make that happen, in the All Resources view, I'm going to filter out everything but key vaults and storage accounts. So I'm going to uncheck Select All. I'm going to turn on the check mark for key vault, and I'll do the same thing down below for storage account, and I'll click outside of it to filter the list. I'm going to click on a key vault that I've previously created because within it, we're going to create a key that we're going to use to encrypt our storage account. So I'm going to go into the Keys blade. I'll click on Keys in the navigation bar, and I'm going to click the Generate Import button up at the top. If you already have key files that you want to use for this purpose, you can bring them in here. In the Options drop-down list, you could choose Import. You could also choose Restore, Backup, or Generate. I'm going to leave it on the default of Generate to generate a new key. I'm going to call it Store Account Key 1. It's going to be an RSA 2048-bit key. I'm not going to set an activation or expiration date and time, so it will always be available because the default is that it will be enabled. The key will. So I'm going to go ahead and click Create. And after a moment, the key will have been created, Store Account Key 1 in our key vault. So I'm going to go back to our filtered All Resources view, and I'm going to open up an existing storage account. The first thing we're going to do is we're going to take a peek at the existing state of encryption for that account. To do that, I'm going to scroll down in the navigation bar in the properties of that account, and I'm interested in clicking on Encryption. When I do that, it will reflect the default configuration of encryption being done using Microsoft Managed Keys. But I'm going to click on the option below that for Customer Managed Keys. Now, when I do that, down below, I can either enter a key URI or I can select it from a key vault, which I will do. Down below that, I'll then click the Select a Key Vault and Key link. I'm going to have to choose the key vault from the drop-down list, so I'll choose our key vault, within which, down below in the key drop-down list, I will select our Store Account Key 1 that we created previously. That's the key that I want to use to encrypt the contents of the storage account. So I'm going to go ahead and click Select. Once I've done that, it's all set up. I just have to put it in effect by clicking the Save button up at the top. There is a note at the top that states any existing content in the storage account will be encrypted with the new key, but that's going to be done with the background process, so it may take a bit of time depending on the volume of data that you have in the storage account. The default behavior when it comes to encryption for an Azure storage account in that it is protected, it is encrypted, so you're protecting data at rest, but using Microsoft Managed Keys. This can be verified by opening the properties of the storage account in the portal and then going down in the navigation bar to the encryption blade. So Microsoft Managed Keys is the default. And while we could set customer managed keys here in the portal, we can also do that using PowerShell. Now here in the portal, I've navigated to an existing key vault, and in its navigation bar, I've clicked on Keys to open the Keys blade. In the right-hand panel, we'll have a listing of keys that exist in this storage account. While we have one here for virtual machine encryption, we're going to be using PowerShell to create one to be used for encryption for data at rest in a storage account. What this means then is that the storage account is going to have the required permissions to this key vault to be able to do that. And that's the first order of business in PowerShell. We're going to make sure that we create an identity, a managed identity for the storage account so it has access to the key vault. So here in PowerShell, I've launched through Cloud Shell in the portal. I'm going to create a variable called $store account. It's abbreviated. And what's going to be stored in that variable is the result of running set-az storage account -resource group name. I'll specify the resource group -name. I'll specify the name of the storage account where I want to use customer managed encryption keys. And then I'll use the -assign identity parameter. So what I'm doing here is working with the system assigned managed identity for the storage account. So I'm going to go ahead and press enter. To grant the permissions in the key vault for the storage account, I'll then use set-az key vault access policy -vault name, and I'll specify the name of the vault, -object ID. What I need here is the principal ID property of the storage account. So I can get that by referring to our $store account variable .identity.principal ID. Then we have to give the permissions that are required for the storage account to get into the key vault and do what it needs to do. So -permissions to keys. We don't need permissions for certificates, but to keys. Wrap key, unwrap key, and get. So I'm going to go ahead and press enter. The next thing I'll do is create a variable $key, which will store the result of running add-az key vault key. I need to specify the vault in which I want to create the key. So -vault name, and I'll name the vault. -name, and I'll specify a name for the new key I'm creating. I'm going to call this key store account key 172. -destination will be software as opposed to an HSM hardware security module type of solution. And I'll press enter to create the key. Next, I'm going to store key vault information in a key vault variable called $key vault, which will store the result of running get-az key vault, -resource group name, and then -vault name with their respective values. So that'll be stored in the key vault variable. And finally, what I want to do is enable encryption on a storage account. And to modify a storage account using PowerShell, we use set-az storage account. -resource group name, specify the resource group, -account name, specify the name of the storage account that's in question, -key vault encryption, -key name, and then $key.name, -key version. Once again, our $key variable, .version property. And finally, -key vault URI, $key vault variable, .vault URI property. Let's go ahead and press enter. And it's done. Let's check our work in the portal. So I'm going to minimize the Cloud Shell. I'm going to go back home here in the portal, go to my list of storage accounts, and I'm going to open up the storage account in question. And what we want to do in the navigation bar is go down and check out the encryption. So I'm going to scroll down, and I'm going to click encryption. And in the right-hand panel, the encryption type will now be set to customer managed keys with a reference to the key in the key vault. You can use a storage account to host a static website. A static website is one whose content doesn't change. So you might have a website consisting of HTML files, cascading style sheets, maybe some graphics files, some content files users can download, and so on. But what's different between a static website and a dynamic one is that dynamic sites have server-side scripts that are executed to generate dynamic content. That is not supported. So if all you have a need for is a basic static site, this is very quick and easy to set up. So here in the portal, I'm going to open up an existing storage account where I want to host my static website. And in the navigation bar, I'm going to scroll down because under settings, there's an option called static website. I'm going to click on it, and it's disabled by default. So all I have to do here is click enabled, which gives me two options. I can specify an index document name. This would be the name of the home page for the site that I want popped up automatically when I hit the URL, which we'll see in a moment. So I'm going to specify index.html. That does not have to be the file name, but that's a file I've already got prepared by that name. So I'm going to upload it. So that's why I'm going to use that name specifically. I can also do the same type of thing, but for an error document. I'm not going to specify an error document path. So I'm going to click the Save button at the top. When I do that, it'll just take a moment for it to happen. I have a message stating that it's created a special container called $web. That's where I need to upload my static website content. It's just a regular blob container. We also have a primary endpoint down below that was generated for our static website. So the URL is https:// the name of the storage account .z9.web.core.windows.net. That's the DNS suffix that it will use. I'm going to go ahead and copy that because we're going to want to test that once we get some content uploaded. So to get that content uploaded, we just have to go to the $web container, and luckily there's a link to do that right here on this same screen. So how convenient. It's going to be empty, of course, by default, but no problem because we can click the upload button up at the top to get some content in here for the site. That opens up a blade on the right, the upload blob blade, and I'm going to select a few files to upload here. So I've uploaded an index.html file that I've created, just a simple sample website that refers to a logo file, logo.jpg. So the two files now exist in the $web container that was created automatically. So let's go ahead and test the URL in another web browser window. So when I connect to that URL, it'll pop up my sample web page, which in turn refers to that logo.jpg file. So we now have a static website being hosted through an Azure storage account. Every Azure storage account has two keys that can be used to access the contents of the storage account, so it provides full access to it. The benefit of using keys to access a storage account is it relieves you from having to create an Azure AD user account and give the appropriate permissions to use the portal to connect to the content in the storage account. Now, whether a user wants to use GUI tools or command line tools along with the key to access the storage account, either is valid. It's really up to the user at that point. So to get started here in the portal, let's open up an existing storage account and let's examine the two keys that we referenced are created by default. We can get to them in the navigation bar by going down under settings and clicking on access keys, where the two access keys and connection strings will be listed. You might need a connection string. For example, if you're writing code and want to make a connection to the storage account, an authenticated connection. The first thing I'm going to do is copy key 1. There's a copy icon over to the far right. It doesn't matter if you use key 1 or key 2. They both will provide full access to the storage account. You have two keys because you can rotate one key for security purposes while the other is still valid, wait a period of time, and then do the same thing in reverse, basically to keep changing the keys periodically to enhance security. So I'm going to copy key 1. And what I'm going to use is the Azure Storage Explorer GUI tool. This is a free Microsoft tool that I've downloaded and installed. And I'm going to make a connection to Azure using the storage account access key. Here in the Storage Explorer tool, in the left-hand bar, I'm going to click the plug icon, which is used to add a connection. When I do that, it opens up a connection dialog, and what I want to do is specify a storage account name and key. So I'll select that option, and I'll click Next. I'm just going to call this store account, that's the display name, and then I have to specify the key, which I will paste down below, and then the name of the storage account in Azure. Once those items have been specified, I can click the Next button in the bottom right, and on the connection summary screen, I'll click Connect. After a moment, it will make an authenticated connection to that storage account. So in the Explorer navigation bar on the left, it will automatically expand. There's the display name that we specified. It will expand that display name to show me the items within that storage account. So they are organized by the normal stuff, blob containers, file shares, queues, tables, and I could drill down, for example, under blob containers and see what's there and navigate through it and manage existing blobs, for example, or create blob containers, upload blobs, create a file shared folder, work with the storage queue, and so on. But this means that I don't have to use the portal, I don't have to use command line tools. I could use command line tools if I really wanted to with an access key, but this is about one way to get a connection to the storage account. Every Azure storage account has two access keys. You can use either one to gain full access to the contents of the storage account. There are two, because while one might remain static for a period of time, you can refresh the other. And you should refresh or rotate keys periodically for enhanced security. So here in the Microsoft Azure Storage Explorer tool, in the left-hand Explorer Navigator, I've already got a connection to a storage account using a key. The word key is in parentheses. And from here, I can navigate through the storage account, such as clicking blob containers, working with blobs, file shares, queues, tables, and so on. So currently it's working, is what we're trying to prove. What we're going to do is we're going to refresh the same storage account key that was used for this connection. And when we come back here, it will no longer work. So back here in the portal, I've navigated to that same named storage account and I've gone to the access keys blade in the navigator. We've got two keys, key 1 and key 2. Well, because I set up the connection in Storage Explorer, I know it was using key 1, which I'm going to refresh by clicking the refresh or regenerate icon. It asks me, do I want to do this? Because the current key will become immediately invalid. Okay, that's fine. Yes, I'm sure I want to do this. So after a moment, it will have regenerated the storage account key, key 1 specifically. Key 2 remains as it was. Key 1 is now different. So let's see what happens when we go back to Storage Explorer where it was using the old version of key 1. So here in Storage Explorer, I'm just going to kind of do a refresh, go back to projects, and maybe what I'll do is right-click on the project's blob container and choose the refresh option. After a moment, once it refreshes, and you can even click the refresh all link at the top of the Explorer navigation bar. But either way, after a moment or two, we're going to get a message that says it's unable to retrieve child resources as I try to drill down into the storage account because the current key that's being used, the old key 1, is no longer valid. Every Azure storage account has two access keys that provide full access to the entire storage account. There are two keys because you can keep one as it is while you refresh the second key. Now, you would do this because security rotation of keys is a good security practice instead of keeping them the same all of the time. So what we can do in the CLI then is we can refresh keys here just as we can in the portal or by using PowerShell. So to do that, I'm going to first start with the AZ storage account keys list syntax in the CLI. -- account name, I'll specify the name of a storage account, -- resource - group, the resource group it's in, and -- output table, because that's how I like to view the output of some of these commands. What will be returned are both key 1 and key 2, their values, from that storage account. Now, I want those available because when you refresh a key, it changes it. And so I want to be able to identify that that indeed has happened by looking at the change in the key. So to actually refresh a key, I'm going to use the AZ storage account keys renew syntax. -G for the resource group. You can use -G or -- resource - group, -G shorter. So I'm going to specify the resource group, -N for the name. Again, that's shorthand for -- account -name. Specify the name of the storage account, -- key, and I'm going to tell it I want to renew the primary key. Now that would be key 1, which currently begins with 1RH7JF. That's going to change in just a moment, so I'll press enter. When I press enter, it will return both key 1 and key 2. Key 1 will have changed because it no longer starts with 1RH7. But key 2 remains intact because we didn't specify that we wanted to change the secondary key, only the primary. So what this means then is that anyone currently using key 2, whether with GUI tools like Storage Explorer or through command line tools, they will still have full account access. However, any code or any tools that are using key 1 will no longer work because we have just renewed or refreshed key 1. PowerShell can be used when you want to refresh storage account access keys. Storage accounts have two access keys, and either one of them can be used by code or by tools, whether they're command line or GUI based, to have full access to the storage account. But you can refresh them periodically for security reasons, so it changes them. And that's what we're going to talk about here. So the first thing I'm going to do here in PowerShell is I'm going to use the get-az storage account key PowerShell commandlet. Now I have to specify a resource group name and a name of a storage account that I want to get the keys from. Now, all of that in my example is within open and close parentheses. That's one statement that I want executed unto itself. But outside of that closing parentheses, I have a dot because I want to call upon the value property. The value of what? The value of the storage account keys, of which there are two. It's an array. So because there are two items, if I want to retrieve the first item, after dot value, I'll use the array notation. So that means within an opening and closing square bracket, I'll put in 0 because the first item starts counting at 0, not 1. And if you've done a lot of coding over the years, you're probably used to the fact that most arrays start counting at 0. I'm going to go ahead and press enter. And what it will do is return the primary or key 1 from the storage account. We can also retrieve the second key because there are two of them in every storage account. So why don't we just bring that previous command back up by hitting the up arrow key once on the keyboard. And why don't we just change value 0 to value 1? That will return the second key. So we have the value returned for key 2. So we know now how to use PowerShell to retrieve these storage account access keys. The next thing we're going to do is we're going to refresh one. Now, the way that we do that in PowerShell is by using the new -AZ storage account key commandlet. We specify -resource group name and -name for the resource group name and the storage account name, respectively. And then what we do is specify the key. So -key name, we can either specify key 1 or, as I'm doing here, key 2. When I press enter, it will regenerate or refresh key 2. Now I can verify this by using my up arrow key to bring up previous commands back to the command where we retrieved value 1. The value 1 item in the array would be the second key. If we compare its current value, currently it starts with YME2. Well, if we compare that with its previous value from earlier, it started with PM2H. It's different. And of course it's different because we've just refreshed the second key. Now, any existing code or tools or utilities that are using key 2 will no longer work to be able to access the storage account. They would have to be configured with the new value for key 2. Of course, anything that would have been using key 1, which is value 0 in the array, will still work as it always did because we haven't refreshed it. There are times when others, such as software developers, might need limited access to a storage account for a period of time. And so instead of providing storage account access keys, there are 2 for every storage account by default, and they provide full access to the storage account. Instead of that, it might be better from a security perspective to only grant access to what is required for the time period required. And that's where shared access signatures, or SASs, come in. So how does this work? Well, let's begin here in the portal by going into an existing storage account. In the storage account, of course, if we take a look at the access keys blade, if I click access keys on the left, on the right, I will be presented with the 2 default keys and connection strings. So you will use the connection string or the key depending on which tool you are using to make a connection to the storage account, whether it's through code or with command line or GUI tools. You can use either key 1 or key 2. It doesn't make a difference. But the only problem with this potentially is it is providing full access to the entire storage account and its contents. Well, what if we don't want that? As we've said, that's shared access signatures. That's where that kicks in. So I'm going to click shared access signature over on the left. On the right, I have to determine the allowed services through this shared access signature. So blob, file, queue, and table are all selected. I only want, in this example, developers to have access to blobs. So I'm going to uncheck file, queue, and table. I want to allow access to the blob service. So service is now selected under allowed resource types. But if I also want to actually allow access to blob containers and blob objects, then I would turn on those options as well. So I've turned on all 3 items under allowed resource types. For blobs, we can then determine the permissions, whether they be read, write, delete, list, add, create. Those are all selected, and I'm going to leave them turned on. We can also enable blob versioning permissions if we want to allow versioning to occur. And then the start and expiry date and time. So the start, date, and time determines when this shared access signature becomes effective and can actually be used. The expiry, of course, means when it expires and can no longer be used. We can specify IP addresses, which will allow connections from those locations to use this shared access signature. And then we can specify the signing key, whether it's key 1 or key 2. Those are the storage account access keys. It really doesn't matter which one you use, as long as you're not going to be refreshing the key soon, which would invalidate this shared access signature. So I'm going to use key 1, and I'm going to click the button below it labeled Generate SAS and Connection String. And when I scroll down, it will have generated 3 items: a connection string, a SAS token, and a blob service SAS URL. Depending on how you want to access the storage account, which tool you're going to be using, whether you're writing code or whether you're using a GUI or command line tool, will really determine which of these 3 items you're going to use. In this case, I'm going to use the free GUI Azure Storage Explorer tool to connect. So I'm going to copy the blob service SAS URL by clicking the copy icon over to the far right of that field. Here in Storage Explorer, I've already got a connection listed in the Explorer part of the window on the left that makes a connection to my entire Azure subscription. But we're going to add a separate connection using only the shared access signature. And to do that, in the left-hand navigator, I need to click the Open Connect dialog box. From the drop-down list on how to connect to Azure Storage, I'm going to choose Use a Shared Access Signature, or SAS URI. I'll click Next. I'm just going to go ahead and paste the SAS I just copied into the URI field, which in turn populates everything else for me. Too convenient. So I'm going to click Next. Let's move on with this. I'll click Connect. And after that's done, in the Explorer navigation bar on the left, there will be a new entry that uses the name of the storage account by default, and in parentheses we have SAS, SAS, under which I can then drill down into blob containers and ultimately selecting blob containers and accessing blobs, all using a shared access signature which has an expiry date and time. In this demonstration, I'm going to configure immutable blob storage within an Azure storage account. The reason I would do this is because I need a mechanism by which data in a storage account, blobs, binary large objects, are protected from modification, either from a time-based perspective, as in a time retention type of policy, or legal hold based on tags. So to get started here in the portal, I'm going to open up an existing storage account. And in this case, for testing purposes, I'm going to create a new blob container. So I'm going to scroll down in the navigation bar, going to click Containers, and I'm going to click the Add Container button up at the top. And I'm going to call this Immutable, only for clarity's sake in this demonstration, and I'll leave the public access level to private. I'm going to go ahead and click Create, and after a moment, we will have our immutable blob container, which I will click on to open up, and I'm going to click the Upload button. And over in the Upload Blob blade that will open up over to the right, I'm going to specify a few sample files that I'm going to upload into this container. Once the files are uploaded, I'm going to close the Upload Blob blade over on the right with the X. Now we are currently inside of our container, which has a name of Immutable. In the left-hand navigator for that blob container, we have access policy. This is important. This is where you go to set up either your time-based retention policies or legal hold policies, or both. So I'm going to click Access Policy. In the right-hand panel under Immutable Blob Storage, we currently have no policies. So I'm going to click the Add Policy button down below that heading. From here, in the drop-down list, I can select from either time-based retention or legal hold. It's on legal hold by default, where I can add a tag. This is the association with the legal hold policy. However, I could, from the drop-down list, instead choose time-based retention, which I'm going to do here. I'm going to set a retention period of 7 days. I can also turn on the checkmark down below to allow appends to blobs beyond after it was initially created. I'm not going to turn that on, and I'm going to click OK. After a moment, our time-based retention policy set for 7 days will be configured. It'll show up in the list. I'm going to click the Overview blade once again to go back to the contents of our immutable blob container. Now, before we go further, bear in mind I haven't yet completed the operation. In other words, I've got the policy created, but it's not been really turned on. So that means that if I were to select an item here that I want to delete, a blob, so I'm going to go ahead and click the context button over on the far right. I'm going to choose Delete, and I'm going to choose OK. the file or the blob is not deleted, and we get a message in our notification area in the upper right to that effect. It states, failed to delete blobs, the operation is not permitted as the blob is immutable due to a policy. Well, that's correct, so that's working. But what's up with the locking option? Well, if we go back to the access policy, the locking option I'm referring to can be set for the policy. The policy is shown currently with the state of unlocked, but that doesn't mean it's not in effect. It is in effect. However, if I click the context menu button on the far right, I can choose to delete the policy. That's interesting. Well, from that same menu list, let's choose lock policy. I'll type yes for confirmation because what it's telling me is that this is irreversible. So I'm going to go ahead and click OK. Now the state is shown as locked, and when I click the context menu on the far right, I cannot delete the policy. And that's where locking comes in. When you lock the policy, you are doing just that, locking it or preventing it in itself from being deleted. When the policy is not locked, the time-based retention policy is still in effect for storage blob. You can set container access levels within a storage account to determine whether or not anonymous access to those containers and the blobs within them is allowed. To get started with this in the portal, I'm going to open up an existing storage account. And in the properties, in the navigation bar for that storage account, I'm going to scroll down, and under blob service, I'm going to choose containers. You can think of containers as being like folders to organize content. So I've already got a container here called projects, and if I open it up by clicking on it, I've got a number of sample project text files that I've already uploaded. When you are in a container, as we are here, you will have a change access level button available at the top. Actually, if I go back one level, even if I just put a checkbox next to the name of the container, I can also get to change access level at the top that way also. Doesn't matter either way. I'm going to click change access level. Now the default setting here is set to private, no anonymous access. Okay, we're going to test out the default first. Now to do that, I really want to make sure I try to open up a specific blob within the container. So let me go into projects. Let me click on one of the blobs that was already uploaded, one of my sample files, because in the properties blade that opens up over on the right, at the top, I have a URL for that specific blob that I can copy. So a direct link to it. So I'm going to click the copy to clipboard button to do that, and I'm going to open up a new web browser window and test that URL. As is expected, it can't find it. Resource not found, the specified resource does not exist. We get all of this returned message because we don't have access to it. It's private by default. Let's go back into our storage account and let's change the access level for the container. So instead of private no anonymous access, we could select blob, so anonymous read access for individual blobs only, which would work for what we're doing right now. We could also enable container, anonymous read access for containers and blobs. So being able to list the contents of containers and so on. I'm going to choose blob, anonymous read access for blobs only, and I'm going to click OK. Now this is for anonymous access. This has nothing to do with people that authenticate to Azure with a username and password, for example. So let's go back into our other web browser window where we were testing the URL. Previously, we got this resource not found message. So I'm going to go ahead and click the refresh button in my browser to refresh the page. After a moment, when I do that, and I might have to refresh a few times if I've just made the change, but that's normal. What will happen is we will then be given access to that file. So either we are prompted to download the file if it's not directly supported within the browser, or in our case, it shows us the contents of the file because it's simply a text file. You can generate a shared access signature for an individual blob within a storage account. Now, you can also generate a shared access signature for the entire storage account, such as to allow access to multiple blobs or tables or queues. For example, here in the portal, why don't we open up an existing storage account and poke around a little bit? The first thing we'll do is scroll down in the navigation bar, and under the settings section, I'm going to click shared access signature, because this is where we could generate a shared access signature at the storage account level. So on the right, we could determine if we wanted to allow access to blobs, Azure files, shared folders, queues, tables, and which specific allowed permissions. And we could also, if I scroll down a little bit, determine a start date and time of when the shared access signature is valid, and an expiration date and time, and so on. Now that's for the entire account, but we can also generate a shared access signature for one individual blob. So to do that, we have to navigate to it first. So how about this? In the navigation bar on the left, I'm going to scroll down, and under Blob Service, I'll click Containers. I have a number of containers that I've already created here and uploaded content into. One of the containers I've created is called Projects. I'm going to open up that container where I've got a specific file called project_a.txt. I'm going to click directly on that blob entry to open up the properties blade over on the right, because when I'm in there, I have a Generate SAS option. I'm going to click on Generate SAS. So I have to determine the permissions for this selected blob. The default permission that's selected is only read, but you could choose create, write, delete. I'm going to leave it on read. Much like at the storage account level, I can set a start and expiry date and time of when the shared access signature can be used, when it's valid. And we can also specify allowed IP addresses and generate the SAS token and URL using either key 1 or key 2 in the storage account. I'll use key 1. So let's get this done. I'm going to click the Generate SAS Token and URL button at the bottom. Then when I scroll down, I've got two items that were generated, a blob SAS token and a blob SAS URL. I'm going to go ahead and copy the blob SAS URL because the way I'm going to test this is not by writing code, where I might want to use a SAS token, but instead I'm going to simply plug it into my web browser. When I plug in that shared access signature for that individual blob, it will either prompt me to download it because I do have read access to it, but because it's a known MIME type in the browser, instead of prompt me to download it, it simply displays it, which is nothing but a sample text file, which is being shown on the screen. Most of us have probably had the unpleasant experience of deleting something important. That's where blob soft deletion becomes useful. In a storage account, you can enable this feature. It's off by default, so that if you've mistakenly deleted a blob, if it's been overwritten for some reason, you have the ability to recover it. Now, this doesn't apply if you delete a container in which the blob exists, or if you delete the whole storage account, but when the individual blob itself is deleted. So to enable storage account soft deletion for blobs, what you need to do is first navigate to the storage account, which I'll do here in the portal. In the navigation bar for the storage account, I need to go down under the blob service setting, and I need to click on data protection. There are a number of offerings that will be available here, but the only one that we're interested in is blob soft delete, which is disabled by default. So I'm going to click enabled. When I do that, I have an option down below to set the blob retention period, which is defaulting to 7 days. So you have 7 days after a blob is deleted in which you can recover it. After that, it's purged and no longer available. So I'm going to go ahead and click the Save button to save that option. We're going to test it out. So to do that, here in the portal, you don't have to use the portal, but we are since we're already here. I'm going to click Containers on the left, and I'm going to click on Budgets. I've already got a container I've created called Budgets that has a couple of sample files within it, one of which is called project_b_budget.xls. That's the one I'm going to delete for testing purposes. So I'm going to select that item by clicking the checkbox to the left of the blob, and I'm going to click the delete button at the top. I can opt to delete blob snapshots if I have any. I'm just going to go ahead and click OK, and it disappears from the view because we've deleted that blob, that file here in this blob container. Now, when you're looking at a container as we are, you will have an option, a toggle switch at the top labeled as Show Deleted Blobs. It's not enabled by default. I'm going to click to toggle that option on. When I show deleted blobs will then appear in the list, but they will have a status of deleted, where normally the status is shown as active. If I were to click directly on the name of that blob to open up its properties blade over on the right, and then if I scroll down to the bottom of those items, there is a button labeled Undelete. So I'm going to go ahead and click undelete to recover that. Now I have 7 days to do that based on our configuration. The default retention period for deleted blobs is 7 days. You can change it, but that is the default setting. So let's go take a look at this. First of all, by closing out of our blob properties and clicking the refresh button up at the top. Storage accounts can sometimes contain sensitive information, and so you might want to limit access to that storage account. And one way to do that is by configuring network access. So to do that here in the portal, I'm going to open an existing storage account. So I'll open up its properties. And in the navigation bar, I'm going to scroll down under the settings section, and I'm going to click on firewalls and virtual networks. You get to specify this when you create the storage account, but as we're doing here, you can also change it afterwards. So the default is to allow access from all networks. That would be all VNets in Azure. But what I can do here is choose selected networks, which opens up a new bunch of settings down below. So the first thing I would have to consider is whether I want to add an existing VNet that I've got created in Azure, or if I want to add a new one. I want to add an existing one. I've already got a whole bunch of them, and I want to limit their access to this storage account. So I'm going to click Add Existing Virtual Network. And from the drop-down list, the first thing I do is select the VNet. Let's say I choose VNet 2 from the list. Then I have to choose one or more subnets within VNet 2. I've only got 2 subnets, but I can also simply choose Select All to select all of the subnets. Now, how would you know to do this? How do you know what to select? You have to think about how you're using your storage account and what type of data is stored within it. Perhaps it's got data that's required by a front-end web app, and the front-end web app is maybe running in those subnets. There are components running in the subnets we've just selected in VNet 2. And so you want to allow access to the storage account from services running in those subnets. So you have to think about which workloads are running, where they are running, and what they need access to. So I'm going to click Enable to do this. After a moment, the fact that we've added VNet 2 and subnets 1 and 2 as having access to the storage account will be reflected down below. But there's more that we could do. We could also add our client IP address. It already has my public IP address for the station I'm using to run this interface, the portal. That's the public IP address on the public side of my NAT router. I do want to add that, so I'm going to turn on that check mark, but we can also specify in the address range field other IP addresses or CIDR ranges of IPs. We have exceptions down below. For example, the Allow Trusted Microsoft Services to access this storage account is already turned on. Trusted Microsoft Services would include things like Azure Data Box, Azure Backup, and so on. So I'm going to leave that as it is. So to put this into effect, I'm going to click Save up at the top. And after a moment, it's done. Any services running in subnets 1 or 2 and VNet 2, as well as myself from my on-premises IP address range, we will be able to access the storage account and potentially all of its contents, depending on how we're connecting, using a storage account access key or a shared access signature or within an Azure storage account, you can configure a private endpoint. You do this, you're creating a separate Azure resource. A private endpoint is its own type of Azure resource. And the private endpoint allows clients within an Azure virtual network to access the storage account through a private link that uses the Microsoft backbone. In other words, it doesn't traverse the internet. Let's get started here by opening up an existing storage account. When it opens up the properties for that storage account, what I'm going to be interested in doing is scrolling down in the navigation bar for that storage account. Because if I go down under settings, the settings section, I will have an item shown here in the menu named Private Endpoint Connections. I'm going to go ahead and click on that. Now, this is not the same thing as going to firewalls and virtual networks and choosing selected networks and specifying subnets or IP addresses to allow connectivity. We're really talking about allowing a specific client or a service access to a storage account when we talk about a private endpoint connection. Let's go back to private endpoint connections, and at the top, let's click the Add Private Endpoint button. That's going to take us through a multi-page wizard. So the resource group and the subscription are filled in. I have to give a name here for it. I'm going to call this private link or endpoint 1. And for the region, I'm going to specify here Canada Central. Remember, it's making its own separate Azure resource here. So I'm going to click Next Resource down at the bottom. So the resource type that I want to make connection to is a storage account in this particular case. So down in the resource type drop-down list, from that list, I'm going to scroll through and make sure I select Microsoft.storage/storage accounts. Then in the resource drop-down list, I'll choose the specific storage account. Let's say in this case, my store account AZ-304. In the target sub-resource drop-down list, remember that in a storage account, we have a number of different items that can be stored, like blobs, tables, queues, Azure files, and so on. Now, if we have replication enabled to a secondary region, we'll be able to select which copy of blob or tables or queues and so on that we want. In this case, I'm just going to choose blob, and I'm going to click the Next Configuration button down at the bottom. Because the private endpoint will use an IP address from a VNet range, I need to specify the VNet and subnet. So I'm going to choose a VNet and a subnet from this list. Down below for connectivity, it's going to integrate with the private DNS zone, and we've got a private DNS zone here that's going to be used, private link.blob.core.windows.net. So I'm going to click the Next Tags button. I'm not going to add any tagging information, but I will click Next, Review and Create. And after the final validation has passed, I will click Create in the bottom left to create our private endpoint. After a moment, the deployment is complete, so I'm going to click the Go to Resource button to open up the properties of our private endpoint resource. In the overview blade for the private endpoint in the right-hand panel, there is an association based on our configuration with a VNet and a subnet, and also a network interface, which is a link. If I click on the link for that network interface, it takes me into the details, and I also have a private IP address available over on the right, here in the overview blade of the network interface. Now, if I go back into my list of storage accounts here in the portal and open up that storage account, we're just going to take a look at the private endpoint links that are defined. So when I do that, we've got a configuration, so it will appear in the list. I can also go to firewalls and virtual networks, so I can use these two items together. If I were to configure allow access from selected networks, and what I could even do is remove any existing networks that might have been configured with access. So I'm just going to click on the context menu on the far right next to the VNet that's listed and remove it. Same with any IP address ranges, I can remove those. So what I'm really doing by saying allow access from selected networks, but nothing is shown here, is I'm really saying I only want to allow access from a private endpoint within the VNet that was configured, VNet 1 and Subnet 1, so VMs within that subnet. I'm going to go ahead and save this configuration. Now, once this configuration has been saved, and we'll see it shown up here in the upper right in the navigation panel, I can then test the connectivity, even here in the portal. So what that means is, let's say that we wanted to go down to blob servers and containers in the navigation bar, and I'm going to try to open up, let's say, a blob container, let's say projects. Well, I'm going to get an authorization failure message that says you do not have access, because I don't, because I'm currently on an on-premises system using the Azure portal. That's a public IP address. Private endpoints are only available through a private IP address. Now, let's just go back to home here, and I'm going to open up the All Resources view because there was a DNS issue, something about a DNS name being created and so on. So in my All Resources view, I'm going to filter the types by unchecking Select All. I'm going to go down to the Ps and turn on Private DNS Zone. And I'm going to click outside to put that in effect. So here's the private DNS zone that was created. It's called privatelink.bob.core.windows.net. If I click on it, I'll see that it will have created an A record, a DNS record set with the name of my storage account. And it's got the private IP address that was assigned from the VNet that we associated our private endpoint with. So that means that Services such as virtual machines within VNet 1, Subnet 1 would be able to connect to this name. This is the name of the storage account in the private link.blob.core.windows.net DNS domain, and that would resolve to the private IP address, thus allowing connectivity. So, in this course, we've examined different mechanisms available to secure storage account data and network access. We did this by exploring various methods of securing Azure storage accounts, how to use the portal and PowerShell to configure storage encryption, how to configure a static website and use storage account keys, how to refresh storage account keys using the portal, PowerShell, and the CLI. We examined how to work with the shared access signature, a SAS, how to encrypt a storage account using custom encryption keys, and how to enable storage account failover. Next, we examined how to set a time-based retention policy on a blob container and how to set the access level for a container. We examined how to generate a SAS for an individual blob and how to use the blob soft delete feature, how to limit VNet access to a storage account, and finally, how to limit storage account access with a private endpoint. In our next course, we'll move on to explore Azure Files, a cloud-based shared folder solution, including how to use the GUI and command line tools to configure, manage, and connect to Azure Files. You can use Azure Files to either supplement or even replace on-premises file servers. The reason for this is because Azure Files is a cloud-based shared folder solution, and clients can exist on-premises or in the cloud to make a connection to the shared folder in the cloud. In order for that to happen, the connecting client OS needs to support SMB version 3.0 or better. That means using a Windows client or Linux or a Mac OS client will allow the connection to occur. But you also have to bear in mind that from the connecting client's perspective, outbound traffic destined for port 445 needs to be allowed because that's the port number that is used for SMB connectivity. We can use not only GUI tools like the portal to configure Azure Files shared folders, but we can also use command line tools like the Azure CLI. So the first thing I'm doing here is listing out the storage account access keys because I can use one of them to authenticate to the account. So the first thing I'm doing is AZ storage account keys list --account -name, and I've specified the name of the storage account -G and its resource group. That will list out the two account keys, either one of which I can use to authenticate further. So the next thing I'll do is create the share using AZ storage share create --account -name. Once again, I'll specify the storage account in which I want to create this Azure Files shared folder definition, --account -key, and here I will have copied and then pasted one of the account keys that resulted from the previous command, after which I'll use --name to give a name to the share. I want to call it projects2 --quota, so I'm setting it to a maximum size of 100. The unit of measurement is gigabytes. Next, I can view the shares within a storage account using the AZ storage share list syntax. So --account -name, the name of the storage account, and then --query space, open and close square bracket .name means all I want to see is the name property for however many storage shares there are within that account. We can also use PowerShell. So the first thing I'm doing in PowerShell is creating a variable called $CTX, which stands for context. All I'm going to do with this variable is point to a storage account. So the context variable will store the result of running get-AZ storage account, -r for resource group, -name with the name of the storage account. And in the second line, I'm setting the $CTX variable equal to itself, $CTX dot context. And so I'm calling on the .context property. That's what we really need in our variable. In the third line, I'm creating a share name variable that's going to be called east-logs. Then in the fourth line, I'm using new -AZ storage share to create it. -name is going to be the $share name variable. -context is simply going to be our $CTX variable. That's easier than specifying the storage account name and resource group every time. Finally, I can use get-AZ storage share -context $CTX, to view the storage shares for a given storage account. In this demonstration, I'm going to configure Azure Files. What this really is a shared folder that supports the SMB protocol that's stored in the Azure cloud. So if you're already familiar with mapping drive letters to shares, or even using a Linux host and mounting one remotely, you can do the same type of thing here with Azure Files. So to set this up in the portal, I'm going to start by going to my storage accounts view, because you set up an Azure Files share within a storage account. So let's open one up. Now in the storage account properties, I'm going to scroll down in the navigation bar until I get down under the file service section. That's where I need to click on File Shares. Existing ones will be shown in the list. Currently I have none. So I'm going to go ahead and click the Add File Share button up at the top. I'm going to call this Budgets, and I can set the quota, which is in gig. That's the unit of measurement. So for example, maybe I'll set it to 100. And I'm going to go ahead and click Create. Now the quota, of course, limits the amount of data that can be stored within that Azure Files share. So at this point, that's it. I've got the share defined in the cloud. Now what I would normally do, of course, is populate it. So that could be done programmatically or through many different tools, including directly through the portal here. And that's what I'm going to do. So I'm going to open up the Budgets file share. And from here, I can add directories to organize items, and I can upload files. So I'm going to go ahead and click Upload. That's going to open an Upload Files blade, very much like what you would use if you were uploading files into a blob container. So I'm going to go ahead and select some on-premises files to complete this example. Once I've selected them, I'll click the Upload button. And because they are small files, they are uploaded very quickly, and they are now available in the Budgets Azure Files share. There is a button up at the top labeled Connect, and if I click it, this will provide instructions for Windows, Linux, and the Mac OS so that I could actually map a drive letter or create a mount point to connect to that Azure Files shared folder. You can use the Azure CLI to configure Azure Files shared folders. The first thing I'm going to do here in the CLI is get a list of storage account keys, of which there will be 2. Now I need this because one of the keys I will use to authenticate to the storage account when creating the storage share. So the syntax I'll use to list out the keys is going to be AZ storage account keys list. I need to point to the storage account, so I'll do that with --account -name and the associated resource group with -G. So I'll go ahead and press Enter. It returns both key 1 and key 2 because every storage account has 2 access keys. Now these keys can be used in programmatic code or through command line tools or GUI tools to gain authenticated access to the storage account. It doesn't matter which key is actually used. So to create the shared folder, I'm going to use the syntax AZ storage share create. Then I need to point to the storage account, which I'll do once again with --account -name. Then I need to specify the storage account access key I want to use to authenticate. I'll specify that with --account -key. And I've copied a key from the above output. Specifically, in this case, it works out to be key number 2, but it doesn't matter. I could have used key number 1 to achieve the same result. After I specify the account key, then I'm using --name. I have to give a name to this shared folder in the cloud. I'm calling it projects2, and --quota is set to a value of 100, where the unit of measurement here for that parameter is in gigabytes. So I'm going to go ahead and press Enter to build that shared folder. So what's interesting is we have a message that states we aren't authorized to perform the operation. Now that could mean a number of things. First of all, it could stem from the fact that we incorrectly copied the key, but key 2 has been copied successfully, so it's not that. If I were to minimize Cloud Shell here, and let's go into the storage account properties in the navigation bar, I'm going to go to Firewalls and Virtual Networks, because what's most likely the culprit, and indeed this is the case, is that selected network access to the storage account has been configured, and it doesn't include using the CLI here in Cloud Shell. So I'm just going to switch this back to allow access to the storage account from all networks. Now I'm going to do this knowing that it means what it says. It's going to allow access from all networks, including the internet. It still requires authentication, but that's fine. So I'm going to go ahead and click Save to put that into effect. And then I'm going to go right back into Cloud Shell. Let's clear the screen with CLS. I'll use the up arrow key to bring up our AZ storage share create command once again, and this time I'm going to press enter. I haven't changed it. And it returns true as a value for created. So we know then that the storage share was created in Azure Files. We can actually test that out at the command line here. We can also verify our work in the portal. Let's start here in the CLI by typing AZ storage share list -- account - name, and then the name of the account, of course. And I've added at the end here -- query, space after the word query, then open and close square bracket, because there might be many storage shares. So it's an array, .name. We want the name property for each item. So once we do that, it will return anything that existed previously as an Azure Files shared folder, one of which is budgets in my case, and then it will return the one that we've just defined projects to. Let's check it out in the portal. So I'm going to minimize Cloud Shell, and we know that Azure Files are enabled within a storage account, so we need to make sure we navigate to a storage account in the portal, and then in the navigation bar, we have to go all the way down under File Service and click File Shares. And then in the right-hand panel, we'll have a listing of any shared folders that were defined. And of course, as a result of our CLI commands, we will have projects 2 listed. You can use PowerShell to define a new Azure Files shared folder in the cloud instead of using the CLI or instead of using the GUI. To get started here, I'm going to create a variable called CTX, $CTX. That stands for context. What I'm trying to do here is set up a context or a pointer to a storage account so I can refer to this later with other PowerShell commandlets in a much easier way than specifying the resource group and storage account name every time. That's the only reason I'm doing this. So I'm going to store the result of running get-az storage account -r for resource group, and I'll specify that, -name, and then specify the name of the storage account, and that's going to be stored in a variable called $CTX for context. If I just type $CTX to return it back, it contains information about my storage account, which was the goal. So that's good. We have that done. But the next thing I'm going to do is type in $CTX equals $CTX.context. Now what we need to do is store the result of the .context property in our context variable. So now if we run $CTX to view it now, we've got a lot of endpoints that are returned because they're stored within that variable. And that's what we actually need for this to work correctly. So I'm going to make a variable called share name, and it's going to equal in double quotes, whatever I want to call it. How about east-logs? I want to store logs in the cloud in a shared folder. And I'm going to make a new shared folder. So I'm going to do that with new-az storage share. This is a shared folder in the cloud. -name is going to be our variable, share name, $share name. -context. This is where I'm going to use my $CTX variable. Once that's been completed, I'm going to type in get-az storage share -context $CTX, and I'll press enter. It will return all of the Azure Files shared folders within the storage account that's referenced with our context variable. And we will have in the list the one that we've just created, east-logs. And if we were to check our work in the portal, so if I navigate to the file shares blade within the storage account, and I'll have to click refresh since I already had it open, we will have a listing that includes the one that we just created, the one that we defined in PowerShell, east-logs. Azure Files provides a way in the cloud to host shared folders, much like you might host them on a file server on premises. So in this demo, we're going to take a look at how to map a drive letter to an Azure Files shared folder. The first thing we're going to do is take a look at the shared folder construct within a storage account. So to do that here in the portal, let's get to the storage accounts view and let's open up the storage account in question. In the navigation properties bar for that storage account, what I need to do to view Azure Files is to scroll all the way down until I see File Service and then choose File Shares. On the right, I will then be presented with a list of any already configured shared folders. I've got one here by the name of budgets, and if I click on it to see what's in it, I've got a couple of sample project budget files already uploaded here. We also have a connect button up at the top. Now, when you click on connect, you will be given instructions for making a connection from a Windows machine, a Linux machine, or Mac OS. We're going to do it from Windows, so we have to select the drive letter that we want to map. So let's say I'm going to map drive letter S. Then down below, we have the option of copying this PowerShell code so that we could run it on our Windows system to map the drive letter. So I'm going to go ahead and copy it to the clipboard using the supplied icon. The thing to bear in mind is that it needs, when I say it, I'm talking about the machine that is going to map the drive letter. It needs to be allowed to talk out of that network in an outbound direction through TCP port 445 for SMB, server message blocks. Now, the issue is that some internet service providers don't allow that outbound traffic for security reasons. And so you'd have to check with your internet service provider to see if that's available or not. Otherwise, you might have a problem trying to map the drive letter. So here on my Windows machine, I'm going to go to the Start menu and I'm going to fire up PowerShell. I'm going to right-click on it and run it as administrator. It's much too small, so we're going to increase the size. Once we've done that, then we'll be able to paste in the PowerShell code that we copied from the portal. So the first thing that's happening is it's creating a variable called $connect test result. It's using the test-net connection PowerShell commandlet against the computer name. It's already filled in the URL for our storage account, but it's using the .file.core.windows.net suffix -port 445. There's an if statement. If the connection test result is that it succeeded, then we're going to go ahead and save the password so that we can have a persistent drive mapping between reboots. And then we mount the drive in PowerShell with the new -ps drive commandlet. It is using drive letter S because that's what we specified back in the portal. Otherwise, if it didn't succeed, if the test for port 445 failed, we get an error message returned. So I'm just going to go ahead and press enter to actually execute this. And before you know it, it's completed. So even right here in PowerShell, if I were to go to drive letter S, S:, and for example, type dir, we would be able to get a listing of those sample project budget files that we saw over in the portal. We can also take a look here in Windows Explorer in the GUI. So if I were to expand this PC in the left-hand navigator, we're going to have a mapping, drive letter S in our case, to the Budgets Azure Files shared folder. And it's completely accessible from here. From a Linux machine, you can create a mount point that connects remotely to an SMB file share, including an Azure Files file share defined in the Azure cloud. Let's start here in the portal by taking a look at the definition of an Azure Files share within a storage account. So I'm going to navigate to the Storage Accounts view, and I'm going to open up an existing storage account. And in the navigation bar, I'm going to scroll down until I come across File Service and then File Shares. I'll click on File Shares. I have a file share by the name of Budgets, and if I click to open that up, there are some sample project budget files available. If I click the Connect button up at the top, it'll give me instructions on connecting from a Windows, Linux, and a Mac OS environment. Right now, I'm interested in Linux. So it's going to create a mount point. I can control the name of the mount point. Maybe I'll call it Remote SMB. And then down below, I can copy the commands required within the Linux environment to make the mount point directory and then to mount it. So I'm going to go ahead and copy that and run it within a Linux environment. So here in my Linux client, I've pasted in what I've copied, so I'm just going to go ahead and press enter. Now remember, in order for this to succeed, you need to make sure that from the perspective of the Linux client, outbound port 45 is open in any firewalls to allow the SMB connectivity. I'm going to type in mount. What I have listed in all of my mount points is I've got my local mount point folder as per my configuration. So here in Ubuntu Linux under /mnt for mount, it created the remote SMB folder, it's my local mount point, which is remotely mounted to my storage account budgets shared folder. So therefore, locally here in Linux, if I change directory to /mnt/remote SMB and clear the screen with clear and do an ls, I have access to the project files. I have made a connection over the network to that Azure Files shared folder. The Azure File Sync feature is related to the definition of your Azure Files shared folders within a storage account. What it does is it makes them accessible on premises. It allows local on-prem access to the contents of Azure Files shared folders, and of course, it's stored ultimately into the storage account in the cloud. Working with Azure File Sync means allowing access from clients on premises through SMB, NFS, and FTPS protocols. It also requires an Azure File Sync resource. The Azure File Sync resource is its own type of resource that you need to create in Azure, and within it, you need to define what's called a sync group. Now, the next thing is that sync group will contain the cloud endpoint for the shared folders in the storage account, but also a server endpoint. The server endpoint will not be available to be selected until you download and install the Azure File Sync agent on an on-premises server, a file server, and part of that installation, actually the tail end of it, is registering that host with Azure. And after you do that, you can finish configuring the sync group and Azure File Sync will be ready to go. The Microsoft Azure File Sync service allows you to present Azure Files shared folders that are defined in the cloud on premises. So therefore, it provides local access for on-prem clients. Before we can start with that, we need to first in Azure create an Azure File Sync resource. So to do that here in the portal, I'll click Create a Resource in the upper left, go to search for Azure File, and I'll choose Azure File Sync from the returned list, and I'll click on Create. So we have to create this resource and then configure it afterwards. So first things first, let's deploy the resource. I'm going to deploy this into an existing resource group. I'm going to call it Store Sync 172, and I'm going to deploy that in the Canada Central region where my storage accounts are. I'll click Next for tags, Next, Review and Create, and then I'll click the Create button to create this object. It won't take long before the deployment is completed, so I'll click the Go to Resource button to open up our newly created storage sync service. The reason we want to be in here is because if we look at the sync groups, they're also visible under the overview, but we can click sync groups on the left. We can determine whether there are any existing sync groups. Now, of course, there aren't because it's a newly created object. So I'm going to click the Add Sync Group up at the top. We have to make sure that we specify a sync group name. I'm going to call this SG1, and I need to select a storage account. So I'll click that button to do that. I'm going to choose a storage account where I know I have Azure Files shared folders defined that I want available through File Sync. So down at the bottom, I can then open up the Azure File Share drop-down list, and I have one there called Budgets. So I'm going to go ahead and click Create to create the storage sync group. The storage sync group will be created after a moment. I can click on it to open it back up, and within it, we will have a cloud point that was automatically configured when we made the storage sync group. It essentially points to our storage account, and more specifically, to our Azure Files shared folder. But there are no server endpoints. That's because we've not yet downloaded and installed the Azure File Sync agent on an on-premises file server, and it hasn't been registered with Azure yet. So that's going to be our next task. So I can go ahead and search up Azure File Sync agent in my web browser, which I've done, and then I'll get to the page where I can download it from Microsoft. So I'm going to go ahead and click the download button to get that started. Now, I have to select the appropriate platform. The on-premises file server I'm going to do this to is already running Windows Server 2019. So I'm going to be interested in the Storage Sync Agent ws2019.msi. So I'm going to go ahead and select that. It says the total size is approximately 52.7 megabytes. So I'm going to go ahead and click the Next button. And then I'm going to choose Allow Once for the pop-up about downloads. And I'm going to download and save this by clicking Save As. I'm going to save this in my Downloads folder, so I'll go ahead and do that. It won't take very long to bring it down. Once it's been downloaded, I'm going to click Open Folder at the bottom here so I can go take a look at that downloaded item. And I'm going to right-click on it and choose Install. So we're installing from the MSI installer that we just downloaded. So it's going to start the setup wizard. I'll click Next to proceed through it. I'll click Next to accept the license agreement. And Next again to install the Azure File Sync agent in the default storage location on drive C. Next for that. We're asked if we have to go through a proxy server to get to the internet. We don't, so I'll just click Next. And we'll use Microsoft Update if there are any software updates for file sync. So next again. And I'm not going to, well, actually, I will turn this on. Automatically update when a new version becomes available. So we may as well turn that option on. So we're always running the latest version of the storage sync agent. So I'll click Install, and it's beginning. And before too long, the wizard will have completed. So I'm going to go ahead and click the Finish button. It's then going to check for any updates. It says the file sync agent is fully up to date. Okay, so I'll click the OK button. Now we have to sign in and register the server with Azure. So Azure Public Cloud is our environment as opposed to Azure US Government Cloud. So I'll go ahead and click Sign In, and I will sign in. Once I've successfully authenticated, I can choose the subscription from the drop-down list, a resource group, and finally a storage sync service. The one we created is called StoreSync 172, and I'll click the Register button. And before you know it, it'll state registration successful and the network connectivity test will have passed. Perfect, we're all done on the server, at least on premises, so I'm going to click Close. Now, as a point of interest, let's take a look at the file system on this on-premises server. It has a disk volume drive E, and it's got a folder called Budgets, in which I've got a couple of sample on-prem files. Back here in the Azure portal, I'm still in the properties of my StoreSync service looking at my sync group SG1. I'm going to open it up. Now remember, we already had a cloud endpoint defined when we first created this, but not a server endpoint. It still says 0 server endpoints. So we want to change that. We want to add one. So I'm going to click the Add Server Endpoint button up at the top. You can only do this, though, after the server has registered, as we've just completed. So from the registered server drop-down list, I'll see the server name where we just installed and configured the agent. I can specify the path, for example, drive letter E:/budgets. That was the path that we just looked at on our on-premises file server. Down below, I'm going to enable cloud tiering because I essentially want data stored in the Azure Files Cloud Share in the cloud. I want that to be cached on the server for local access for on-prem clients. So I'm going to enable cloud tiering. I'm not going to do anything. I'm not going to enable offline data transfer through DataBox. So I'll leave that as it is disabled, and I'll click the Create button. After a moment, we'll now have a server endpoint listed down below. The health currently states that it is in a status of provisioning. Then the status or the health will switch to pending. If we were to look at the file system of our on-premises server on Drive E in the Budgets folder, we still have our on-prem files we had originally, but we have some new files that were synchronized from the Azure Files Cloud Share because we enabled cloud tiering. And that was the option that made this serve as an on-premises file cache. Now, some of the icons have an X through them, which means they've not been accessed or opened. So I've already opened one of them. So if I double-click to open one of the other files that were synchronized from the cloud, let's say I just choose, it doesn't matter which app I use, so WordPad is fine to open it up. But at this point, once I've done that, then the file will have been accessed, and so we lose the little X in the icon. Back in the portal, if I were to navigate to that storage account that held that Azure Files shared folder, and if we go take a look at it, so let's scroll down in the navigation bar till we get to File Service, File Shares. We're talking about budgets, so I'm going to click on that. So not only will we have the files that were already available here in the cloud, but we will also see the presence of the on-premises files that previously only existed in the on-premises file server. So in this course, we've examined Azure Files, including how to configure, manage, and connect to it using GUI and command line tools. We did this by exploring Azure Files and how Azure Files shares enable shared folders in the cloud. We looked at how to use the portal, CLI, and PowerShell to manage an Azure File Share. We examined how to map a drive letter to an Azure File Share in Windows and how to map a mount point to an Azure File Share in Linux. Finally, we examined how the Azure File Sync service provides an on-premises cached copy of Azure Files Share content. In our next course, we'll move on to explore Azure database solutions, including SQL, NoSQL, Azure SQL, and Cosmos DB databases, as well as database integration solutions, including Azure Data Factory, Azure Databricks, Azure Data Lake, and Azure Synapse Analytics. When you're planning your Azure SQL configuration in the Azure environment, there are many choices to choose from, depending on how much flexibility and configuration control is required, or how much appetite there is for that underlying configuration versus simply deploying a database solution quickly and easily. Let's examine this. So Azure SQL is a relational database solution. It consists of database servers and databases. So whether you configure those manually or whether you use a managed service type of solution, either way, that's what's running in the background with Azure SQL to support your other database objects like tables and views and stored procedures and so on. We also have this notion of elastic pools. So elastic pools allow you to group databases together in the pool where that elastic pool is configured to use a set of underlying resources. So you can move databases into and out of elastic pools as needed at any point in time. So using elastic pools makes sense if you've got, for example, a web application or maybe a multi-tiered web application, even multiple web applications that have unpredictable spikes in performance. And so to get the best performance at the least cost, it might be best to put those into the same elastic pool. But you have to be careful because if you have one very busy component, it could utilize most of the resources in the pool, thus depriving other components like other databases from using that pool. In Azure, SQL database deployment options include SQL Database, which supports databases in size up to 100 terabytes. This is considered platform as a service, and it's a fully managed service. So if you're looking for getting a SQL database solution up and running with the least amount of fuss possible, this is what you want. We then have SQL Managed Instance up to 8 terabytes in size for the database. This is also considered platform as a service, and it supports most on-premises SQL features, and it can be useful when you want to migrate your on-prem SQL solution to Azure. So the difference between SQL Managed Instance and SQL Database, SQL Managed Instance gives you a bit more functionality, therefore lends itself to migration. Then we have SQL Virtual Machines or VMs, so databases up to 256 terabytes in size. This one is not platform as a service. It's considered infrastructure as a service because you are manually deploying the virtual machines. However, it also means it's fully compatible 100% with your on-premises SQL deployment. Depending on which configuration options you have enabled on-prem, you could be guaranteed that they will be supported in the cloud. So this would allow access to the virtual machine operating systems since they are manually deployed, so you can tweak and tune them to your liking. And it works well for quick lift and shift migrations from your on-premises SQL environment to the cloud with minimal to no changes because you've got full support for SQL features in the cloud. So it's more work, but you get more flexibility. Then we have to think about our database pricing tiers, our SQL purchasing models, which come in the form of Virtual Core vCore. Now, this means that we get to specify the required compute resources that will support our database workload. It supports auto-scaling. However, this option is considered to be more complex because you have more flexibility than DTU. Now, you might wonder, what on earth is DTU? DTU stands for Database Transaction Unit. DTUs are a unit of measurement when it comes to Azure databases that combine together storage, compute, and I/O options. And the result is a DTU. And you can specify the number of DTUs based on your workload needs. So it's a less granular control of underlying compute resources than you would have with vCore, as we mentioned previously. So less flexibility. So it's designed to be a simple configuration option for determining the underlying compute power. Then there's database scaling. Dynamic scaling is supported. So auto scaling, scaling up and down, which is vertical scaling, which means you are either increasing or decreasing the underlying compute power. Increasing is scaling up, decreasing is scaling down. Now you would scale up to improve the performance of your database, but then scale down to reduce costs. And with dynamic auto scaling, that can happen based on the workload. So you get the benefit of performance and cost savings automatically. Database scaling also supports scaling out. This is horizontal scaling, We can also have dedicated read replicas for heavy querying. Then sharding is an option. Sharding allows you to take larger databases and break them into smaller pieces where each piece can be scaled separately from the other. So this would improve performance on a larger scale. So we have a number of options to consider then when it comes to pricing tiers and the type of deployment we would use for Azure SQL Solution. In this demonstration, I'm going to use the portal to deploy Azure SQL Database. The great thing about deploying this is that I don't have to worry about manually deploying virtual machines and installing database software and so on. That's going to be handled automatically by Microsoft. So to get started here, I'm going to click Create a Resource in the upper left, and I'm going to choose the Databases category under the left-hand column, and on the right, I'm going to choose SQL Database. I'll choose the resource group into which I want to deploy Azure SQL, and down below, I have to give a name to the database. I'm going to call it YHZDB1, and I either have to select an Azure SQL server if there is one, I don't have any available, or I can click the Create New link to create a new one, which I will do. When I click Create New, that opens a new server blade over on the right, where the first thing I have to contend with is the server name. I'm going to call this YHC server 1, and it's going to append the .database.windows.net DNS suffix by default. Then I have to specify the server admin login and the password, and then confirm the password and specify the location, all of which I will do right now. Once I've filled those in and made those selections, I'm going to click the OK button within the new server blade. The next thing I'll look at is whether or not we want to use SQL Elastic Pool. The default is set to no, and I can change that after the fact. Because I'm not going to have numerous databases with unpredictable resource needs, I don't really need to use Elastic Pool, so I'll leave it on no for now. Down below that, I can specify the sizing for the database, the compute and storage, which is currently listed as 2 virtual cores and 32 gigabytes of storage. But I can click the Configure Database link if I want to change that up. That, of course, is going to be dictated by the workload I anticipate that will be using this database. However, I'm going to just apply the current selection, and I'm going to click Next Networking at the bottom. So for connectivity method, I'm going to turn on Public Endpoint. Then down below, for allowing Azure services and resources to access the server, I'll choose Yes, and I'll add my current client IP address from which I am running the portal in the first place. I'm going to choose Yes to do that. And then I'll click Next Additional Settings. From here, we can use existing data. It's currently set to none, but we could specify data from a backup to be fed into the new database we're creating, or I could choose Sample, which I will do. That's going to use the AdventureWorks LT sample database, just so we have some tables that we can work with if we so need to test this out. Then I'm going to click the Next Tags button at the bottom. I'm not going to tag this, so I'm going to go ahead and click Next Review and Create. We get the estimated cost per month. Now, this is one of those types of Azure services. You want to make sure that you deprovision when you don't need it. If, for instance, you're just testing it out, because it can get costly very quickly if you leave something like Azure SQL Database running in the background when you're not using it. Okay, so having said that, I'm going to click the Create button in the bottom left to deploy both the Azure SQL Database, and remember, we also elected to create a new server, an Azure SQL Server. Once the deployment is complete, I'm going to click the Go to Resource button so we can check out our freshly deployed Azure SQL Database. So I'm in my SQL Databases properties, and in the navigation bar over on the left, we're in the Overview blade. So on the right in the panel, we have a status of online. We'll also have a reference to the server name that is hosting this database, and there's a link to it. We also have a listing as to whether Elastic Pool is enabled. It says no Elastic Pool. We also have connection strings. We can click Show Database Connection Strings. The connection strings will be very useful depending on the utilities, or if you're writing code and you need to make a connection to this particular database. I can also click Query Editor in the left-hand navigator if I want to query any of the data that might already be in here. So I'm prompted to log in. So I'm going to specify my SQL credentials that I specified when I deployed this, and I'll click OK. After which I'm placed into the query editor. So if I drill down in the left-hand navigator for that, under tables, I will have a listing of tables that are available, such as saleslt.customer. If I click on that and drill down further, I get a listing of the columns of the field definitions and their data types and so on. On the right, we can then specify a query. I'm using a select statement here to select the last name column from saleslt.customer, and that's coming from that specific table. And if I simply run that query, we can quickly get some information listed back here, in this case, the last names of customers stored in that table. So that's kind of a handy thing to have right here at your fingertips in the portal. If I were to go back to the overview blade, I'll just click OK. I don't want to save anything about that query. And if I were on the right to click on the link for the SQL Server name, that naturally would take me into the properties of the SQL Server that we deployed. Now, what's interesting about that is as I scroll down in the left-hand navigator, I can click on SQL Databases to see which databases it is accommodating, including our current sample database. Back here in the database properties in the left-hand navigator, I can go down under Settings and click Configure. This is where I could go if I wanted to change the underlying horsepower of this solution. So we can get a listing here of our current selection, which is the General Purpose tab at the top, provisioned as the Compute tier, but we could choose Hyperscale or Business Critical. Naturally, when you have more underlying horsepower and more high availability, you're going to end up paying more. But if you need that to support the database workloads, then you need it. Down below, under Compute Hardware, I will have a listing of my current configuration, so the number of vCores and the amount of memory in gigabytes. I can click Change Configuration, and as a convenience, I scroll over to the right and perhaps up just a little bit. I also have a database utilization chart that I can use to measure CPU utilization and disk space that's used. So that can help me make a decision when it comes to the sizing to accommodate my database workload or workloads. So down below, we can also use the sliders if we want to use this method to increase the vCores or the database maximum size. There are many different ways that can be used to connect to an Azure SQL database, whether it's through code programmatically or using command line or GUI tools, including GUI tools like Microsoft SQL Server Management Studio, which is what I'm going to use to connect here. I'm going to be running that on premises. But first things first, here in the portal, I've already navigated to my SQL Databases view. What I want to do is start by opening up my SQL database deployment. So I'm going to click to open it up. That opens up the properties of the SQL database. In the overview blade on the right, I'll be able to then click on the link for the SQL Server name that is hosting this database. And I want to click on that. The reason I want to navigate to the server is I want to first check out firewall rules in terms of who's allowed to make a connection to the server and ultimately databases hosted on it. So in the left-hand navigator for the SQL Server, I'm going to scroll down until under Security, I can click on Firewalls and Virtual Networks. So we can deny public network access. We can set the minimal TLS version, transport layer security. We can also, as we go further down, determine if Azure services and resources can access the server. This is a lot of the stuff that you get prompted with when you initially deploy it, but naturally you can change it after the fact. I also have a client IP address added down below. I could add it, if it wasn't already there, by clicking the Add Client IP button up at the top. That's going to take the current IP address you're using to use this interface and add it to that list. So normally, that's the public known network address, IP address, for the public side of your NAT interface if you're using a NAT router. Now that's important because if I'm going to be on premises on that network accessing or attempting to access my SQL databases using tools like SQL Server Management Studio, I've got to be allowed to do it. My IP needs to be in that list, which it is. So the next thing I'm going to do is fire up Microsoft SQL Server Management Studio on premises, which I've already installed. Now, while that's happening, if I look at the overview blade for a SQL database, I will have a listing on the right for the server name. So I'm going to go ahead and copy that. That's the SQL Server name. Copy it to the clipboard. In SQL Server Management Studio, I'm going to paste that server name into the server name field here in the login dialog box. This is rather the connect to server dialog box, which starts automatically when you fire up this tool. I'm going to specify the login name and the login password for SQL in the cloud here. And I'm going to go ahead and click connect. Now, if everything is working, if I've got the right credentials and the firewall allows outbound port 1433 traffic, so that's what SQL Server listens on, and if my client IP is added in the SQL Server firewall, then we should be able to make the connection. And we did. In the Object Explorer on the left, we have a listing for the name of the server we've connected to and for the username that we connected as, in this case, C. Blackwell. And if I expand the databases on the left, I'll have the database being hosted on that server. I only have one called YZDB1. I can then drill down under its tables and start working with items. I could, for example, right-click on saleslt.customer, so the customer table. And from here, I could tell it I want to select the top 1,000 rows, essentially run just a very basic query to make sure something is being returned. And in the right-hand navigator at the bottom, we will have a listing for some of the customers that are stored within that sample database. So we were able then to make a connection successfully from on-premises to the Azure SQL Server using Microsoft SQL Server Management Studio. If you're using an Azure SQL database for a mission-critical application, then you can initiate failover so that a secondary copy becomes the new primary. And this is possible when you configure geo-replication. So it's really Azure SQL Database high availability. To do this, first of all, here in the portal, I'm in the SQL Databases view already. So I'm going to open up a database that I want to enable this high availability option for. So in the properties of the database, I want to scroll down in the navigation bar under settings until I come across geo-replication. When I click geo-replication, on the right-hand panel, I will have a listing of the current primary. In my case, that happens to be in the Canada Central region. I can see the name of the server and the database, and it's online. The status is online, and there is no failover policy. In the list of target regions, I'm going to choose Central US. That's going to open up a new Create Secondary blade. So what I need to do is specify the target server. We might already have a server in that region, Central US, so I'll find out by clicking Target Server. There's nothing to be found here. It says no servers found, so I'm going to have to create a new one. So the new server then I'm going to call YHZ Server 2, and it's going to use the .database.windows.net suffix, and I'll specify, because it's a separate server, a set of login credentials. And then I'll click the Select button down at the bottom. I can then choose from some more detailed options like Elastic Pool if I want to group databases together to use the same set of resources. I'm going to leave the pricing tier as it is, and I'm going to click OK. Now bear in mind, when you're doing this, we are setting up geo-replication between two countries, so between Canada and the United States. So depending on regulations and laws and the nature of our industry will determine whether that's okay or not. It really depends on the type of data, doesn't it, and how sensitive it is. So I'm going to go ahead and click OK. So we already had a listing for our primary copy of this database. We now have a grayed out listing for the secondary copy, which currently has a status of initializing. After a moment, the status of the secondary will show readable, and you can add multiple secondaries. Now what you can then do is select a secondary to open it up and either stop replication to it, or you can force a failover. Forcing a failover makes this secondary the new primary, and if you have multiple other secondaries, they'll all link back to this one as being the new primary. And you might have a bit of downtime in the order of 10, 20, maybe 30 seconds or so, but for what you're getting out of it, business continuity with just a few seconds of downtime, it's worth it. You can use the Microsoft SQL Server Management Studio GUI tool to not only connect to on-premises and Azure-based SQL servers, and ultimately databases, but you can also use it if you want to publish an on-premises SQL database to Azure. So here on-premises, I'm already in the Microsoft SQL Server Management Studio tool. I've already connected to a server, and if I drill down under databases, I've got a database here called YZDB1. This is the database that I want to publish from on-prem, where it currently resides, into Azure. So I'm going to right-click on it. And in the Tasks menu, I'm going to choose Deploy Database to Microsoft Azure SQL Database. That's going to start a wizard, so I'll click Next on the first page of the wizard. I have to specify a server connection. Once I've authenticated to that server by clicking the Connect button, I can specify the new database name, and I'm just going to call it new YHCDB1. And I can specify some details like the edition of Azure SQL Database, the maximum database size, and so on. I'm going to leave those as they are. I'm going to click the Next button in the bottom right. That takes me to my summary screen where I can review the source and target details and the environment. And then when I'm happy with it, which I am, I'll click the Finish button. Now, while that's happening, here in the All Resources view in the portal, I'm going to click on Type because I want to filter it out. I'm going to uncheck Select All. I'm interested in SQL servers, so I'm going to turn on the check mark for that and click outside of the list to update the list based on that filter. And I've got one server named YHC Server 1. I'm going to click on it to open that up. What's important here is that in the overview blade of the SQL server that I've already created here in the cloud, that I know the URL. I have to know the URL or the server name, which I can copy, because that's what I use to make the connection when I want to publish that on-premises SQL database into Azure SQL. Back here in SQL Server Management Studio, we can check on the progress. So it's run a lot of tasks. The status column reflects that they were successful. We have a couple of in-progress tasks, importing the package schema and data into the database and updating the database. So we're just going to wait around a few moments to make sure this succeeds. And before too long, the operation will be complete and it will be ready to go. So that means that if we close out by clicking the Close button, we'll then be able to use SQL Server Management Studio to connect to our Azure SQL database stored in the cloud. Now, in my example, the source and the target are both in the same cloud-based SQL server, but it doesn't make a difference. The same procedure would be followed if you were doing it from an on-premises SQL server into the Azure cloud. You just have to make sure that you've got outbound connectivity that would allow that connection to be made. So through port 1433, and your Azure SQL server has to have your client IP, since you're doing this on premises, to allow the transaction to occur. You can create Azure tables within an Azure storage account. The tables that we're referring to here are not relational tables that you might be used to link related items together, but instead, these are NoSQL key value type of tables that are designed to be highly scalable. To get started with this using the portal, I'm going to open up an existing storage account. When I open up a storage account in the navigation bar, in its properties, I'm going to scroll down until I get down to the table service section where I'm going to click on Tables. When I click on Tables, any existing Azure tables will show up in the right-hand panel. To add a new one, I would click the Add Table button, which I'm going to do here. I'm going to call this Site Visits. You have to have planned what you're going to be storing here. Because this is designed for large amounts of data, it's designed to be highly scalable and very fast, and it's just a key value store, I've decided I want to store some statistics about visits to a large amount of different websites. Hence the name of the table, Site Visits. I'm going to click OK. So that will create the table. It's that quick and easy. We get a URL reference, and if I scroll over a bit to the right, in my context menu, for this table, I could choose to either configure an access policy, so permissions, or I can delete it. I don't want to delete it, of course. I'm going to click Access Policy. I'm going to create a new one for a development team. So I'm going to click Add Policy. For the identifier, let's say I'm going to call this Team 1. From the permissions drop-down list, I'm going to choose Read, Add, Update, and Delete. And I can set a start date and time and an expiry date and time. I'm going to set an expiry date, and I'm going to click OK. So the Team 1 policy is shown here. I need to click the Save button to make sure it's committed, so I'll do that. After which I can just click the X menu. So now at this point, we've got our table. Great. But now what did we do? There's really nothing else we can do actively in this portal interface, and that's correct. So normally you would then either programmatically access this table. We've got the URL, we've got the name of an access policy, but there's more to it because we have to create content. So to do that, I'm going to use the Azure Storage Explorer. Here in Storage Explorer, which is a free Microsoft tool I've downloaded and installed, I've connected to my Azure subscription. So in the Explorer panel on the left under my subscription, I can drill down under storage accounts. I'm going to choose a specific storage account, the one we just worked in, and then I'll expand tables. That's going to show me a number of built-in hidden metrics tables, which are prefixed in their nomenclature with the $sign. That's normal, and that's to be expected. But also we'll be able to click on our table site visits, which I will do. If I right-click on that table, for example, what I could do is generate a shared access signature. I can choose Get Shared Access Signature. I could choose my access policy, Team 1, from the list, and I could specify any further details such as the start date and time, or just leave it empty so it's effective immediately. And I could click Create. So at this point, we can choose to copy the URI or the query string, and this is what we would use in either command line tools or when we make API calls to Azure to work with these tables. So I'll just click Close. Also in the right-hand panel, now that we've selected our Azure table on the left, we can also click the Add button to add an entity. An entity is like a row or a record in a standard relational table. And of course, within that, each entity is broken down into properties. We see property names shown here. There are two default ones, the partition key and the row key. A different partition key means we want to have multiple storage partitions. The row key is interesting because this is the unique identifier within the partition, or what you might call from the relational database world a unique primary key. Okay, that's fine. Here I'm just going to put in 1, 2, 3 as well, but I'm going to click Add Property in the bottom left because what do I want to store here? Let's say site URL, which is going to be a string. Notice we have other options available here for data types like Boolean, binary, date time, double, GUID, 32 and 64-bit integers, so we can choose the appropriate items. I'm going to click Add Property again, and I'm going to call this num visits, and in this case, I'm going to choose int64 for this. A 64-bit integer can accommodate a number with 18 zeros, so quite large. So let's fill in the site URL here, the first one. Let's say it's https://www.site1.local, and maybe for the number of visits, I'll just enter in a value, and then I'll click the Insert button at the bottom. So we've just added a new entity. So it shows up in the list, but we can continue adding additional entities. So if I click the Add button again, all of the properties are remembered. So I can put in the same partition key. Let's say I put in the same row key I did previously, which is supposed to be unique within the partition. So I'm going to put in the same value here, row key of 1, 2, 3. Let's put in the number of visits value, and let's put in another site URL here. Okay, once I've done that, I'll just click Insert. And at this point, I have a message, an error message is telling me that the entity already exists. That's because we use the same row key value of 1, 2, 3. Oh, yes, of course. So if I put in, let's say, 4, 5, 6, and click Insert, it has no problem with it. So all of the entities will be showing up here in the list as we keep adding them. So this is how we can use, in this case, the Azure Storage Explorer GUI to work with our Azure tables. Cosmos DB is an Azure service offering that's designed to handle large amounts of data that are globally distributed in partitions replicated around the world. You could even, as a software developer, download an emulator to test it locally on your station. If you search for Cosmos DB emulator in your web browser, you'll come across this page, the Microsoft documentation page, where it discusses how to use the Cosmos DB emulator for local development and testing. But not only does it talk about it, as we go further down, you'll have the option of selecting the download link to download this tool. However, we're going to deploy it for real here in the cloud by clicking Create a Resource in the upper left of the Azure portal. And I'm going to search for Cosmos, and there's Azure Cosmos DB. So I'm going to select that. And then I'll click on Create. This is one of those services that you can deploy easily using the GUI, but it's really designed to be used from a developer's perspective by making API calls to Cosmos DB for working with and managing the data. So I'm going to deploy this into a resource group. I'll choose it from the list, and I'm going to specify an account name. Now, the account name needs to be lowercase and unique. So I'm going to call this Cosmos DB1. Now, if it's not unique, it's going to say the name is not available. So I'm going to put in a couple of characters to make it a unique name. while at the same time adhering to organizational naming conventions. Then we've got an API drop-down list, so we can select Core, SQL, Azure Cosmos DB for MongoDB API. It's compatible with MongoDB NoSQL databases. Cassandra for column-based type of databases. Azure Tables. Gremlin, which is a graph type of database. So this is what we mean when we say it's a multi-model API type of database that you can choose from at create time. So if I'm familiar with working with MongoDB already, I might select Azure Cosmos DB for MongoDB API, depending on what we've planned for in our use of Cosmos DB. Then I'll select the location, and down below, I can apply for a free tier discount against my RUs. The RUs are request units. This is a measure of throughput to Cosmos DB. Now in this case, I'm going to leave the account type to non-production. If I were to select production, notice down below that multi-region rights is switching over to enable, whereas if I go back to the default of non-production, multi-region right options are disabled. So now I'm going to click the next networking button at the bottom. Much like creating a storage account, we get to determine connectivity and where this database is accessible from. The default is all networks. We could choose public endpoint or private endpoint. I'm going to leave it on all networks for testing purposes, and I'm going to click Next for encryption. So we can use either an Azure Service Managed Key or a Customer Managed Key for encryption purposes. I'll leave it on Service Managed Key. I'll click Next. Not going to add tagging. I'll click Next for Review and Create. And after the validation passes, I will click the Create button in the bottom left to deploy Cosmos DB. Once that's completed, I'll click Go to Resource so we can browse around the properties of our new Cosmos DB deployment. The first thing I'll point out is that if we scroll down in the navigation bar, we have the ability of clicking on Connection String. This will give us a lot of options. We've got read-write keys. We can also click read-only keys up at the top. But for each of these variations, we have a listing for the host that we would connect to, the port number, the default of which is 10,255, the username. As we scroll down further, we have the primary password, secondary password, and finally, the primary connection string and the secondary connection string. So you can use either the primary or secondary passwords and connection strings. It really doesn't make a difference. However, we do have this listed here, and this is important because from a programmatic standpoint, we need to have this information. We also have a replicate data globally blade that we can click on the left. Currently, multi-region rights is set to disabled. We do have the option of choosing enable. Now for that to work, we'll have to click Add Region. The current region is listed below. It's Canada Central. When I click Add Region, I would choose the additional region that I want to replicate this data to. Let's say, for example, Western Europe. I'm not going to actually do that, but I would click OK and then Save to get that started. In the left-hand navigator under Collections, I'm going to click Browse, and I'm going to add a collection over on the right. There's a button at the top with that name. So I want to create a new database here where the database ID will be DB1. The throughput units, the RU, request units will be 400, and the collection ID, because we're making a new collection, let's say will be call1 for collection 1. Based on the data that you're going to populate into Cosmos DB will determine if you have a wide enough range of items, values for the val1 key to make sure that data is spread out or partitioned properly. So I'm going to go ahead and click OK. And after a moment in the collections navigator on the left, we will have a listing for DB1, so I can expand that, under which I'll see call1 for collection 1. I can even drill down under call1 for documents, where I'll have any documents that currently exist, there are none of course yet, listed over here on the right. But we do have a new document button available. Now normally, instead of entering in this information through this interface to populate and work with data in Cosmos DB, this will be done by a software component. Software developers will write code that will reach into Cosmos DB to work with the data. So at this point, we've successfully deployed Cosmos DB using the portal. There are plenty of sources for big data. When we say big data, we are talking about a variety of sources that produce vast volumes of data that need to be analyzed to gain insights. Whether it's from IoT devices like baby monitors or video surveillance cameras, whether it's banking information, medical research, whether it's information about users visiting websites and their habits through cookies, or whether it's about server utilization, social media feeds, military records, phone calls, it just goes on and on and on. So the key is that data, if it's analyzed correctly, can provide very valuable insights. So big data characteristics include the amount of data, the pace at which that data is produced, the data types, such as whether it's treated as a text string, whether it's numeric, whether it can be correlated easily with other data points, and also the data accuracy, the trustworthiness of it, and the insights we can derive from it. Azure Data Factory is one service in Azure that can be used with big data sources. Really, this is referred to as an integration service in the cloud, a data integration service. It supports something called a pipeline. So in Azure Data Factory, the pipeline is used to contain what are called activities. You define the activities in pipelines. And an activity, of course, defines tasks or actions that are to be performed on the data, such as copying data from one data store to another. Or also, we can configure activities with conditions on which action to take if a certain condition fails versus succeeds. Then we have data sets. The data sets, of course, are the core data, and this can come from a number of different locations. We can also configure linked services. These are similar to what a web developer might be used to working with in terms of a connection string to a back-end database. You are linking something in the front end to a data source in the back end. Then we have Azure Databricks. Databricks really is an implementation of the open source Apache Spark solution on Azure. Now, what does that mean? It's a data engineering solution. It's based on Spark, which is the open source clustering platform that's available out there in the wild. So this is considered a managed service, which is a good thing. There aren't too many people that have the expertise to manually install and configure and then deploy and ultimately manage a Spark cluster. So we can use other solutions along with this, like HD Insight, to even allow further configuration flexibility. The output format of using Databricks is JSON syntax. So what we could do then with Data Lake is we could integrate data from Azure storage accounts like blob storage. We could also integrate a Data Lake store or SQL databases and so on. The next thing to consider is Azure Data Lake. This service really serves as a repository for vast amounts of data. So the components would include the Azure Data Lake Store, Azure Data Lake Analytics, and Azure HD Insight. Data Lake Store is the large-scale data repository, whereas Data Lake Analytics is really the tool that we would use in order to analyze the data and derive value from it in some kind of way. Then we've got Azure HD Insight, which is really the cluster platform. On the storage side, we get to enable this during the storage account creation. Now, this means that when you make a storage account, you have the option of enabling Azure Data Lake. This uses a hierarchical file system to store data. And it also allows you to set permissions using POSIX-compliant file and folder security mechanisms. Finally, we have Azure Synapse Analytics. Really, this is considered to be SQL Data Warehouse in Azure, the newest version of it with some additional functionality. So the purpose of Synapse Analytics is to bring together different types of analytic workloads, including from Data Lake, from machine learning sources and data warehouse, and so on. So it's data warehousing and big data analytics essentially in one. You can also use the Azure Synapse Studio tool to bring all of this together using a web interface, using a UI. So, in this course, we've examined various Azure database solutions, including their deployment and management, as well as a number of Azure solutions allowing for data integration. We did this by exploring the various database services and selecting the best one to meet your business needs, how to deploy Azure SQL using the portal, how to connect to Azure SQL using the Microsoft SQL Server Management Studio tool, how to enable high availability for Azure SQL. Next, we looked at how to publish an on-premises database to Azure using the Microsoft SQL Server Management Studio tool, how to create a NoSQL table in a storage account, and how to use the portal to deploy Cosmos DB. And finally, we examined Azure database integration solutions, including Azure Data Factory, Azure Databricks, Azure Data Lake, and Azure Synapse Analytics. In our next course, we'll move on to explore the design and management of Azure Virtual Machines, VMs, including planning, implementing, and managing Windows and Linux VM configurations, as well as looking how they are managed remote. Microsoft Azure Virtual Machines, or VMs, are the underlying component that provides the compute horsepower to support workloads. It supports rapid provisioning. We can use GUI tools or command line tools, even templates, to very quickly provision Azure VMs in the cloud. Certainly much quicker than if we had to acquire hardware and install an operating system locally on premises. We can also go to the Azure Marketplace to search up some existing images that contain perhaps not only the operating system, but additional software that we might need to support a given workload. Windows and Linux are both supported, but there are usage fees, so depending on the VM size determines the number of virtual CPUs. It also determines the amount of RAM that's available for the VM. Other things include the maximum number of attached data disks and the maximum disk IOPS, which is a measure of throughput performance for the disk subsystem. Basically, as you increase those items and make your VM faster, you are paying more. And of course, you're also paying while the virtual machine is running. So in a testing sandbox type of environment, you want to make sure that VMs are shut down when they're no longer required. There are plenty of details that you need to think about when you plan virtual machine deployments. We've mentioned the VM size, so the virtual CPUs, RAM, disk IOPS. We also have to think about the Azure region in which the VM will be deployed. Depending on your requirements, you might want the Azure VM in a region within national boundaries, perhaps for data sovereignty reasons, if the VM will be storing sensitive data. Now, every VM is going to have at least an OS disk, but you can attach data disks, and they show up as regular disk devices on a normal server, as it would see it. And so those data disks, the number of them is really determined by your VM size. The other thing to think about are VM extensions or agents that we can install to give additional functionality to the VMs. Now, you could do that after the VM already exists. It doesn't have to be done during deployment. So these VM agents might give us additional options related to security, backup, or support for running scripts within the VM operating system. We then have to think about Subnet in Azure where the VM will be deployed and its IP addressing. Will it only require a private IP? Maybe it's going to be managed indirectly from the internet through an Azure Bastion host, or will it require its own public IP? Really, the workload running within it and how you want to manage it will determine what the answers to those questions are. So for Windows virtual machines in the cloud, we need to specify the logon credentials. We can connect for management purposes to those Windows VMs through Remote Desktop Protocol or RDP. You just need to make sure that firewalls on premises, for example, as well as firewall solutions in the cloud, like network security groups and Azure Firewall, allow RDP traffic to that VM. We can also configure VM high availability through an availability set. The VMs in the availability set do not have to be exactly the same. So the purpose of the availability set is that when you're deploying groups of VMs, you can spread them out in Azure data centers across hardware, across physical hypervisor, servers, and compute racks, and network switches and power sources. We can also enable VM backup for Azure virtual machines. On the Linux side of VMs, we can use username and password authentication similar to a Windows VM But we also have the option of using public key authentication. Now, if you want to use that, you're going to have to generate a unique public and private key pair. The public key is associated with the VM in Azure. The private key is required on the machine where you want to use SSH to connect to your Linux VM. So we can connect using Secure Shell or SSH. So your firewalls have to allow that type of traffic. Just like for Windows, they'd have to allow RDP. And again, you can also use availability sets if you have multiple Linux VMs you want to run together, but you want to spread them out across underlying data center hardware. And just like with Windows, you can also enable VM backup for Linux VMs. Now, when you deploy an infrastructure as a service or an IaaS VM, as opposed to a managed VM, you have a manual deployment and configuration. However, you have full configuration control. And if that's what you need, then yes, you can deploy IaaS or infrastructure as a service VMs. But in some cases, you don't care about the underlying operating system and virtual machines. You don't need to configure them. You just need a higher level service that runs on top of them. And so you might look to using managed VMs, which is available with many services in Azure. So it's deployed automatically in the background when you deploy higher level services such as a SQL type of configuration, a managed SQL configuration like Azure SQL Database. So you've got limited configuration control, at least of the underlying VMs. So managing VMs can be done with the Azure portal, using PowerShell, using the Azure CLI. You can also create and manage VMs using an ARM template, which uses JSON syntax, or you could use REST APIs and client SDKs, so developer kits. Now, SDKs can use different languages. Normally, if you're using Visual Studio, the SDK for the Azure REST API would use the C# language. In this demonstration, I'm going to use the portal to deploy a virtual machine. Now, deploying a virtual machine using the GUI is really not that difficult. The tricky part comes in the planning ahead of time so that you know how to configure that VM deployment. Things like the name of it, also the operating system type, which you have to think about the workload that the VM will accommodate, which in turn will help you determine what kind of sizing you need. How much horsepower do you need to support that workload? Which region should it be deployed into? Should it be publicly visible on the internet for RDP purposes? All these types of things we have to account for and plan. So if I've done that, in the portal, it's quite easy to get started. I would click Create a Resource in the upper left, and under the Azure Marketplace category or column on the left, I'm going to go down and choose Compute, and then I'll choose Virtual Machine over on the right. That'll get me started with the Create a Virtual Machine wizard here in the portal, where I can specify all the details that we talked about planning for. So the first thing I would think about is the resource group I want to deploy it into, or I could create a new one, and giving it a virtual machine name. We should be following naming standards within the organization. I'm going to call this WinServe 2019, that's the OS it's going to be running, -1. Then the region. Well, I'm going to deploy this, let's say in my case, in the Canada Central region, because that's where I am administering it from, but also that's where access to the workload will be required. Down below, the image is currently set to Ubuntu server for Linux. I don't want that. I'm going to choose Windows Server 2019 Data Center. Now, I can also click the Browse All Public and Private Images link to do just that. You might even have a private VM image that you've saved that's tweaked and configured for your environment that you want to reuse over and over to save time. It's a great idea. In this case, just generic Server 2019 Data Center will fit the need. I'm not going to deploy an Azure Spot instance, essentially using extra Azure compute capacity at a discount, but then of course I'm also not guaranteed that compute capacity. So the size is listed next, where I can see the number of vCPUs and the amount of memory and the approximate cost per month. I can click Change Size if I wish. I'm going to leave it as it is. And this is Windows, so I'm going to have to specify a Windows username and password for authentication purposes. Once I've done that, down below, the default is to leave RDP as a public inbound port. Now, that could present a security risk. Instead, you might want to not allow it to have a public presence and instead connect to it through a VPN or perhaps through an Azure Bastion host. But for testing purposes here, there's nothing at stake It's a complete sandbox environment, so I'm going to leave it with the allowed RDP port of 3389 to be open to the internet. So I'm going to click Next. For disks, the disk type is currently set to Premium SSD solid state drive. If we wanted to save on costs and didn't require a lot of performance, we could choose standard hard disk drive or HDD, but I'm going to leave it on Premium. I'm going to leave the default encryption at rest with the platform managed key. That's fine. Down below, I could also create and attach a new disk or just attach an existing disk if I wanted additional disks to work with this VM. And I can also do that after the fact. I'm going to click Next Networking at the bottom, and I want to deploy this into a specific VNet and subnet. So I just have to choose it from the list. So VNet 1 and Subnet 1, although I could change those. And it's going to create a new public IP address resource for this server. That's fine. I'll leave that alone. I'm not going to change any of the other settings on this page, so I'm going to click Next for management. I'm not going to change anything here, so I'll leave boot diagnostics on and OS guest diagnostics off. Again, I can turn that on after the fact if I so choose down the road. Next for advanced. This is where if I wanted to, I might configure dedicated hosting so that all my VMs run on a physical host that is in an Azure data center, but that no other Azure customers have their VMs running on. I don't need that. So I'm going to click Next Tags. I'm not going to add any tagging. So really, all I have to do now is click Next, Review, and Create. It's going to validate my selections. So we can see it's running the final validation. After it's passed, I can actually create the VM by clicking Create in the bottom left. After a moment, the deployment is complete. I'm going to click the Go to Resource button so we can jump into the virtual machine's properties and just poke around a little bit. So in the overview blade on the right in the panel, we'll see the location is set to Canada Central and that a public IP address has been assigned, as well as a private IP address. If I go down and look at the networking by clicking on that in the left-hand navigator, we'll see the network association here is for VNet 1 and Subnet 1, and we can see any network security group rules that might be in effect here to allow or deny traffic. If I were to click on disks in the left-hand navigator, we're still in the VM properties here, I'll see any current disk configurations. We've got an OS disk, but we don't have any data disks. And again, we could click the Add Data Disk button if we wanted to work with that. If I click on Size in the left-hand navigator, we'll have the configuration on the right for the sizing for the VM, and we could select it. We could either perhaps decrease it, maybe less vCPUs and RAM if we don't need the power that we currently have to accommodate our workload. That would save on costs. Or we might increase it if we don't have enough juice to support our workload. So it's very easy then to deploy a virtual machine using the Azure portal. As we've mentioned, the tricky part is planning it ahead of time. Filling in the blanks and clicking on things is the easy part. You can use PowerShell to deploy Windows virtual machines. Now here I'm going to be using the PowerShell ISC, the integrated scripting environment on premises. I've downloaded and installed the Azure PowerShell module. However, we could also do this from Cloud Shell within the portal if we so chose. So here I've got a script open in the PowerShell ISC where in line 1, I'm creating a variable called $creds, which will store the result of running get-credential. All that's going to do is prompt for a username and password and store that in the $creds variable, which we'll use later to define the credentials for the virtual machine. To build the virtual machine in line 3, we're using the new -AZVM PowerShell commandlet. I've then got a space and a backtick symbol. That is not a single quote, but rather it is a backtick symbol, which you'll get on the keyboard in the upper left where you have your tilde type of key. So that lets me go down to the next line in my expression, where I'm specifying the resource group I want to deploy the VM into and the name of the VM, which I'm calling WinServe 2016-1, in accordance with naming standards in the organization. I'm using the -location parameter to specify Canada Central as the region, -virtual network name, VNet 1, -subnet name, Subnet 1, -security group name. The security group, of course, consists of security rules that determine whether traffic is allowed or denied into or out of a subnet or for a specific network interface. So public IP address name parameter, I'm going to create a public IP address resource for this VM dash image. Now this one's important. What is the OS image that I want to use, whether it's public or private? Here I'm going to use the Microsoft Windows Server Windows Server 2016 data center latest. So the latest version of 2016 Data Center Edition. Now, how do we know what that information is? How do we know that is what we put in as the image string? That's a good question. We have to be able to get that listing. And there are a number of PowerShell commandlets that we can use to do that, which I will use down below here to explain that in the PowerShell window. The first thing I'll do down below, we may as well get this out of the way, login-AZ account so we can authenticate to Azure. We're going to need to do that anyhow. So I'm going to go ahead and do that. That will prompt me to log in to my Azure account. So I'm going to go ahead and specify the correct credentials to do just that. After a moment, we'll have the result of having successfully authenticated with the login-AZ account commandlet. So I'm just going to clear the screen. So the first thing I'm going to do here is I'm going to run get-az VM image publisher -location Canada Central. When I press enter, I will get some publisher information, which is going to lead me to what I need to specify on the command line with the -image parameter of new-az VM. So in this list, if I kind of scroll all the way back up through here, we'll eventually come across some variations for what might be of interest to us, which would include in the M's taking a look at Microsoft Windows Server as just an example. We can then use get-az VM image offer. Now I didn't specify the location on the command line, so I can just specify it when I'm prompted because it's mandatory. Canada Central. Publisher name, well, we just figured out it was Microsoft Windows Server. I'll spell that out, press enter, to see what images are available for that. And we'll have many listings here, including for Windows 10 and what we're interested in, Windows Server. So next, we can use the get-az VM image SKU, specify -location of Canada Central, -publisher name of Microsoft Windows Server, -offer Windows Server. And when we do that and press enter, we'll get some more detailed listings of what we're going to need to specify on the command line. So an example, if we go up through the list, is we'll see 2016 data center. So that's how we can start to determine what to use for -image here when we are creating a VM in PowerShell. Continuing on with our new -az VM commandlet, I'm going to specify -open ports of 3389, and $credential will simply refer to our $creds variable way up from line 1. Let's run the script. I'm going to click the Run Script button, which we could also execute by pressing F5 on the keyboard. So I'm prompted for credentials. This is going to be used to authenticate to the VM, so I'm going to go ahead and specify these. And then I'm going to go ahead and click OK. We then get a message here in the ISC about creating the Azure resources with a percentage. We've got a progress bar that's increasing as it creates the resources used for the virtual machine, because it's going to need to create a virtual disk for the OS, a network interface, and so on. After a moment, the PowerShell script will have completed, so let's go ahead and check our work. One way to do that is to run get-az VM, where it will return all of our virtual machines, including the one that we just deployed named WinServe 2016-1. The Azure CLI can be used to deploy Windows virtual machines, as well as other methods like using PowerShell, ARM templates, the portal, and so on. The great thing about the CLI is that if you're used to working in the command line and perhaps you want to make a reusable script, then the CLI works well for doing that. So to get started here, I've launched the Cloud Shell using the Cloud Shell icon at the top center of the portal. This is where I'm going to run my CLI commands. I'm going to start by running AZ --H because I'm not sure what the next level command would be. Now, as I scroll back up through the output, I have an alphabetical listing of next level commands, one of which is VM in the V's, virtual machine. Perfect. So from here, I could then run AZ VM-H for help. And if I scroll back up through the output, I'll come across something that makes sense, create. And from there, AZ VM create-h for help to get more details about creating a VM along with some syntax examples. The other thing I want to do here is run AZ VM image list. Now I can also pipe that to more, stop after the first screen full. Now this is important because from the image listing, I can determine which one I'm going to use on the CLI command line to build my new Windows virtual machine. So I can just hit the spacebar, keep going through a lot of these variations on Windows Server and Ubuntu and so on. Okay, so to make this happen, here's what we're going to do. I'm going to use the AZ VM create command, --resource-group e*g1 --name. WinServe 2019-2 is what I'm going to call it. --image. I'm going to use the Win 2019 data center image. --admin -username is going to be C Blackwell. And finally, --admin -password. I'm going to specify a value for that in double quotations. So I'm going to go ahead and press enter to deploy this Windows VM using our CLI statement. After a moment, the VM will be deployed. So it's going to be in a running state as VMs normally are when they're first created. I'm going to clear the screen with CLS and I'm going to run AZ VM list. Now that will return all of the VMs, but it includes all of their properties. It's a little bit overkill. So I think what I'll do is run AZ VM list. And I'm going to make sure after list I use --query space, open and close square bracket, .name. In other words, I only want to see the name property for my virtual machines. And when I do that, we'll see our newly deployed VM, WinServe 2019-2. In this demonstration, I'm going to deploy a Linux virtual machine, or VM, using the portal. So to get started here in the portal, I'm going to click Create a Resource. Now over on the right under the Popular column, I have an entry for Ubuntu Server 18.04 LTS because it's popular. So if that's what I want, that's an easy selection. But I could also click Compute over on the left and simply choose Virtual Machine on the right, after which I could then select the appropriate operating system image. But first, there are a few other things that we have to specify when we deploy the VM. The first would be the subscription and the resource group that we want it deployed into. So I'm going to go ahead and specify those, and then a name. I'm going to call this Ubuntu-Serve1. For the region, I'm going to place this in a region where I've got a VNet that is near where I'm administering my Azure environment from. And so in my particular case, I'm going to choose that as Canada Central. I don't have any availability requirements at this point, so we could select availability set or availability zone, but availability zone is grayed out because availability zones will vary from region to region. So if I were to choose, instead of Canada Central, let's say France Central, and then take a look at my availability options, availability zone becomes a selectable choice. However, I don't want this in France Central. I want it in Canada Central. So I'm going to go ahead and choose that again. So the image. Down below, we can select from common popular images based on Linux variants as well as Windows variants like Windows Server 2019, 2016, 2012, Windows 10, and so on. We can also click Browse All Public and Private Images. They are categorized here in the Azure Marketplace on the left, and there are a lot of them. So if I were simply to search up, let's say, Linux and press Enter, I have numerous choices. If I'm an IT security penetration tester, I might be interested in Kali Linux. I've also got other ones like Red Hat Enterprise Linux and Oracle Linux and so on and so forth. However, in my particular case, I'm just going to go with Ubuntu Server 18.04. I don't want to use spot instances, extra compute power at a discount, but although that compute power is not guaranteed. The sizing I'm going to accept. It's currently set to use 2 vCPUs and 8 gig of RAM, which is fine for what I'm doing. And I have 2 authentication possibilities for Linux VMs, either SSH public key, the default, which means I would have to paste a public key portion of a key pair here in the SSH public key field. So I have to generate a public and private key pair. The private key is stored on the connecting client device. However, I could also select password and specify a username and password for this VM, which I'm going to do here. I can switch between SSH public key and password-based authentication at any point in time after the VM is deployed as well. After I've done this, I'm going to scroll down. I could allow the SSH port 22 to be visible to the internet if this VM will have a public IP. I'm going to choose none for security reasons because I know I've got an Azure Bastion deployment through which I can make a connection to the private IP of Linux and Windows VMs. So that's why I'm saying none here. I'll click Next. For disks, there's going to be an OS disk allocated for this specific virtual machine. It's going to use premium SSD. However, I can also create and attach data disks below or attach existing disks. I'm going to do neither. Just going to click Next, Networking. I'm going to deploy this into an existing VNet and Subnet, in my case VNet 1, Subnet 1. It wants to make a public IP address. I'm going to choose none. I don't want a public IP here. I don't want this VM directly accessible from the internet. So I'm just going to continue by clicking Next Management just to go through each of the tabs. I'll accept the defaults for things like boot diagnostics being enabled and so on. I'll click Next. For Advanced, here's where if I wanted to, down below, I could enable a host group for dedicated hosting, whereby I have a server, a physical server, that is really set aside specifically for my exclusive use for running VM guests. I don't want to do that. I don't need to. So I'm going to click Next for tags. I'm not going to add tagging information for the VM. I'll click Next for Review and Create. And I'm going to deploy this VM after the validation has passed by clicking the Create button in the bottom left. After a moment, the deployment is complete, so I'm going to click Go to Resource because that virtual machine will be up and running automatically when you deploy it. You can verify this in the Overview blade. The Start button at the top is grayed out, but the Stop button is available. We also have a Restart button and also Connect. We could choose Connect and select to connect over SSH directly, which would require a public IP, which this VM does not have. RDP doesn't apply here. That's Remote Desktop Protocol for Windows. And also, we could connect through an Azure Bastion solution if we've got one deployed. Over on the right of the Overview blade, we also will have a listing of a public IP address if one is configured. One is not, so instead all we see is a dash in place of a public IP, but it does have a private IP address. As I scroll down in the left-hand navigator, I can click on Networking to see the network that this VM is deployed into. In this case, it's VNet 1, Subnet 1. We also have a listing of inbound and outbound port rules from network security groups, so to allow or deny traffic. We can also click on Disks on the left, where we will see the OS disk that's been configured, and we have the ability to add data disks. We can click Size in the left-hand navigator, which will reflect the current selection for sizing. So in this case, 2 vCPUs, 8 gig of RAM, up to 4 data disks can be attached, and so on. So we can come in and resize this to accommodate the workload if we need more horsepower or less, although it will restart the VM if we resize it. We can scroll further down in the left-hand navigator, down under Support and Troubleshooting, where we can choose Reset Password. This would be useful if we forget the username and password for this Linux VM, or we could reset the SSH public key if we want to use public key authentication. But again, that would require the generation of a public and private key pair for this use. But at this point, we've got our virtual machine up and running. If we don't need it up and running currently, then we could go to the Overview blade, where we could elect to stop it by clicking the Stop button up at the top. Or if I were to go into the virtual machines view here in the portal, we can do that simply by putting a check mark in the checkbox to the left of the VM name and then clicking the Stop button from there. In this demonstration, I'll be using PowerShell to deploy a new Linux VM. I've elected to use the PowerShell ISC GUI interface on my on-premises system, where I've got a script that's going to create the Linux VM. I've already logged into my Azure account with the connect-az account commandlet, so I don't need to authenticate to Azure. I've already done it. So here we've got a script where in the first few lines we're setting up a number of different variables that will ultimately be used down in line 17 when we build the VM using the new -az VM PowerShell commandlet. Let's quickly run through this. In line 1, I'm creating a variable called $VNet. It's going to store the result of get-AZ virtual network, and I'm pointing to a resource group name and the name of an existing VNet called VNet1. So that's going to be stored in the $VNet variable. Line 3, I have a comment or a hashtag or pound symbol in front of the code, so it's not executed. But what that will do is return one of the subnets from the subnets array within my VNet, the name property specifically. So for example, I'm going to highlight those two lines and I'm going to run the selection. I could press F8 to make sure it returns a valid subnet name. It does, subnet 2. So we can refer to the next subnet in that VNet by specifying a 1 within the square parentheses instead of a 0 because it's an array. So that's fine. I don't need that when I'm running the script, so I'm going to put the comment symbol in front of it again. That's the hashtag or the pound symbol. In line 5, I'm creating a NIC variable, network interface variable, $NIC, which will store the result of running new-AZ network interface, then -name to give the resource a name, -resource group. I'm going to specify RG1, -location will be Canada Central, -subnet ID. I want to tie the new network interface to a subnet. So this is where I'm going to refer to, for example, $VNet dot. In this case, I want to change that to subnets 0.id, the ID property of that subnet. In line 8, I'm making a password variable called $PW. I'm running convert to -secure string. And in quotes, I've got the password I want to use, and then I'm using -plaintext -force. So it's stored in memory in the $PW variable, not as just a string, but as a secured value. In line 10, I'm creating a $creds variable, which will store the result of running new-object system.management.automation.psCredential. And in parentheses, I want the username to be C Blackwell, so that's in quotes within the parentheses, comma after that, and then we'll just simply refer to our $PW variable from above, close parentheses. We're getting there. Line 12, we're making a variable called $vmconfig. It will store the result of running new-AZ vmconfig, where we're going to specify -vm name. I'm going to call this Ubuntu-serve3, -vm size. I can set the sizing there, and I'm going to pipe that with the vertical bar symbol to set -AZVM operating system. It's going to be -Linux, -computer name here. I'm going to specify as Ubuntu-serve3, -credential. This is where we're going to use the $creds variable from up above in line 10. Then I'm going to pipe that to yet another commandlet. Set -AZVM source image, -publisher name, canonical, -offer, Ubuntu server, SKUs. I'm going to specify the SKU value here of 14.04.2-LTS. So that's for Ubuntu Linux. -version will be latest. Pipe the result of that once again to a different commandlet with the vertical bar or pipe symbol. We're going to pipe that to the add-AZVM network interface. -ID is going to be our NIC variable from above, $nic.id. Now that's quite a long statement, but what we serve to do here is set up the configuration that we can pass as a variable in line 17 when we build the VM. So we do that in line 17 with new-AZVM, -resource group name, in this case East RG1, -location, which is set to Canada Central, and finally -VM, we specify our $vmconfig variable. Let's go ahead and run the script. I'm going to do that by clicking the Run Script button at the top. Alternatively, I could press F5 to do the exact same thing. After a few moments, the isSuccessStatus code property will return a value of true. So if I were to clear the screen down at the bottom in PowerShell and run, let's say, get-azvm, and then press Enter, it will return a list of our virtual machines, including the one that we just deployed by the name of Ubuntu-serve3. Linux VMs can be deployed using the Azure CLI. I've started Cloud Shell here from the portal using the Cloud Shell icon up at the top. So to get started, I'm going to type azvm-h for help. So I know the prefix for the command so far will be AZ for Azure and VM for virtual machine, but what's next? Well, because we asked for help for AZVM, we have a listing of the next level commands, such as create, to create an Azure virtual machine. So we could take it from there and type in AZVM create -H and get further help on the syntax that would be required to build our Linux VM. So the other thing to bear in mind is that when we're going to create a virtual machine using the CLI, we need to have a proper image name. We can run the command AZ-VM image list command to list out the images that can be used. So from this list, we can determine the specific offers that are available for images, whether they are Windows or Linux-based, such as Ubuntu server. Okay, so the next thing I'm going to do then is going to actually build a VM here. And to do that, I'm going to use the following command. I'm going to start by typing AZ-VM create. We know that from looking at the help system. -- resource -group will be east1 -- name. I want to call this Ubuntu-2 -- image. Well, from the previous command, I get a list of images, VM images. So I'm going to use Ubuntu LTS --admin -username. I'm going to use the name of C Blackwell --admin -password in quotes. Specify the password for the account. Finally, --location. I'm going to specify as Canada Central. So to deploy this Linux VM, I'm going to start by pressing Enter. After a moment, it will have been provisioned. The power state is shown in the output of the command as VM running. We can actually check our work in a number of different ways, including running AZ-VM list. And if I press Enter, it will return a list of our virtual machines. What we could do is ask for specific properties instead of viewing all of this output. It's much easier than if we just clear the screen here and use our up arrow key to bring up that command, and at the end add --query space open close square bracket .name. We want to see only the name property. And our new virtual machine, our new VM named Ubuntu-2 will be shown in the output of that command. You can use an ARM template to deploy a virtual machine. To do that using the portal, we would start by clicking Create a Resource, because what you would be creating is a template deployment. So I'm going to search for template, and I'm going to choose Template Deployment, deploy using custom templates. Then I'm going to go ahead and click on Create. Remember that an ARM template is nothing but a text file that uses JSON syntax to identify which type of Azure resource will be created and its specific details, its properties and values. We can either generate that ourselves, we could generate it here in the portal. As we're building a custom deployment, we can choose Build Your Own Template in the editor. When I click that, it opens up the editor, and I'm immediately placed inside a location where I can start typing in the JSON formatted data to identify the template. However, I'm going to click Discard. There are some common templates that can be selected here, such as create a Linux virtual machine, create a Windows virtual machine. Down below, I can also search through GitHub online for certain types of templates. So if I type in VM, then I get some variations on names of GitHub ARM templates that contain VM. For example, SQL VM new storage. It's quite a long list here. I can scroll through and see it all listed here. Now, that's fine. I can do that. But in this case, I'm just going to choose Create a Linux Virtual Machine. And when you are selecting a template to deploy here in the portal, depending on how the template was created will determine which fields you must fill out. Some templates might specify values for almost everything. Might be mostly hardwired, or you might have to specify a lot of the details yourself. It just depends on the template itself. When you're in a template, as we are here, we've selected one, you can choose to edit the template at the top or parameters. The parameters are the values that we specify here. Things like a resource group, which I'll choose from the list. As I scroll further down, the VM name, it's going to be called Simple Linux VM, the admin username. So I'll specify a value for that. We can specify the password or the public key portion for SSH. For the DNS label prefix, it's already got some code in here that's going to convert to lowercase using the toLower function, and it's going to concatenate our text, the name of our VM, simple Linux VM, with a unique string that's derived from the resource group ID. So that's what that statement does. I could change that by deleting it and typing in my own specific DNS label prefix. I can select the specific version of Ubuntu. This template specifically uses Ubuntu Linux, which is fine. The location is set to the resource group dot location. Resource group is a function here, so resource group open close parentheses, which is specified up above. We can specify the VM sizing, the VNet name, and the subnet name. It's going to build a new one here, and the network security group it's going to use. So we could change those values. I'm going to accept them as they are. I agree to the terms and conditions, and I'll click on the purchase button. And if I click my notification bell icon in the upper right, I have a message stating that the deployment is in progress. So that's how easy it is to deploy a virtual machine using an ARM template. After a moment, we'll have a message stating that the deployment succeeded. Let's just go to our virtual machines view here in the portal to ensure the VM exists and that it's up and running. So our VM, Simple Linux VM, is shown in the list with the status of running. The free PuTTY tool can be downloaded by searching for PuTTY on the internet, P-U-T-T-Y. This is an SSH client, although it can do more than that. But not only do we have the PuTTY installer for Windows 32, 64-bit or for Unix and Linux hosts, but also as I scroll further down, we've also got the PuTTY Gen tool. PuTTY Gen is used to generate keys. So I've already downloaded and installed these tools. I want to generate a public and private key pair so that I can use SSH public key authentication. So here in the PuTTY Gen tool, I'm going to click the Generate button. I'm told that I need to move the mouse around the blank area to generate some randomness, which will be treated as a seed to generate the public and private key. So I'll keep doing that until the end. Where it then has our public key shown up at the top, we can specify a key passphrase and confirm it so that we can secure the private key. Now, the public key is public because it can be shared publicly with anybody and there's no risk at all. And the public key is what we need to configure on the Azure side. The private key needs to be on our machine where we will be connecting for SSH purposes. It needs to be backed up and safeguarded. So I'm going to go ahead and confirm a passphrase and save both the public key and the private key files. So I can use a text editor like WordPad to open up the public key file. I don't have to open it up, but all it contains is the unique public key that was generated as part of the key pair. Back here in the portal where I've opened the properties of my Ubuntu Linux virtual machine, I'm going to scroll all the way down in the navigation bar under Support and Troubleshooting, and I'm going to click Reset Password. I'm going to then, on the right, click Reset SSH Public Key. I'm going to specify a username, and I'm going to paste in the SSH public key, which I've copied. And I'll click the Update button. Notice here, I've copied the entire public key. That means I've got the end SSH public key part of the text as well as the begin. Now, after we've done that and we click Update, it will be able to update this public key on the server side in Azure. The private key is in a file in our possession from a connecting client's perspective. Now, once that update has been saved, we can test connectivity from the client side using an SSH client, in our case PuTTY, along with our private key. So back here in the PuTTY client, I've got the public IP of my Linux VM again. And what I'm going to do in the left-hand navigation bar in the PuTTY configuration, I'm going to drill down under Connection, SSH, and Auth, where I can specify the path and file name of the private key file that we have generated. You need a public and private key pair. The public key is part of the Azure configuration. The private key is on the client side. So I'm going to click the Browse button to choose that file. And then I'm going to click Open to open the SSH connection. So it's asking me to log in. I'm going to specify the username that was configured server side here in Azure. And then it's going to ask me for the passphrase to authenticate with the private key file. So I'm going to enter the passphrase for that file. And after a moment, I'm in. So I've successfully authenticated to my Linux virtual machine through its public IP address with SSH public key authentication. After deploying virtual machines into the Microsoft Azure cloud, the next thing you have to ask yourself is, how am I going to reach into the cloud and manage those virtual machines remotely? Normally on premises for Windows virtual machines, you might use RDP, Remote Desktop Protocol, to remotely manage Windows hosts when you need to do that for individual servers. We can do the same type of thing here for our cloud-deployed Windows VMs. So here in the portal, I'm going to click to open up an existing VM that's currently up and running. One of the things I need to do is determine how I'm going to connect to it. In the overview blade for a virtual machine in the right-hand panel, we'll have access to a number of properties, including the public IP address, if it has one. This one does. And the private IP address. Now, the private IP address is only reachable from within the VNet that this VM is deployed into, or perhaps another VNet that it might be paired with, but basically, it's internal to Azure. Because this virtual machine has a public IP address, I can at least attempt to make a connection directly to it through its public IP. So I'm going to go ahead and copy its public IP address. While we're here, let's also point out that if we scroll down in the navigation bar for that virtual machine, we can also go to networking. The reason this can be important in this topic is because of the allowed ports. So network security groups have inbound and outbound port rules that either allow or deny traffic. And we have a listing for this virtual machine that shows a priority value of 300 for a security rule. And it looks like it is allowing port 3389 TCP from anywhere to anywhere, and the action is to allow, not deny. So it looks like RDP traffic is allowed. You want to be very careful with this with production servers and not expose them directly to the internet with a public IP when RDP is potentially available, because there are a lot of known exploits against this. Because this is a testing server, it's not going to make a difference. I'm going to scroll back up. Well, actually, we can just click Connect over in the left-hand navigator to connect to the virtual machine, either using RDP, so we can specify the IP address, the port number's filled in, and we can download an RDP file. If it was Linux-based, or it could be Windows and have SSH enabled, we could connect with an SSH or Secure Shell client. And if we've deployed Azure Bastion, then it acts as a middleman that we would basically authenticate through the Bastion hosts to the server via its private IP address. It wouldn't need a public IP. And you also get the remote session directly in your web browser. We're going to be doing RDP. So I've started the RDP client on my on-premises Windows system, and I've pasted in the IP address into the computer name field. So I'm going to go ahead and click on Connect. And then I'll specify the username and password for that virtual machine operating system, and I'll click OK. I get a message asking me if I want to trust this certificate from this host, since it's not issued from a trusting CA or certificate authority. I'm okay with that, so don't ask me again for connections to this computer, and I'll click Yes. That's going to take me directly into an RDP session within that server. This happens to be running Windows Server 2019. Now, it automatically loads up the Server Manager tool upon login. If I don't like that behavior, I can click the Manage menu in the upper right, go down to Server Manager Properties, and turn on the checkbox that says Do not start Server Manager automatically at logon, and I'll click OK. And I'm going to close out a Server Manager. I just want to open up a command prompt very quickly here on this host. Now, the reason I want to do that is because I just want to examine the IP addressing of the host. I'm just going to increase the font size here so we can see what we're doing in the command prompt environment. And what I want to do is issue the IP config command. What it's going to return is only the private IP address for this virtual machine or this VM. So the public IP address, even though this VM has one, is an Azure resource. It isn't reflected within the VM operating system. Remotely managing a Linux host is usually done over SSH, Secure Shell. This is an encrypted connection over the network to the target Linux host. Now, that can be a virtual machine or a physical machine. Here in the portal, I've got a virtual machine that's currently running by the name of Ubuntu-Serve 1. I want to remotely manage it. However, if I go into the overview blade of that virtual machine on the right, I notice it does not have a public IP address. Well, if it doesn't have a public IP address, how will I remotely manage it? It does have a private IP address. One way to remotely manage this is through a jump box. Jump box is essentially a host that has a public IP address that's reachable from the internet, and also a private one that allows connectivity to internal hosts. I have Azure Bastion deployed, so one way to do this is to click the Connect button up at the top here in the overview blade. I could also click Connect in the left-hand navigator. Either way, I can select Bastion. Now, when you have an Azure Bastion configuration, you'll then be prompted for the credentials, whether it's password or SSH private key based with a public key on the server side. I have password-based authentication here, so I'm going to specify the username and password. And after that, I'll go ahead and click on the Connect button. That's going to open up a new web browser tab where I'm going to have remote management capabilities for that Linux host. So if I were to issue the clear command, an ls, for example, and ifconfig, all of these Linux commands work as directed. So we've connected using the private IP address of the Linux host. I'm going to go ahead and close that out. But what about if we don't have Azure Bastion? Well, we'd have to have a public IP address then for the Ubuntu server. We can make that happen in a couple of ways. One of which is in the properties of the virtual machine, I can go down and click on networking to open the networking blade. Within the networking blade over on the right, there is a link for the network interface associated with this VM. I'm going to click on the link for that network interface. Now within the network interface, I can then click IP configurations in the navigation bar on the left. And then on the right, I will have an IP configuration listed for this interface. It's called, in this case, ipconfig 1. So I'm going to click on that to open that configuration up. Now, currently, for public IP address settings, it's set to dissociate. I'm going to click Associate, and down below, I then have to click on the IP address resource, public IP address resource, that I want to associate with this VM. I don't have any that are available. I have a few listed, but they're grayed out because they're already being used. They're already associated with network interfaces. So what I'm going to do is click Create New. I'm going to create a new public IP address resource, which I'm going to call Ubuntu-serve1-pub-IP. It's going to be a dynamically assigned public IP. If I have a workload requirement for it to be unchanging and static, I could also choose that. I don't, so I'll leave it on dynamic. And I'll click OK. So that's now been selected for the association of a public IP address resource with this configuration. So I'm going to click Save. And after a few moments, in the overview blade of the public IP address, there will be a value shown on the right, which I'm going to copy. I'm going to copy that public IP address. Next, I'll start the free PuTTY tool, and I will paste in the public IP address. It's going to make a connection to port 22. So I'm going to go ahead and click the Open button. However, after a few moments of that, we have a network error. Connection timed out. That usually means it's a firewall issue. So I'm going to shut down PuTTY and we're going to go back and troubleshoot this. So to do that, why don't we go back and go to our virtual machines view. And let's open up the properties for the virtual machine in question. It's a Linux one called Ubuntu-serve1. I'm going to click on networking in the navigation bar, because from here we can view the firewall rules. Now the inbound port rules are shown, but there's nothing here that would allow incoming traffic destined for port 22. And therein lies the problem. So I'm going to click the Add Inbound Port Rule button over on the right to remedy the situation. So what I want to do is make sure the destination is set to port 22 for TCP any destination, so from anywhere, to any Linux VM, port 22, allow. Priority will be 100, so it'll be checked before other rules that are starting, in our case, at 65,000. And I'm going to name this Allow Inbound SSH, because that's what we want to do. And I'll click the Add button. After a moment, our new Allow Inbound SSH port 22 rule will show up in the list. So let's try our PuTTY connection to the public IP once again. This time, I'm asked if I want to trust the unique RSA fingerprint of the server I'm connecting to. I'm going to choose yes, so I won't be prompted with that again. I'm being prompted to log in. Well, this is much better. So our rule for allowing SSH is working. So I'm going to log in with the appropriate credentials. And just like that, we are in. So if I were to issue, for example, the ifconfig command, once again, we'll see the private IP is 10.0.1.7. Notice, though, there's no reference here to the public IP address, which we've now assigned, because that's handled at the Azure level through the public IP address resource. But either way, we now have a few methods by which we can remotely manage a Linux VM in Azure through SSH. Azure Bastion is a jump box solution. What that means is that it allows connectivity from a public network like the internet so that we can go through that host to connect to the private IP address of an Azure VM to remotely manage it. So what it's doing is it's preventing us from exposing with a public IP address directly to the internet, RDP and SSH, respectively for Windows and Linux VMs. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Bastion, and I'll select it from the list, and then I'll click Create. I will define the resource group into which I want this deployed. I'm going to call it Bastion 1, and I'm going to put this, let's say, in the Canada Central region, since that's where most of my resources are deployed already. Then I'm going to choose from the virtual network list. I'll choose VNet 1. Now it says if you want to associate a virtual network with Bastion, it must have a subnet named Azure Bastion subnet with a prefix of at least /27. Now I don't have that available already in the drop-down list for VNet 1, but I do have a link here labeled Manage Subnet Configuration, which I'm going to click. So it takes me directly into the subnets blade for VNet 1. So I'm going to go ahead and click the Add Subnet button up at the top, and I'm going to call it Azure Bastion Subnet. And I need to specify an address range CIDR block that uses /27 as the prefix for network addressing. So I'm just going to change the /24 to /27. I'm using 10.0.4.0. Now, we have the ability to view all of our existing subnet address ranges in the background to make sure we're not overlapping with it, which I'm not. So I'm going to go ahead and click OK at the bottom to define this Azure Bastion subnet, at which point we've got the prerequisite configured. So I'm going to go ahead and click the X to close out of this subnet screen. And when I go back to where we were in the midst of creating the Bastion host, I then have the subnet dropdown list already populated with what we've just created. How convenient. So down below, we need to have a public IP address for the Bastion host. Remember, it needs to allow that kind of connectivity, but by extension, each individual VM does not need a public IP address. I'm going to call this Bastion Pub IP. Perfect. Then I'm going to click Next Tags at the bottom. I'm not going to add any tags, so I'll click Next Review and Create. The validation has passed, so to deploy this, I will click Create in the bottom left. After a moment, the deployment will be complete, so I'm going to click Go to Resource just to check it out. So it is a separate Azure resource. It is an Azure Bastion host used to allow remote management without exposing individual VM public IP addresses to the internet. Now we can click on Sessions in the navigation bar to see if any sessions are active currently through the Azure Bastion host, but it's returned no results. The way that you use Bastion is you click on a virtual machine in the portal that you want to remotely manage. Then when you click Connect, either in the Overview blade at the top, there's a button, or when you go to the Connect blade in the left-hand navigator, either way, you can select Bastion. When you choose that, it's going to request information about the Bastion host that's available, and after it's confirmed that there is one available, all you have to do is specify, in this case, the Windows credentials, because it's a Windows VM. Once I've done that, I just click the Connect button down at the bottom to initiate the connection. That's going to open a new web browser tab, and it's going to allow me to remotely manage that Windows VM. It could be Linux, but in this case, it's Windows, directly through my web browser interface. I've got an active start menu, and everything works nice and quick. Resizing a virtual machine means changing its underlying horsepower. Now, why would you want to do this, especially when you can determine that when you initially deploy the virtual machine? Well, the fact remains that you might not know at the time of virtual machine deployment exactly what kind of horsepower is required to support the given workload. You can monitor the VM over time to determine if it needs more horsepower, maybe more vCPUs, more RAM, or maybe less to save on cost. Either way, it's not a big deal. We can easily resize a VM. So here in the portal, I'm going to click on an existing VM. Notice that it has a status of running. So this is a running virtual machine, although it doesn't have to be to resize it. So I've clicked on it to open up its properties, and in its navigation bar, down under Settings, I'm going to click on Size. This will allow me to select a different size for the VM, either more or less power, to accommodate the workload. So the current size is selected in the list, and in this case, I'm going to increase the size, so I'm going to click on a different size. Now, when I work with the list will present information on the number of vCPUs available with that sizing, the amount of RAM, the number of potential data disks that can be attached to the VM, that's also part of the sizing, the maximum disk IOPS, which is a measure of disk I/O throughput. More is better if you have disk-intensive workloads. So I'm going to go ahead and click the Resize button. There is a message at the top stating if the VM is running, changing the size will cause it to be restarted. So if it's running a mission-critical workload, you don't want to click the Resize button during peak hours of that workload. After a moment, if I click the notification icon in the upper right, I'll have a successful message about the fact that the virtual machine was successfully resized. The thing to keep in mind after you resize a VM in Azure is make sure that you monitor it for a period of time to make sure that what you've done makes sense. Make sure that you've given it enough horsepower, for instance, to accommodate the workload. Remember that you can keep track of virtual machine statistics in many different ways, one of which at a very basic level is simply to go to the overview blade and check out some of the default metrics that are being presented, such as the average CPU utilization, the network traffic disk operations per second. Just because you have items charted like, there's some spikes in disk operations per second, or there are spikes in CPU on average, that's going to happen because the resources are being used. The question is it normal? And you're not going to know that until you monitor it over time to establish a baseline of what normal means when things are running well, such as when the workload is performing at an acceptable level. The sizing configuration for your Azure VM will determine how many data disks it will support. So for example, here in the portal, why don't we go to the virtual machines view and let's check out the sizing and its relationship to attached data disks. So I'm going to click to open up an existing Windows virtual machine that is already up and running. Not that it has to be to check out the size. In the navigation bar, I'm going to scroll down, and under Settings, I'm going to click on Size. So the current size for the virtual machine will be shown over in the right-hand panel. Here I've got 4 vCPUs, 16 gigs of RAM, and under the data disks column, it tells me that 8 is the value. So I can have up to 8 data disks attached. Whereas some of the other sizes available only allow 2 data disks or 4 data disks. So this is a part of what we have to consider with our virtual machine planning. And of course, we can change this after the fact, like we're seeing right here. We could click Resize. The only thing about that is that if the VM is up and running, it's going to cause it to be restarted. But we don't have to resize it. It's got support for up to 8 data disks. The next thing to take a look at is how many data disks are currently attached to the VM. So for that, we can just click on Disks in the left-hand navigator. The VM, for sure, is going to have an operating system or an OS disk. However, down below, under Data Disks, we'll see any data disks that might exist. Currently, we have none. So I could click Add Data Disk. When I do that, it will allow me to select an existing managed disk from the list. I don't have any. So I've got a link here, convenient, that I can click on to create a disk. Or I could have created a managed disk resource outside of this entire process. It doesn't matter how you do it. Why don't we just do it right here because it's in front of us. I'm going to click on Create Disk. I'm going to call this data disk 1. I'm going to associate it with the resource group. That's already filled in. The location I can't change. That's got to be Canada Central here because of the virtual machine location. I can choose the source type. I can get snapshot. So if I've taken a snapshot of a disk, then I can use that to create this new disk, kind of like using an image of a pre-existing disk. I might already have a disk, a VHD disk file uploaded as a storage blob, so I could go and specify the storage blob, or I could simply choose none, essentially to create a blank managed disk. The disk itself has sizing information. Here we've got 1024 gig premium SSD solid state drive. Depending on my requirements, I might click change size and select a different option. So for example, I might need a smaller size. I might want to determine what the max disk IOPS value is for the throughput. Depends on the workload. If you're running a disk-intensive workload, you want the highest IOPS value possible within reason. The higher you go, the more you pay. So you get what you pay for, essentially. I'm going to stick with the default sizing for this example, and the encryption type default is encryption at rest with a platform-managed key. So keys managed by Microsoft. I'm okay with that. So I'm going to go ahead and click Create to create this managed disk. So this is its own separate resource in Azure. It would show up separately if we were to look at the All Resources view. That's going to take us back to where we were. And where we were was in the disk blade for the virtual machine, and it automatically selects that data disk 1, under the data disks section. That's perfect. Now I'm just going to go ahead and click on Save to save that change. But we're not finished because it's much like if you were to plug in an external storage device into a physical server. What do we do next? Well, we initialize the disk, we partition it, and we format it so that we can actually use it. And that's going to be what we do next. For that, I'm going to go into the virtual machine and manage it. I can do that by clicking the Overview blade. I could have clicked Connect over on the left. It doesn't really matter, I suppose. And I'm going to click the Connect button at the top. I'm going to go through an Azure Bastion configuration. I've got an Azure Bastion host to allow remote management, or I could RDP it directly with its public IP. Either way is fine. So when I go to Bastion, I'm just going to have to specify the Windows OS credentials, which I will, and then I'll click the Connect button. It's going to open up another web browser tab, and I'll have a remote desktop session with the server, which is exactly what I wanted. In my virtual machine, from the Start menu, I've started Computer Management. I've clicked Disk Management on the left, and when I do, it automatically pops up and says that there is a disk 2, and I need to initialize it. I'm going to initialize it with the default selection of MBR, Master Boot Record, as opposed to Grid Partition Table, GPT. So I'm going to go ahead and click OK. So we've now got a second disk device that's unallocated. I'm going to right-click on it and choose New Simple Volume. And I'm just going to go through the wizard accepting all defaults to partition and format it as NTFS. And after a moment, it will be listed as being in a healthy state. And in this case, because of the configuration of my server, it's allocated drive letter E. So at this point, we have drive letter E available, which is a result of having attached that data disk. In preparation for encrypting virtual machine disks with customer managed keys, I'm first going to create a key in a key vault and then create a disk encryption set. So to start with this in the portal, I'm going to open up an existing key vault. Now the key vault and the virtual machine whose disks that we are going to encrypt, they need to be in the same region. So in my key vault, I'm going to go to the keys part of the navigation bar on the left, and I'm going to choose the Generate Import button at the top. I want to generate or create a new key that's going to be used here for encrypting VM disks. So from the options drop-down list, I want to choose Generate. Other options there include Import and Restore Backup. So Generate it is. I'm going to call this VM Disk Encryption Key. It's going to be an RSA 2048-bit key. I'm just going to go ahead and click Create, and the key is created within the key vault. Now what I need to do is create a disk encryption set resource. So I'm going to go home here in the portal, I'm going to click Create a Resource, and I'm going to search for disk, and that's enough actually. From there I can select disk encryption set, and then after that I can choose Create. I can choose the appropriate resource group I want this disk encryption set deployed into. I'm going to call this disk encryption set 1. And I'm going to create this, let's see, in, how about the Canada Central region, where everything else is that I've deployed. And down next to Key Vault and Key, I'm going to click the link that says click to select a key. Okay, so I'm going to click on that. What I'll be doing here is navigating into the Key Vault we were just in a moment ago, KV East 172, within which we'll select the key we created, VM disk encryption key, and the current version of that key, and I'll click select. Then I'll click next for tagging. And then after that, we're not going to add tags, so I'm going to click next, review, and create. And after the validation passes, I will click the create button in the bottom left to deploy the disk encryption set. For a moment, the deployment is complete, so I'm going to click the Go to Resource button to open up the properties of our newly created disk encryption set. We get a message at the top that says to associate a disk, image, or snapshot with this disk encryption set, you must grant permissions to the Key Vault, KV East 172. Okay, I'm going to go ahead and click on that. After which, if I click my notification bell icon in the upper right, it states that it has successfully granted the permissions, so to our Key Vault. So at this point, we've done the legwork or the prep work to allow for the encryption of VM disks using customer-managed keys. In this demonstration, I'm going to create a new managed disk, and then I'm going to enable customer-managed keys for the disk. That disk can then be attached to a virtual machine. So to get started here in the portal, I'm going to click Create a Resource, and I'm going to search for disk, and I'm going to choose Managed Disks, and then I'll choose Create. I'll specify a resource group into which I want to deploy this managed disk. I'm going to call this Data Disk 2, and I'm going to make sure I deploy this in the same region, in this case Canada Central, where I've got a Key Vault where I've defined a key, and also where I've created a disk encryption set resource. So I'm going to click Next for encryption. The default encryption type here, when you're building a new managed disk, is the default encryption at rest with platform managed keys. You could choose to encrypt at rest with a customer managed key. However, you can also change that after the fact. So I'm going to leave it on the default and click Next, Tags, Next, Review, and Create, and then I'll click Create to deploy this new managed disk. After a moment, the deployment of the new disk is complete, so I'm going to click Go to Resource. Just like we had the option of enabling customer managed keys, we can click on encryption here in the left-hand navigator. We'll see the same option we saw upon creation, encryption at rest with a platform managed key. We could open that list and choose encryption at rest with the customer managed key. And I can choose an existing disk encryption set from the list that I've already deployed. That's a separate Azure resource. After which I can then click Save. When I do that, the encryption will be enabled for this particular managed disk using that disk encryption set. Let's go take a look at that disk encryption set just for fun. So I'm going to go to my All Resources view, and I'm going to filter out the list for only disk encryption sets. So type equals all at the top, not for long. I'm going to click on that, uncheck Select All, turn on the check mark for disk encryption set, and click outside of it. There it is, disk encryption set 1. I'm going to click on it to open it up. And if I click the key part of the navigation bar, on the right, I have a reference to the Key Vault and the key and the version of the key that is being referenced. So in the end, this is what is being used to encrypt that newly created managed disk. At this point, we can associate or attach that managed disk to any VM that we wish for it to be used. You can use the portal to deploy a virtual machine scale set, otherwise called a VMSS. As the name implies, it will support auto scaling. So you can think of it as being kind of a load balanced type of solution where you have multiple VMs serving up the same kind of app or functionality. So to get started here in the portal, I'm going to click Create a Resource in the upper left, and I'm going to type in the word Scale, and I'm going to choose Virtual Machine Scale Set, and then I'll choose Create. So I'll specify the resource group I want this deployed into, and I have to give this a name. I'm going to call it VMSS1, VM Scale Set 1. I'm going to deploy this in, let's say, Canada Central, where I have everything else deployed. And I can determine that the image be Ubuntu or Windows or Oracle, Linux, Debian, CentOS, whatever the case might be. So if I know, for example, that I want to use Server 2016 Data Center, so a Windows image, then I can select that. Now I can also click the Browse All Public and Private Images because we might already have a private image that has not only the OS, but it might be tweaked and configured and have all the software components to support the app that we're trying to make available through this virtual machine scale set. Okay, so down below I have to specify some details for each VM. So I'm going to specify a username and a password. Up above, I'm going to leave the existing sizing with 2 vCPUs and 8 gig of memory. I'm okay with that. And I'm going to click Next for disks. So the disks for the OS image that we selected. The default is a premium SSD operating system disk. The encryption is encryption at rest with a platform managed key, but if we have a customer managed key setup available through a disk encryption set, we could also use that. We might do that for regulatory compliance. However, I'm going to leave it at the default encryption at rest with a platform managed key in this case. I'm not going to add any data disks, so I'm going to click Next for networking. Now I want this virtual machine scale set deployed into a specific VNet. I'm going to choose it from the list here, VNet 2. Down below, for each virtual machine, we've got a NIC or a network interface configuration. We could add multiple NIC configurations. We could also tie this virtual machine scale set with an actual Azure load balancer. However, I'm going to leave that on no for now, and I'll click Next for scaling. Now with the scaling, we can have an initial instance count, and we can determine that we want a custom scaling policy. Currently it's set to manual. So I can set the minimum and the maximum number of VMs and determine when new VMs are added for scaling out horizontally. The default is the CPU threshold exceeding 75%. For 10 minutes, increase the number of VMs by 1 at a time. And for scaling in or removing VMs when things are slow, once we get a CPU threshold below 25%, then we'll decrease 1 at a time, 1 VM at a time. So that's fine. I'm okay with that. So I'm going to go ahead and click Next. That takes me to the management options for the scale set. I'm going to accept all of the existing defaults for that. I'll click Next for health. I'm not going to monitor the app health this way. There are other ways that can be done, such as through application insights. So I'm going to click Next for advanced. I'm not going to make any changes here. Next for tags. I'm not going to add any tagging info. So I'll click Next, review, and create. And after the validation has passed, which it has, I will click the Create button in the bottom left to deploy this virtual machine scale set. Before too long, the deployment is complete, so let's check it out. Let's click on the Go to Resource button to go into the virtual machine scale set. The first thing I'm going to do is check out the number of instances that are running and some of their details. So I'm going to click the Instances item in the navigation bar. In the right-hand panel, we'll have a listing of instances, one of which here is shown as running, the other which is in the midst of updating. So the instances for the virtual machine scale set then show up here, but not in our normal virtual machines view. So if I go home and go to virtual machines, we'll see any normal existing VMs we might have deployed, all of which are shown as being stopped here, but you don't see the scale set instances. They are contained and shown only within the virtual machine scale set. Azure supports dedicated hosting for virtual machines. What this means is that you actually have an entire physical server in an Azure data center allocated for your exclusive use. So that means that VMs deployed by other customers will never show up on that dedicated host. To begin this configuration, we need to create a dedicated host resource. So here in the portal, I'm going to click Create a Resource. I'm going to search for dedicated, and immediately I see dedicated hosts. So I'm going to click Dedicated Hosts, and then I'm going to click the Create button. So we're going to have to fill in a few details here, including, of course, the region. We're going to have to name it, and we're going to have to either create or associate with an existing host group. We'll talk about that. So first of all, the resource group will be East RG1. The name here will be dhost1 for dedicated host 1. And I'm going to specify the location, let's say here, where I know I'm going to want close access to these things geographically. So perhaps I'll choose a location like Canada Central. Now I can choose an existing host group, one has popped up here automatically, or I have a link to create a new host group. Like the name implies, a host group allows you to organize multiple dedicated hosts together under one item called a host group. I've already got one created called HG1, so that's fine. The next thing I can specify is the sizing family. This is going to be important because you can't just run any VM size on any dedicated host. Naturally, it's going to be dependent upon the underlying physical horsepower available in that underlying host. So that's fine. I'm going to select the appropriate size family. We can also specify a fault domain related to this dedicated host. Now, there are only two available, which stems from my configured host group up above. You get to determine the number of fault domains when you create the host group. So when I created that, I specified that there were two of them, so I can determine which one I want this dedicated host associated with. The idea is that we want to spread out virtual machines across multiple fault domains. A fault domain is a physical equipment rack. So when you spread things out across two physical equipment racks, if you have a VM running on one set of equipment and that equipment fails, the other VM is still left running. So that's fine. Automatically replace host on failure. I'm going to leave on enabled. And at the bottom, if I've already got some existing operating system licenses, then I can specify them for Windows and for SQL. Well, I don't, so I'm going to go ahead and click Next for tags. There's no tagging information. I'll click Next for Review and Create. Now I have a validation failure message at the top. That's usually because you're not selecting the right VM sizing for the underlying host. So I'm going to go back to basics and let's just check out where the problem is. And it is actually with the size family. It says 64 vCPUs are needed for this config, but only 8 vCPUs of 10 remain. Okay, so I have to select the appropriate family type that I think will be supported. Now, if they're not supported, and I'm not having a whole lot of luck here, then you might have to choose a different region that would have different physical hosts available in an Azure data center. So Canada Central doesn't seem to be cutting it. That's fine. So let's say, for example, I were to choose West Central US. Now, because I don't already have a host group created in that region, I can't select it. I have to create one. Not a problem. We need to see that anyway. So I'm going to choose Create New Host Group. This one's going to be called HG2, Host Group 2. And we mentioned earlier, this is where you specify the fault domain count. Let's say up to 2. I'll click Add. Once we've made the correction, we could review create and then actually create the resource. I'm not going to do that. Instead, I'm just going to click the X in the upper right, and I'll click OK when it says I'll lose my work. But I'm going to go home, because one of the things to bear in mind is that when you deploy a new virtual machine, so I'll just start that process, one of the things you can do during that deployment is specify the host group for dedicated hosting. You're going to be able to do that under the Advanced tab of the Create a Virtual Machine wizard. So I'm going to click right on Advanced just to jump right to it so we can see the option. And when I scroll down under Host, I can choose from the host group list. And once it's actually configured, it'll be available for selection. So in this course, we've examined the planning, creation, and management of virtual machines, or VMs, for both Windows and Linux, as well as remote VM management. We did this by exploring how to plan for Azure VMs, how to use the portal, PowerShell, and the Azure CLI to create Windows VMs, how to use the portal, PowerShell, and the Azure CLI to create Linux VMs. We examined how to create a VM using an ARM template, how to use PuTTyGen to create SSH keys, and enable Linux VM public key authentication using the portal. We examined how to connect to both a Windows and a Linux VM for remote management, including how to do that through Azure Bastion. We looked at how to perform VM resizing and how to create a managed disk and then attach it to a VM. We looked at how to enable VM disk encryption using both the portal and PowerShell. We examined how to deploy a VM scale set, and finally how to configure a host group and dedicated host for running VMs. In our next course, we're going to move on to explore how to work with Azure AD, including planning and deploying Azure AD tenants, user accounts, and user settings. Azure Active Directory, otherwise referred to as Azure AD, refers to running Active Directory in the Azure cloud, specifically as a managed service. You'll also hear references to Azure AD tenant, which is a separate instance of a named Azure AD environment. So within Azure AD, we have a centralized repository of configurations for things such as user accounts, groups, apps, and security principles, where security principles we'll discuss a little bit further in how they're different from regular users in Azure AD. We can also link our Azure AD tenant to an on-premises Active Directory installation. We would do this using Azure AD Connect, which is an on-premises agent you would install on one of your domain member servers to link the two directory services together. The purpose of that would be to allow on-premises user credentials to authenticate to Azure Cloud Apps. So we can manage Azure Active Directory in the sense of managing things like users and groups and so on using the GUI, the portal. We can also do it using command line tools like PowerShell and the CLI. But the thing to watch out for is that Azure Active Directory or Azure AD is not the same thing as Azure AD Domain Services. They are two separate and distinct products. So as an example, with Azure AD, there is no full support for all features that you would find with your installation of Active Directory on premises. So notably, Azure AD doesn't support group policy, but Azure AD Domain Services does support features like group policy. Now, Azure AD Domain Services is a managed service like Azure AD is, meaning you don't have to worry about setting up the virtual machines and configuring them as domain controllers. But there's more flexibility with Azure AD Domain Services. There are a number of security options we need to be aware of when it comes to Azure AD, like role-based access control, where we can assign roles to limit other Azure administrative access to manage Azure resources. There's conditional access. We can create conditions that determine how someone must authenticate before we allow them to be authorized to use things like cloud-based apps. So they might have to sign in with multi-factor authentication using an iPhone from a specific IP address range. Then there's Azure AD Access Reviews, which we can run periodically to ensure that things like group membership or assignments to use apps are still relevant, and if not, then we can remove those permissions to enhance our security posture. There's privileged identity management, which essentially is just-in-time access for admin privileges in Azure that we can allocate to administrators that need to manage Azure resources. We can enable multi-factor authentication to enhance sign-in security. So for example, besides just username and password, we might require some other type of authentication factor. And finally, we can also enable single sign-on or SSO. So once the user signs in initially, let's say with their on-premises domain credentials, and that's linked to Azure AD, they won't be prompted for their credentials when they access Azure Cloud applications. So this is all part of Identity and Access Management, or IAM, where we're talking about managing users and groups in Azure AD, devices that can be registered with Azure AD, and also service principals. A service principal you can think of as being a dummy user account whose purpose is to apply permissions to software components, such as other Azure services or custom code running in a VM. Along the same line of logic, we also have managed identities. The difference is that a managed identity is automatically managed by Azure. So when you deploy some services, it will automatically configure the managed identity that might allow software components to have access to other resources. So service principals, you manage. Managed identities are managed by Azure. Now, the other thing to think about is authentication, which is the proof of identity. Single-factor authentication would use things like username and password. So despite the fact that those are two items, they both fall under one category, in this case, something you know, so hence single-factor authentication. Multi-factor authentication will use another category, such as something you have, like a smart card. Authorization occurs after authentication. It allows for the controlled access to resources, whether on premises or in the Azure cloud, and it could fall under the manifestation of assigning permissions or configuring policies, perhaps assigned to groups that allow access to resources. So multi-factor authentication then requires additional authentication factors, and often it uses out-of-band authentication codes. What that means is that while we might be using a desktop computer to authenticate to Azure with a username and password, we might have a code sent to our smartphone, so a different mechanism, hence out of band, before we're allowed to authenticate. So it's considered to be more secure than only a username and password authentication. Bear in mind, with Azure AD conditional access policy, signing in with MFA might give you access to resources that you otherwise might not have access to. So we're talking about combining two or more authentication categories with MFA, such as something you know, like a username, and something you have, like a smart card. It could be something you know, again, like a username, and something you are, such as a unique biometric fingerprint scan. Or it could be something you have and something you do, which is more related to gesture type of authentication. So the Microsoft Authenticator app then is one example of an out-of-band app that would run, let's say, on your Android or iPhone device. It would allow you to authenticate beyond your username and password with a 6-digit PIN that changes every 30 seconds. When you sign up for a new Microsoft Azure account, an Azure AD tenant or instance is automatically created for you, where you can create user accounts and groups and so on. Now, here in the Azure portal, once I've signed in, I can see my current Azure AD tenant by clicking in the left-hand navigator, scrolling down and selecting Azure Active Directory. In my case, I am currently using an Azure AD tenant by the name of Quick24x7. However, if I have multiple Azure AD tenants, I can switch between them in the upper right. But before we do that, let's create a new Azure AD tenant. Now, why would you do that? First of all, let's go home and let's click the Create a Resource button. Now, you would create a new Azure AD tenant for the same reasons you would create a new Microsoft Active Directory domain on premises. For example, we have a different business unit that's completely separate from our current business unit. So we might want administration to occur separately for things like user accounts. So we might build a new Azure AD tenant for that. Or if we're a parent company, we might have acquired a new subsidiary or child company that we might want to have separated when it comes to Azure Active Directory into their own tenant. Or it might be for a different country where we run business operations, or a different project. There are many different reasons. Either way, here where I've started the process of creating a new Azure resource, I'm going to search for Azure Active, and I will see Azure Active Directory in the list which I can choose because I want to create a new instance of that, and then I'll go ahead and click the Create button. So the first thing I have to do is provide an organization name. In this case, I'll use a fictitious example such as Your Way Airline. And I must specify the actual domain name that will be used in user principal names, such as the email address for users in Azure AD when they sign on. So I'm going to specify Your Way Airline, and it will automatically append the .onmicrosoft.com suffix. Now, if that name is not unique, as it is not in this example, you're going to get a little signifier or an icon to the far right of the initial domain field that will tell you that it's already in use by another directory. So you'll have to change the name so it's unique. So I'm just going to add something to it to make it a unique name. I'll click outside of it until I have a green check mark to the right of that field. When you do this, make sure you are adhering to organizational naming standards when it comes to proper nomenclature. Down below, I'll then choose the country or region. In my case, I'm going to type in CAN, and then I'll select Canada, and I'm going to click Create. So I have a message stating that the directory is being created now. This might take a few minutes, so we're just going to wait a moment until the new Azure AD tenant is deployed. After a moment, the new Azure AD tenant is deployed, and we can click the Here link to manage the new directory, which I'm going to do. That's going to switch me to that Azure AD tenant because I was originally connected to one called Quick24x7. At this point, I'm now in the Your Way Airline Azure AD tenant. And if I click on users over on the left, I'll be able to work with user accounts in this Azure AD tenant. The only one here by default is related to my Azure account, but we've got the buttons to create new users or guest, or rather external users that we want to invite to partake in our Azure AD tenant. Now we can switch between the tenants in the upper right. Currently, my sign-in name reflects the current tenant, which says Your Way Airline. But if I click on that, I can click Switch Directory. And here, for example, if I want to go back to the Quick 24x7 Azure AD tenant, I can just click on it and I will have been switched over. So if we examine this tenant, for example, if I click on users, just like we did for our newly created tenant, we're going to see a different listing of users. The reason is because it's a different instance of Azure AD. It's a different tenant. The other thing to watch out for is subscriptions. Your Azure subscription is tied to your Azure AD tenant. The subscription allows you to create resources, and it also is how you are billed. So for example, if I were to search for sub in the top center bar here in the portal and click subscriptions, I would be viewing one or more subscriptions tied to my current Azure AD tenant, which in the upper right is showing as Quick 24x7. And so I've got a pay-as-you-go subscription. And that means that if I were to go, let's say, back home in the upper left and then click all resources, I would see Azure resources that were deployed within this particular subscription for this Azure AD tenant. Now let's switch over to our newly created Azure AD tenant. So I'm going to click in the upper right, choose Switch Directory. We're looking for Your Way Airline. So I'm going to click on that to switch to it because I want to examine subscriptions for this Azure AD tenant. So I'm going to search in the top center bar for the word sub because I want to navigate to my subscriptions for this tenant. So I'll click on subscriptions. Any subscriptions that might have been attached or created for this will show up. But because it's brand new, there are none listed. Instead, we have a message that states you don't have any subscriptions. If you don't have subscriptions, you can't do anything. So if I were to go back home by clicking the home link, and let's say in the left-hand navigator, if I were to choose the All Resources view, I won't get a list of resources because we don't have a subscription to create them in the first place. So that's the relationship then between subscriptions and an Azure AD tenant. And at the same time, we've seen how to deploy a new Azure AD tenant. You can use Azure AD verification methods as a mechanism to ensure that users can be contacted in a variety of ways for authentication purposes or forgotten password purposes, such as through a phone call, SMS text message, and so on. Let's take a look at some of these AD verification methods that are related to security. So to get started here in the portal, I'm going to open up the navigator on the left and click on Azure Active Directory. The next thing I want to do is scroll down in the navigation bar for my Azure AD tenant all the way down to security. After I click on security, I then, in the new navigation bar that opens up, want to click on conditional access. There are a couple of important things here that we can use to tighten sign-in security. An example of this would be named locations. So I'm going to click the Add New Location button at the top where I have to provide a name, let's say HQ for headquarters. And I can specify either IP ranges in the form of IPv4 or IPv6, where we would use this within a conditional access policy to allow access from certain locations, or we can even specify entire countries. So for example, if my operations are primarily in Canada, then I could choose Canada as an allowed named location. So I'm just going to go ahead and click Create. So that's one aspect of this. But the other aspect of this is to click the Configure MFA Trusted IPs button at the top here over in the right-hand panel. Because when I do that, this is where I'll have a number of verification options. If I scroll down, there's a heading labeled Verification Options, where we can have call to phone, text message to phone, notification through a mobile app, and verification code from a mobile app or a hardware token. So imagine that you want to enable multi-factor authentication MFA for users. So in addition to a username and password, maybe an additional verification option would be for them to receive a verification code through a mobile app like the Microsoft Authenticator app. So that's what we have here to help verify user identities to harden our security environment. So once we've selected the appropriate items, we could click on Save to save the configuration. I have a message about the update being successful. Now I would click Close. So now when users, for example, are configuring multi-factor authentication or MFA, for example, upon their login after it's been enabled, they'll have these verification options to choose from. You can create users in your Azure AD tenant using the Azure portal. These users might be for regular users so they can authenticate and gain access to cloud apps, including Office 365 related apps, or it could be for another Azure technician or administrator that you want to be able to manage some or all of the objects in an Azure subscription. So to get started here in the portal, I'm going to open Azure Active Directory by opening my navigation bar on the left and scrolling down and then selecting Azure Active Directory. I will then click on the Users view. That puts me in the All Users view where any existing user accounts will be listed. What I want to do at the top is click New User. That's a button. Now I have to make sure that I follow naming standards when it comes to how we're going to name user accounts in our environment. The first thing I'm presented with is whether I just want to create a user, which is the default selection, or invite a user. Inviting is when we have users that already have an external identity, such as an email address outside of Azure that I want to invite to partake in our Azure AD tenant, maybe so they can access some apps in Azure. In this case, I'm going to leave it on Create User, and down below, I'm going to create a user, C. Blackwell, Cody Blackwell. After the @ symbol, we can then select if we have multiple options from our Azure AD tenants or custom domain names. I'm just going to use the domain name for one of my Azure AD tenants that I want this user to be created in. And for the name, I'll specify the full name. In this case, it's going to be, let's say, Cody Blackwell. First name is Cody, last name is Blackwell. So I'm filling in the appropriate fields. The password will be auto-generated, so I can choose Show Password, which I'll copy, and then I can communicate that to the user in a secured manner. So they'll have to change their password upon first sign-in. As I go further down through this screen, I can opt to have this user be made a member of a group in Azure AD or assign them roles, so they could have special permissions to manage Azure resources like virtual machines, storage accounts, and so on. I don't want to block the user's sign-in, so I'll leave that on the default of no. I could specify a usage location. So for example, I'm going to specify Canada. Some security features in Azure AD will require this usage location to be set. In some cases, that's also applicable for assigning licenses that might be tied to a geographical location. I can specify a job title. I'll put here Sales Manager and a department, in this case Sales. And then I'll go ahead and click Create to create user Cody Blackwell. So after a moment, user Cody Blackwell will be listed in my list of users in the All Users view here in Azure AD. I can click on that user account to open up the details. So we have a properties bar on the left. And in the profile blade over on the right, I have a button at the top to reset the user password, to edit their properties, to delete the user account. If I scroll down in the profile blade over on the right for the user, we also have options such as the user object ID, which we could copy if we, for example, wanted to use command line tools to access that object via the object ID versus the name of the user or the user principal name, such as the sign-in. We can also edit things like the contact info for the user over on the right. So we can specify their street address information and their office versus mobile phone number. All of that stuff is available. In the left-hand navigator, we can also view any assigned roles for this user. I could click the Add Assignments button, and I could add some Azure AD roles. So if this person is going to be helping out with administering everything in Azure AD, then I could add them as the Global Administrator role, which I will do in this example. So this is an assistant for Azure administration. We can also assign the user to groups by clicking Groups or to applications that might be registered with Azure AD, so they have access to certain apps. We can assign licenses. We'll see any devices the user might be associated with if those devices have been registered with Azure AD. In our case, we have a message stating there's no device found because nothing has been registered for this user when it comes to Azure AD. We also have Azure role assignments shown over on the left, where any roles that might have been assigned to the user, let's say, for example, as a virtual machine contributor, so that's a role outside of Azure AD, that would allow the user to manage everything about virtual machines wherever that role was assigned, whether it's at the subscription level, the resource group level, or to an individual virtual machine in our particular example. We can also click on authentication methods on the left and configure some details for the user, such as the authentication contact info, the phone number, the email address, and so on. So let's go ahead and try to log in as our newly created user, Cody Blackwell. So I'm going to sign in to myapps.microsoft.com as that user. That's typically what a standard user would sign in with to access apps. Of course, we could also sign into the portal at portal.azure.com. Since that account is an assistant administrator, either way would work to test it out. So I'm going to select to use the myapps.microsoft.com URL. So when I sign in, I will specify the user principal name or the email address of the user. In this case, it's cblackwell@ and the DNS name for my Azure AD tenant, which in my case is quick24x7test.onmicrosoft.com. So I'm going to go ahead and click Next. It's then going to require the password for that account, which I will specify, and then I'll click the Sign In button. Because it's the first time the user is signed in and we had set that password when we created them, we'll have to update the password, or the user will when they sign in. So they have to specify the old password and then specify a new password and confirm the new password, which I will do, and then I'll click the Sign In button. User Cody Blackwell, whose name we see in the upper right along with the Azure AD tenant Quick24x7, is now successfully signed in to myapps.microsoft.com. Sometimes using command line tools like the Azure CLI is a preferable way to manage Azure, such as in the case of creating Azure AD users. The reason it might be preferred is number one, an administrator might be more comfortable at the command line, and number two, you might want to script the creation of users. Maybe not specify all the details right in your script like usernames, but maybe have them passed in as parameters and use the CLI to build multiple users over and over. So really we're talking about a potential for automation. In this case, we're going to build a single user using the CLI here in the portal. So within the portal, the way we're going to do that is I'm going to click the Cloud Shell icon at the top so we can run the CLI commands directly here in Cloud Shell. So to get started, the first thing that we want to do is find out what the syntax would be. And for that, I might run AZ AD user create-h for help, so I get help on the next level commands for working with user accounts. So as I scroll back up through the help output, I have a list of arguments or parameters that I can pass on the command line, like --display-name, --password, --mail-nickname, and so on. We have to provide values for those arguments to go ahead and create a user using the CLI. So I'm going to go ahead and clear the screen, and we're going to go ahead and create a new user. Now, you will have made sure ahead of time that you've got a standard naming convention for new user accounts. So I'm going to use the AZ-AD user create command. --display-name, in this case, I'm creating user Jen Hill. So it's in double quotations because there's a space between the first and last name. --user-principal name, I'm going to specify the email address for that user, which in this case is jhill, and then at my Azure AD tenant DNS domain name, which in my case is quick24x7test.onmicrosoft.com. The next thing I'm going to do is specify the --password parameter or argument with a value of the password I want for this newly created user. So at this point, it's just a matter of pressing enter to create user Jen Hill. What you should get back is some JSON output that implies that the account was created. So I'm going to clear the screen with CLS. We can also run AZ-AD user, if I spell this correctly, list -- query space open close square bracket dot, and the property I might choose to view for users is male nickname. Now, this is case sensitive, so the capital N is important here in nick. Got to go ahead and press enter, and any male nicknames for users that we've created will show up. I do have a listing here for Jen Hill. So this is one way we could verify that account exists, at least in the specific CLI. If we ever wanted to make changes to a user account, we could also run the AZ-AD user update command. I'll just use -H after that so we can get a sense of what we might be able to do here. So as we go through this, we could specify the --ID argument for the user that we want to update, the object ID of the user account, and we might do things like force a password change at next login, or set the user password, the male nickname, and so on. I'm just going to go ahead and clear the screen with CLS. This time I'm going to run AZ-AD user-H. What if I want to remove the user? Well, there's not actually a remove part of the syntax, but rather delete. So we could specify a user account that we wanted to delete. So not only can we create users using the CLI, but the point is that we can also manage them to the ultimate, inevitable decommissioning of that account, which could include deleting. In this demonstration, I'm going to use PowerShell to create an Azure AD user account. Here I've launched Cloud Shell from the Cloud Shell icon within the portal. And to get started, I'm going to deal with the password. So to deal with the password for the account I will create using PowerShell, I'm going to create a variable that in this case I'm calling $secure string password equals convert to -secure string. So we want to store this as a secure string in memory in the variable -string, and then I specify the value of the password here in double quotation marks -as plain text -force. So when I press enter, if I were to play back what's stored in that variable, meaning if I just type in $secure string password, see what's in that variable, we don't see the actual password because it's been secured. That was the whole purpose. Instead, all we see is the data type, which is system.security.secureString. So the next thing I'm going to do is clear the screen with CLS, and I'm going to run get-command. And I want to know how to work with the new user. So I'm guessing that the PowerShell commandlet begins with new. I'm not sure what's after that, let's say. So asterisk or a wildcard. I'm going to put in user and then a wildcard again to see what we come up with. And it would appear that we have a commandlet by the name of new-AZ-AD user. That sounds like what we want to work with. And we can get help on that with get-help, new-AZ-AD user, maybe ask for -detail, and pipe that to more. So it stops after the first screenful of output. This is perfect because the synopsis states that it creates a new Active Directory user. Specifically in our context, that would be an Azure Active Directory. And as we continue down through the output, we'll have a sense of some of the parameters and values that we can specify. Display name, force password change, male nickname, -password. And notice that the data type required for -password is system.security.secureString. Oh, we're good for that because that's what's in our variable. So we can just pass our variable name, prefixed with the $, of course, in PowerShell, as the value for that parameter. So I'm just going to press Q to get out of there. So what I want to do is actually use the new -AZ-AD user commandlet with -display name. In this case, the user I'm creating is Sharon Bishop. -user principal name is going to be the email address for that user. In this case, sbishop @ and then the DNS domain name suffix for my Azure AD tenant. -password, I'm simply going to give it $secure string password, the variable that we started off this discussion with. So let's go ahead and press enter. Now, I didn't specify a mandatory argument on the command line, the male nickname. So any mandatory or required parameters that you don't supply on the command line, you will be prompted for. That's not a problem. So I'm just going to put in S Bishop for the mail nickname. I could have used -mail nickname S Bishop on the command line. But at any rate, we'll be able to create the user. Now we have an error message in red, but in looking back up at our syntax, I realized that in the user principal name or the email address for the user, I've got a space after the @ symbol. Well, no wonder it didn't work. That's okay, let's correct it. Up arrow key to bring up that previous command, and I'm going to fix that problem by removing the space within the email address. And you know what? While we're here, why don't we just add -mail nickname of S Bishop so it doesn't prompt us for anything. And this would be important if you decided you wanted to script this and have minimal interruptions when the script is run. So let's see what we get this time. I'm going to press enter, and immediately we get some output. It looks like things worked. Let's verify our work. Let's clear the screen with CLS, and now I'm going to run get-az-ad-user. I'm going to pipe that to select, because all I really want to see are a few properties, not everything. Let's say we want to see the display name and maybe the ID of the user. So display name, comma, ID. So now I have a list of users in my Azure AD tenant along with their IDs in the right-hand column. And of course, we're looking for user Sharon Bishop. Now that ID, the object ID shown on the right in this case, that is automatically assigned by Azure to objects in Azure AD, such as for Sharon Bishop, we can use that ID if we wanted to make a change. So I'm going to go ahead and copy that. What I mean, let's say, is that we wanted to change her name. We want to change Sharon's name from Sharon Bishop to Sharon, it doesn't matter, let's say Ballantyne. So I'm going to go ahead and run the update -azad user command. It's not case sensitive. -object ID. In this case, I'm just going to go ahead and paste in the ID that I just copied a moment ago. And after I've done that, what I want to do is I want to set the display name to be different. So -display name, that's what I want to modify or update. I want the new name to show as Sharon Ballantyne. So I'll just specify that and press enter. And I'm going to go ahead and clear the screen with CLS. And for convenience, I'll use the up arrow key to go back up through my commands to the point where I get to the get-az-ad-user line. I'll press enter. And indeed, the display name for that account, of course, has changed. If we wanted to, we could also update, of course, the user principal name to reflect the change in the last name for that user account. One great flexibility option when dealing with Azure AD user accounts is the use of guest users. You can invite users that don't actually have an account in Azure AD to partake in accessing Azure AD related type of apps, including for even Office 365. So in other words, you are sending an invitation to an external user email address. How is this done? Why don't we take a look at that? So I'm going to click here in the portal in the left-hand navigator to open it up. I'm going to go all the way down and click on Azure Active Directory. What I want to do naturally is go into users. So I'll click on users on the left. At the top of the users panel on the right, I can click new guest user, but actually if I just click new user, I can also choose to invite a guest user from this screen. The default is to create a user directly in Azure AD, but I could just as well choose invite user. Either way, inviting a user or adding a guest user really does mean the same thing. So what I need to do is specify a username. I'm going to call this fake user. And the email address in this case is just going to be fake user 173, let's say, and at hotmail.com. So whatever the email address is for that user, first name is fake, last name is user. And this is similar at this point to configuring a standard Azure AD user account. We have to fill in some fields. I can also put in a personal message. Welcome to our Azure AD tenant. Enjoy the apps. So the user will have had to have been assigned to applications before they'll see them if they were to go into, for instance, myapps.microsoft.com. So like a regular Azure AD user, I can also here with my guest user, add them to groups, assign them roles, block sign-in, specify job information. However, at this point, I'm just going to click invite to trigger the sending of that email. Now, what we want to do is open up that user's mailbox to check out what it looks like. Now, before we do that, here in Azure AD, in our all users view, we have our user listed at the bottom, fake user, and the user type column reflects for that account that it's a guest as opposed to a member. Here in the inbox of that user, we have a mail message from Microsoft Invitations about the quick 24x7 Azure AD tenant inviting the user to access apps within the organization. And as I go further down, we'll have a reference to the actual original message that I specified, welcome to our Azure AD tenant, enjoy the apps, and the user can then click the accept invitation button. Then there's a review permission screen for this user that they must accept because the organization, our quick 24x7 Azure AD tenant, wants to sign the user in and then read the name, email address, and photo for their account. So ideally, the user would click on accept. And after a moment, the user is signed into the myapps.microsoft.com site. Of course, we haven't assigned any apps for the user, so we have a message stating there are no applications available. But we have successfully created the external user account, sent the invitation, and the user has accepted it and successfully signed in. You can create enterprise application definitions within Azure AD, and then you can allow both Azure AD users as well as external users access to those applications. And those external users might be as a result of a business-to-business or B2B relationship. So here in the portal, I'm going to start by going into Azure Active Directory, and I'm going to go into Enterprise Applications. I've already got an application named Sample1. Otherwise, I could click the New Application button up above to register an app that might be in the midst of being developed by a team of software developers. It could be an on-premises applications or some other app that isn't available in the Microsoft Gallery, which we'll gain access to as we scroll down below. So we can add standard apps that might be available like Dropbox, GitHub, Jive, Office 365 apps, that type of thing. So I've already added a sample called Sample1, just a sample custom app. So if I click on the app to open it up, it's within here I can go into users and groups to determine which users or groups should have access. So within here, I'm going to click the Add User button up at the top. I'm going to click Users and Groups, and from here I can search for any external user accounts that might already be registered with our Azure AD tenant. I have one called Fake User, so I'm going to select that external account. I'll click Select. The default role here is default access. That's fine. I'm going to go ahead and click Assign. So then Fake User has now been assigned to Sample App 1. The next thing I'll do is from a web browser, I'll connect to myapps.microsoft.com and I'll sign in with that fake user account, which is really just an external account that's been added as a guest or invited to Azure AD. After we've signed in with our external user account, we'll then have Sample App 1 listed within our list of apps on the myapps.microsoft.com webpage. So you can create users individually, one at a time in Azure AD using a multitude of ways. You could do it here in the portal, using the CLI, PowerShell, and so on. But what about if you have a bunch of users, so many users, that you need to create all at once? That's what the bulk operations is for. So for example, we could have a prepared file, a CSV file, that has the items for each user specified correctly, and then we can import that file to create a bunch of users all at once. Let's examine exactly how that's done. So here in the portal, the first thing we need to do is get into Azure AD. So I'm going to click in the left-hand navigator and scroll down and click Azure Active Directory. And because we're talking about users, well, of course, then we're going to click Users over on the left. Now in the Users panel, the All Users view over on the right, there is a button up at the top labeled Bulk Activities. So I'm going to click to open that. Now, bulk invite would be if you want to invite external users, which is fine. This is completely valid. But in our particular case, we don't want to bulk delete. We don't want to download users. We want to bulk create. So I'm going to select bulk create, which opens up the bulk create user blade over on the right. Now, the first thing you'll notice is in step 1, we have a download button we can click on to download a CSV template, comma-separated values. Now, this is a file that you can download and then populate with the user account information for the users that you want to create via bulk create. Now, I've already downloaded and added user information to that file. Let me show you what it looks like. I like to open up this type of file in Excel. You don't have to. If you do, just make sure you save it as a CSV type of file and not an Excel spreadsheet. But at any rate, the template will include in the very top version, in this case v1.0. Then we'll have the name, which is required. We know it's required because of the asterisk to the right of that column heading. Same goes for the username, which is going to be the email address and the initial password. The other items like blocking sign in, first name, last name, job title, street address, you don't need to specify that. You certainly could. So we're going to go ahead and use this file to import users Marcia Lynn and Lucas Brenner. Back here in the All Users view, Marcia Lynn and Lucas Brenner do not exist currently as users. So I'm going to click the selector button over in step 3 to upload my CSV file. Once I've done that, there's a green message that states the file was uploaded successfully, so I'm just going to go ahead and click the Submit button to get the job started to create the users. And I can click on the link provided to view the status of each operation. So that takes me into the bulk operation results screen, where currently under completion time it says not completed, but as I wait and click the refresh button, eventually we will have a completion date and time. Because we only had 2 users, it's very quick. You can imagine it would take longer if you have 2,000 users you're creating. The status then states it was completed with no errors. So let's go back to our Azure AD tenant, and why don't we navigate back into the users view to make sure that the 2 users were created. Indeed, I have a record here for Lucas Brenner as well as for Marcia Lynn. So the 2 users then were successfully created from our CSV import file. Microsoft Azure allows you to perform a bulk invitation of external or guest users from a CSV file. Let's examine how that process works from beginning to end. So here in the portal, the first thing I'll do is navigate into Azure Active Directory, because within my Azure AD tenant, I want to go into the Users section. That'll open up the All Users view. Now, under the Bulk Activities button up at the top, you will see an option called Bulk Invite, which I'm going to click on. And in step 1, I have a button labeled as Download to download a CSV or comma-separated value template file that I can then populate with the external user account information required to perform a bulk user invite. So I've opened up and populated that sample file in Excel. I don't have to use this program, but that's what I've chosen to use, where I've specified the email address to invite. There's a redirection URL that was already supplied here to myapps.microsoft.com. Send invitation message is set to a value of true, and I've added a message, welcome to the Quick 24x7 organization. So once the user opens their mailbox and accepts the invitation, their account will exist in Azure AD. When we specify our CSV file, we'll get a message about the file having been uploaded successfully, so we can create the users by clicking on Submit. Then I can click the link provided here to view the status of each operation, which I will do. So I might have to click refresh, and eventually I'll be able to look at my bulk guest invite file that's added here with an upload date and time, and it should have completed successfully with no errors. And if we check the All Users view, we'll have a reference for our invited user, fakeuser173@hotmail.com, that was added from our bulk invite file. There is an Azure AD feature that's currently in preview that allows for user self-service sign-up, specifically when they access an app. It's done through an app with the user flow. So to configure this, the first thing that we're going to do is open up Azure Active Directory, and I'm going to start by going into Users because we have to then click on User Settings to enable this type of options. What I mean specifically is in User Settings on the right, if I scroll down, under external users, we've got an option labeled as Manage External Collaboration Settings. So I need to click on that option. And for the option that's labeled as Enable Guest Self-Service Sign-Up via User Flows Preview, I'm going to click on Yes. So the next thing I'll do is click the Save button up at the top. Now what I need to do is go back to Azure AD, and I need to click on External Identities in the left-hand navigator. Within here, over on the far right under Quick Tasks, I'm going to click Create a User Flow. We need to define the types of properties we want to gather from users as part of the Azure AD self-service sign-up process. So I'm going to click the New User Flow button up at the top, where the first thing I'll have to contend with is giving it a name. So I'm going to call it a name that will be unique. Then down below, if I scroll down further in step 3 for user attributes, I can check off the attributes that I want to make sure are gathered, like given name, surname, city, country, region, display name. I can click show more and even have access to additional properties that I might be interested in. So from here, for instance, I might select job title or state or province. Once I've made the appropriate selections, I would just click on OK, and I'll click Create. So that's going to create the user flow. But we need to establish a relationship with an app. And so that means I would then click on the newly created user flow in the list to open up its properties, and in the left-hand navigator, I would scroll down and select Applications, and I would then click the Add Application button up at the top. So I've got a sample app here called Sample App 1, which I'm going to select so that I can basically associate it with this user flow. So currently, this feature is in preview, as I mentioned, and what this means is that the user flows that we are associating with apps are really only apps that are custom built by your organization. So at this time, using Microsoft apps like Microsoft SharePoint and so on isn't yet supported. You can assign Azure AD product licenses to Azure AD users or to groups. When you assign it to a group, it's affecting the members of that group. So it's just an indirect way to do it to multiple users at once. So you would do this because you want to allow Azure AD users to access specific types of apps or features available in the Azure environment. So to get started here, in the portal, I'm going to navigate into my Azure AD tenant, and then I'm going to scroll down in the navigation bar, and I'm going to select Licenses. Now on the right, I'm then going to click Manage Your Purchased Licenses. I also have a button up at the top, Try and Buy, where I could add additional licenses or try some out if there are free trials available. I've got a couple of them here, and the first thing that we have to bear in mind is how many available licenses we have based on what we've purchased or what a trial run might allow. We also have to track whether or not any of these are expiring soon under the Expiring Soon column, and of course we can get a listing of how many were assigned from the assigned column. So for instance, the Enterprise Mobility Plus Security E5 license I have here has 249 available licenses with only 1 currently being assigned and 0 expiring soon. So I can go directly into the license by clicking on it here to add licenses for users or groups. You could also do it from the user or group perspective initially. So I'm going to go ahead and I'm going to click the Assign button up at the top to assign an additional user. So I click Users and Groups, and from here I can either browse or search through my Azure AD tenant for accounts. Here I'm going to filter for a user whose name begins with Jen, user Jen Hill. I'm going to select that account, click the Select button at the bottom. Now, depending what the selected license provides will determine what you get to enable or disable under Assignment Options. I'm going to click Assignment Options. This particular license, Enterprise Mobility plus Security E5, has options that will differ from other types of licenses that you might assign. So, for example, maybe one of the things I want to do is turn off features that won't be used, like Azure Rights Management or Microsoft Intune for cloud device management, and then I'll click OK, and then I'll click the Assign button. So after that, we can track how that went up in our notification icon in the right. Now I have an error. It says the license was not assigned. Well, it can't be that complicated, so what happened? Why don't we click on the link for licenses not assigned to see what it says? Now the reason that this didn't work is it says that the license cannot be assigned to a user without a usage location specified. What that means is that within the user account or user profile, we haven't defined a usage location, a country. Oh, that's no problem. Let's fix that. So the user in our case is user Jen Hill. So I'm going to go back into Azure AD. I'm going to go to my users this time because we have to correct the problem with Jen's account. I'm going to click on user Jen Hill to open up her account. And in the profile blade, which is shown on the right by default, I'm just going to click the edit button. And that will allow me to scroll down and specify, among many other properties, a usage location, which I'm going to specify here as being Canada. I'm going to go ahead and save that. So we can assign the license the same way we did previously to try this again, but since we're already in the user account, why don't we do it from this perspective? It makes no difference. I'm going to click Licenses over on the left. I'm going to click the Assignments button over on the right. I'm going to select Enterprise Mobility plus Security E5. The interface is a little bit different, but we can still uncheck items that we don't want available, like Microsoft Intune, for example, and Azure Rights Management, and then I'll click Save. So it happens very quickly. This time, though, if I go into my Bell or Assignments icon, we now have a message stating that the license assignment succeeded. One way to reduce the burden on help desk technicians in supporting users is to enable user self-service password reset, so that if a user forgets a password, he or she will have the ability to reset it themselves without help from the help desk. So to get started with this, in the portal, I'm going to navigate into Azure Active Directory. Naturally, we're then going to click on Users. Within the Users section in the left-hand navigator, I'm going to click on Password Reset. The default selection is set to None, but what we can do here is click Selected and browse Azure AD for groups that contain users for whom we want to allow self-service password reset. We could also enable it for all of the users within our Azure AD tenant if that's what we want, which I do in this case. So I'm going to go ahead and select all, and I'm going to click Save. After a moment, we can check this in our notification icon in the upper right, and we have a message stating that the password reset policy was successfully saved. The next thing I'm going to do to test this is sign in as a user, but I'll specify an incorrect password. I can sign into really anything to test it that's related to Azure, like myapps.microsoft.com or portal.azure.com. So I'm going to select myapps.microsoft.com, and I'm going to attempt to sign in. So I'm signing in as a specific user that has an account in Azure AD, and the password is incorrect. Now it says, if you don't remember your password, reset it now. We have a Reset It Now link. I'm going to go ahead and click on that link. The first thing I'm presented with is the user email address I'm trying to sign in with, and I have to enter the characters shown in the picture, or I can play the audio. So I'm going to go ahead and enter the characters, and then I'll click the Next button. Now we get an error message essentially saying that you can't reset your password because you haven't registered for it yet. Well, that's interesting. So what we're going to do is we're going to sign in correctly with the correct password for that user, see how the registration is done, then we're going to test it again once that's been done. So this is an important fact to remember. So after I sign in successfully, when I do know the password, I am prompted with a message that states that the administrator has required me to verify contact info, which is going to be used to reset my password. That sounds great. I'm going to click Verify Now. Based on the Azure AD security verification requirements, I have to specify an authentication phone number and an authentication email, both of which I will specify here. I'll do that by clicking the Set It Up Now link for both of those items. So by specifying a phone number, a text message or a phone call is sent with a unique code that I had to enter, and the same is true when I specified an email account. So I've done that, so we're good to go. Let's test this out once again. So I'm going to sign out as this user. And we're going to try to sign in with an incorrect password. Once again, we're going to click the Reset It Now link. This time, after we enter the characters that are shown on the screen, it's going to be a bit of a different story. So let's go ahead and click Next after entering those values. This time, it says that we can email my alternate email as the contact method for password verification to reset it, or text my mobile phone. So for example, I'm going to choose text my mobile phone. So it says that you need to enter the verification code down here, but first you need to enter the entire phone number. The phone number is masked here for security reasons. So I'm going to go ahead and enter that and click the text button. And I've received this code on my phone through a text message, which I've entered here. So I'm going to click Next. And lo and behold, I'm now given an option to enter and confirm a new password. So in this course, we've examined how to work with Azure AD, including managing Azure AD users and guest users, user license assignment, and self-service password reset. We did this by exploring the purpose of Azure AD and the use of single sign-on. We looked at how to create a new Azure AD tenant and switch between tenants, how to configure Azure AD verification methods, how to use the portal, CLI, and PowerShell to manage Azure users, as well as how to manage Azure AD guest user accounts and modify B2B guest user app permissions. Next, we explored how to create Azure AD users through bulk create and invite. We explored guest users through bulk invite and how to enable AD self-service sign-up, how to assign product licenses to Azure AD users, and how to enable self-service password reset for users. In our next course, we'll move on to explore Azure AD groups, including how to create and manage groups and group settings, such as licenses and group ownership. You can use the Microsoft Azure portal to create and manage Azure AD groups. To get started in the portal, I'm going to open up my left-hand navigator and I'm going to scroll down and choose Azure Active Directory. The next thing I'll do is click on Groups on the left. So that's going to open up a new submenu or navigation bar for group options. The first thing I'll do is make sure I'm in the All Groups view where any existing groups will be shown on the right-hand side of the screen. I'm going to go ahead and click the New Group button up at the top. I want to create a group here, but the first thing I have to think about is the type of group I want to create. There are two options. So the default selection for the group type is a security group that would be used for assigning permissions and so on throughout Azure. However, we can also elect to create an Office 365 mailing group or distribution list. In this case, I'm going to choose security. For the group name, I'm going to call it Team 1. And down below for the membership type, we can select from assigned, where we manually add users to the group, or it could be a dynamic user group where we have expressions that look at user attributes to determine group membership, or we could have a dynamic device group, which also would look at properties or attributes, but for devices to determine which devices should be a member of the group. I'm going to go with an assigned type of group. I'm going to click on No Owners Selected. I want to have a group owner that can control who's a member of the group and so on. So I'm going to select a user from Azure AD and add them as the owner. At this point, we could also add members. So under Members currently, it says No Members Selected. Well, I'm going to go ahead and click on that link and add a member. So I can browse through or filter my Azure AD listing. I'm going to filter it for a user by the name of Jen Hill, and I will add her to the group and I'll click Create. So we've created the Team 1 group. It's got one member. So if we open up the Team 1 group, in the overview blade on the right, there is information about the group, such as the fact that it is an assigned group. It is a security group. We can see the object ID assigned by Azure for the group, which can be important sometimes when working from the command line. And as we scroll down below, we can also see that we've got one direct user member, where if we click Members over on the left, we'll also be able to see that Jen Hill indeed is a member of the group. When I click the Add Members button to add a member to the group, take note that I can also add other Azure AD groups of a member to this group. So groups can contain groups. Groups can be nested, you could say. So that's an important aspect of working with this. But the purpose of groups really is to organize and facilitate permissions assignment. You can use the Azure CLI to create and manage Azure AD groups. Here I've already started my Cloud Shell environment by clicking the Cloud Shell icon at the top here in the portal. I'm going to run the CLI in here. The first thing I'm going to do is try to figure out what the syntax would be to work with groups. I'm going to guess that it's going to be AZ for Azure, AD group, and then after that I'm not sure. So -H for help. So I then have a listing of subgroups that would follow AZ-AD group. So I could work with members of a group or the owner of a group. But I also have other commands that could follow that, like creating a group, deleting a group, getting the group members in terms of the IDs of the members, object IDs, listing groups that are available in Azure AD, showing details about one group. So I want to create one. So I could take this further by doing AZ-AD group create -H so I can get specific help on how to create a group. And from here, I get a listing of the syntax, such as the required arguments, like the display name and the mail nickname. So that should give me enough then to get started. So I'm going to go ahead and run AZ-AD group create --display-name. I want this group to be named team2 --mail-nickname. Same thing, team2. I'm going to go ahead and press enter to create that group. All right, it seems like it worked, but we're going to verify our work by running AZ-AD group list. Now, the problem with doing that is that it shows all of the attributes for all of the groups. It can be a bit overwhelming on the screen. So let's clear the screen. Let's use the up arrow key to bring up our AZ-AD group list command, except this time what I'm going to do is use --query space open close square bracket .display name, where name has a capital N, and I'll press enter. That's better because now I can see the group that we've just created, team2, instead of all the additional attributes that aren't relevant to my current need. So I can also do this type of thing. I can run AZ-AD group member list -G for the group name is, in this case, team2. Now, of course, it's a newly created group and we've not yet added a user or any members. Could be a user, could also be a group, couldn't it? You can have groups that are members of Azure AD groups. So we're going to add a member. We're going to do that by adding a user. That means that I'm going to need to have a user ID. So I'm going to go ahead and run AZ-AD user show --ID, and I've specified an existing username. I'll just have to make sure I correct that. It's got to reflect the current Azure AD tenant. And additionally, I'm specifying the user principal name, the UPN. Then --query, and I'm asking simply for the object ID. Notice the I in object ID is uppercase because this is case sensitive, this reference. Well, if you have a syntax error like I do, because you have a dot right after the @ symbol, it's not going to be shy in letting you know. Let's try that again after correcting the issue. There we are. We have returned the object ID for a particular user. Now, why have we done this? Well, we've done that because what we are going to do is we are going to add user C Blackwell to the group using the ID. So I'm going to add C Blackwell to the group with the AZ-AD group member add command -G for the group of team2 --member -ID. And here I've pasted in the object ID for user C Blackwell. So I'm going to go ahead and press enter. AZ-AD group member list -G for group team2 --query space open close square bracket. I'm only interested in seeing the display name, where name is a capital N, for the members of the group. And indeed, we have a listing that implies that user Cody Blackwell indeed is a member, the team2 group. You can use PowerShell to create and manage your Azure AD groups. To get started here in PowerShell, specifically in Cloud Shell that I've launched from the portal, I'm going to use the new -AZ-AD group PowerShell commandlet. Now it's got two required parameters, the first being -display_name, I'll call the group team3, and secondly -mail nickname, which I'll specify the same value team3. Go ahead and press enter. So if I run get-azad group, it will list all of the groups that exist in my Azure AD tenant. However, if all I want to see is one specific property, I'm going to use the up arrow key to bring up that same command, but I'm going to add to it by piping to select, and maybe I'll ask for the display name of the group, comma, and maybe the ID. So we've just created a group named Team3, which is shown in the list along with its object ID, which I'm going to copy. Now I'm going to do this because when you work from the command line, you can specify the IDs of objects, and I'm going to be doing that a little bit later. So the next thing I want to do here is I want to add a user as a member of that group. In order to do that, I'm going to get the ID, the object ID for the user. So to extract that in PowerShell, I'm going to use a user-based PowerShell commandlet for Azure AD, get-azad user, -user principal name. I'll specify the email address or the user principal name for the user. And of course, it'll return back the object ID for that user, which I'm going to use in my command to add that user to my group. Now, to finally bring it all together, I'm going to go ahead and use the add-azad group member object ID. This is the member ID. That's for user Cody Blackwell in our case, the user that I want to add to the group. -target group object ID. What follows there is the object ID of the group that we just created, Team3. So I'm going to go ahead and press enter to add the user to the group. Now the next thing I want to do is make sure that we take a look at the members within that group. I can do that running get-azad group member -group display name, and Team3 is the name of our group. And when I do that, I'm going to see the members of the group, of which there is only one that we just added, user Cody Blackwell. Not only can we use Azure AD as an identity provider specifically for Microsoft Azure services, but we can also, of course, leverage its benefits for use with Office 365. In other words, Office 365 uses Azure AD. And so as a result, we have the ability to restore deleted Office 365 groups. So as an example here in the portal, let's start by going into Azure Active Directory, into our current Azure AD tenant. Let's go to the groups view, and the first thing I want to do is create an Office 365 mail group. So to do that, I'm going to click the new group button at the top. Now the default group type is going to be set to security. In this case, I want to change that to Office 365. I'm going to call this headquarters or HQ. Now for the group email address, I could specify whatever the email address is for that. So once I've done that, I can move on and specify things like group memberships. So I'm going to specify the group email address, in this case HQ, and it will add over to the far right my DNS suffix for my Azure AD tenant. For the membership type, it can be assigned or dynamic user, where dynamic user allows us to test attributes of users to determine whether or not they should be made a member of this group, or assigned, where we just manually assign them. So I'm going to set a group owner that has the ability to control the group, and then I'm going to go down and add a member to this group. Then I'll click Select over on the right, and I'll click Create to create our new Office 365 mail group. So our new group, HQ, is showing up in our list of groups in Azure AD. What I'm going to do now is select it and delete it. And I'll click OK. It disappears from the list. I'm going to do the same with a regular security group here called Team1. I'm going to put a check mark to select it, and I'll press Delete and OK. Bear in mind, if you've got licenses assigned to groups, you'll have to first remove that assignment before you can delete the group. So I've deleted two groups. So over in the left-hand navigator, I'm going to click on Deleted Groups. All I see is my deleted HQ group. I do not see Team1. And the reason for this is because it's working as designed. The deleted groups option, where you can restore a group, is available for Office 365 type of groups. So here I've got my HQ group. I can see the deletion date over on the right, but I can also see the permanent deletion date. So that's a month down the road where it'll be permanently removed or purged. So within that time frame, we can choose to restore it. So I put a check mark next to the group. I'm going to click the Restore Group button up at the top, and I'll click Yes. So it no longer appears here because it's been restored. It's no longer a deleted group. So if I go to the All Groups view on the left, sure enough, our HQ group is now showing up again. You can join devices such as Windows 10 computers to an Azure AD domain. You would do this for many of the same reasons you would do this in a traditional Active Directory sense, meaning it would allow users to sign in using a domain account. They don't have to have a local account on the machine to be able to sign into it. However, unlike traditional Active Directory, group policy is not supported by Azure AD. So here in the portal, I've already navigated to my Azure AD tenant, which is called Quick24x7, and I've gone into the Devices view. Currently on the right, we don't have any devices showing up, but that will change once we join our Windows 10 computer to the domain. Here on my on-premises Windows 10 machine, I've gone into the Windows settings. Next, I'm going to click on Accounts. This is where we have the ability to join to a domain. On the left, I'm going to click Access Work or School, and I'm going to click the Connect button. So what I'm going to have to do is sign in with the account I want to use. This is going to be the email address or the user principal name for an Azure AD user. So back here in the portal, I'm just going to navigate to my users list so we can take a look at an existing user that's going to be used to join that device. Here it's going to be user Cody Blackwell. Now, when I go into the profile for Cody Blackwell, this is where I will see Cody's user principal name or email address. I'm going to go ahead and copy it. Now, while we're here, let's go back into our Azure AD tenant, back into devices, because in order to allow users to join devices, we have to make sure the option is enabled. And so for that, what we want to do is go into device settings over on the left. Now we're looking for the option here for users being able to join devices to Azure AD. Currently it says none. We could choose selected and go through Azure AD to select accounts, or we could just say all, which I'm going to do. Then I'm going to click Save. Back here on premises on my Windows 10 computer, I've specified Cody Blackwell's user principal name or email address. Go ahead and click Next. Naturally, it's going to want the password for that user, so I'm going to go ahead and enter the password and click Sign In. And we get a message stating it's going to register the device with our company, and before you know it, it's completed. So it says, you're all set, we've added your account successfully, you now have access to your organization's apps and services. Okay, so I'm going to click the Done button, and on my Windows 10 computer, where I initially clicked on Connect, I have a reference now to a work or school account, in this case a work account, with the user principal name or the email address of the user that was used to join to Azure AD. If I click on that listing, I can choose to disconnect so that the device will not be a part of that Azure AD domain. Of course, here in the portal, if we go to our All Devices view, we will have a new device listed. In this case, it's for my Windows 10 laptop. So the OS is shown as being Windows. We have the version of the OS. The join type is Azure AD registered. We can see the owner is Cody Blackwell, the user that joined the device. We can click right on the device name to open up further details about it. So again, we'll see things like the owner, the username, the object ID, and so on. So that device can now be used to sign in with any valid Azure AD user account. Before you join or register devices with Azure AD, you might want to take a look at some of the device settings, some of which are very important because it determines if users can or cannot join devices to the domain. So here in the portal, to get started, I'm going to go into Azure Active Directory, and on the left, I'm going to click on Devices. Now that's going to open up our Devices submenu, where I'm going to click device settings over on the left. Now, the first thing we need to do is ensure that users have the ability to join devices to Azure AD. I've got that set to all right now, which means all users in my Azure AD tenant. It could be set to none or selected, where we can then go down and select who is allowed to join devices. I could click the Add button, and I could select Azure AD groups or individual users or any combination thereof, and they would be the only entities in this Azure AD tenant that would be allowed to join devices to the domain. We can also specify additional Azure AD accounts that would have local admin access on joined devices. Now, anyone that is a user in Azure AD that has some roles assigned, like the global Azure AD admin, would already be a local admin, but we could click Selected and determine which users should be added as local administrators so they can troubleshoot and perhaps work in a help desk capacity for people using those systems. Also, down below, we can specify whether multi-factor authentication or MFA is required to join devices to Azure AD. That's currently set to no. The maximum number of devices per user is 5. And down below, also on the left, we have enterprise state roaming. This allows user settings and their app data to be synchronized across their devices. If they're using, for example, a laptop when they're at the office or working from home, but they're also using a mobile device when they're on the go. So we have a number of these options then that we can configure to control Azure AD device management. We know that we can join devices to an Azure AD domain and that it allows any valid Azure AD user account to be used to sign in to that device. But there are times when you might want to disable a device to prevent it from connecting to Azure AD, such as when the user or device is considered perhaps to somehow be compromised from a security perspective. Here in the portal, I'm already in my Azure AD tenant. I'm going to go to the Devices view over on the left, and any existing devices will be shown on the right. Now, I have one, which is a Windows 10 laptop. I'm going to select that device and choose the Disable button at the top. I'm asked to confirm my selection. I'm going to choose yes. I'm sure I want to disable the selected device. And the enabled state changes from yes to no when we are viewing our devices. And if we look at our notification bar in the upper right, it successfully disabled the device. However, it can take time before this actually takes effect. You could also have disabled the device using command line tools like PowerShell. Now, the thing to bear in mind, too, is that if it's a Windows device, so let's say it's a Windows 10 computer, it will have a cached username and password if an Azure AD user signed in already. Now, what this means then is that the users who have already signed into that device will still be able to sign into that desktop using the cached version of their Azure AD username and password. However, if we've got, for example, conditional access policies that are based on that device to allow access to apps, those won't work anymore. So at some point, the user will get a message about the fact that the organization has disabled their device. As an example, here we have user Cody Blackwell that was connecting to myapps.microsoft.com, the landing page where users can access any apps that they were assigned to, even for Office 365. But we have a message stating that something went wrong, and specifically, it says your organization has disabled this device. Azure AD dynamic groups are available for both users and devices. You just can't have both users and devices in a single dynamic group at the same time. So group membership being dynamic means that we are not manually adding users or devices to groups. Instead, the membership is based on the user or device attribute. So a user attribute might be city or department if that's been filled in for that user, where a device attribute could be something like the OS type running on that device. So in order to use dynamic groups, you need at least an Azure AD Premium P1 license. So dynamic groups have an evaluation cycle that occurs whenever user or device property changes. The benefit of organizing items like users or devices into groups, of course, is to facilitate granting permissions for resource access. We can also assign licenses to the members of dynamic groups. So as an example for users, if we take a look at some of the syntax for building the expressions within a dynamic group, we would see something like this: user.type. So user is the object class, .type is the property within that object class, or the attribute, same thing. So we're saying user.type -eq for equals guest. That would return only guest or external users. The next example is user.companyname -ne for not equals null, followed by user.department -equals or eq it. And then we have a more complex expression below where in the first set of parentheses, we have user.type equals guest and, literally, and then in the second set of parentheses, user.companyname not equal to null, where we can compare the user city attribute to see if it has Halifax, Montreal, or Toronto as a value. So whenever you use the rule builder to build these expressions, you can have up to 5 expressions. If you don't want to do an exact match of a string, you can also use -match. So here we're doing user.department match, and in quotes we have it.*. We can also test device.os type equals iPhone, as in this example, or device.device manufacturer equals Motorola. So we have a number of different ways we can create our rule expressions for dynamic groups. Dynamic groups are a great option in Azure AD because instead of manually assigning members to a group, you can specify attributes, such as user attributes, that must be satisfied in terms of conditions, and then the user is automatically made a member of the group. If the user attribute changes, such as a department that the user is in, then they would automatically no longer be in the group. So it's for adding and removing users to groups dynamically. You can also do this for devices, but in this demo, we're focusing on user dynamic groups. So to get started, let's go into Azure Active Directory in the portal, and I'm going to click on Groups on the left. I want to add a new dynamic group, so I'm going to click the New Group button up at the top. The default group type is security, which is great for my needs in Azure for assigning permissions to resources. For the group name, I'm going to call it Project A. And for the membership type, which is defaulted to assigned, so manually assigning members to the group, I don't want that. In this case, I'm going to choose Dynamic User. Down below, I'm going to click and select a group owner that can manage the group. And then under Dynamic Group Members, I'm going to click on Add Dynamic Query. So here in my dynamic membership rules, I can specify 5 expressions. So to determine group membership. So I'm going to click down under property where it says choose property, and I'm given a list of user attributes or user properties. So as I scroll all the way down through here, one of the ones that I have is department. And I know that in our Azure AD tenant, I have filled in the department attribute for user accounts. So the property is department. The operator, there are many to choose from. I want to use equals, but it could be in, if we want to look for a particular item, and any, contains, not in, match, not equals, not starts with, a lot of possible variations. We're going to keep it simple here, equals. And what I'm looking for is human resources. I know that's how I've typed it in for some existing user accounts. Now down below, we could click Add Expression. I'm just going to click outside in a white area to add the rule syntax down below. So I don't want to add another expression. So our rule syntax shows up as being user.department-eq for equals, and in double quotes, human resources. So I'm going to go ahead and click Save, and then Create to create our dynamic group. Now, depending on how many objects you have in your Azure AD tenant may determine how long it takes for the group membership to be refreshed. If I click on our newly created Project A group again, in the overview blade, I have a listing that states this is a dynamic security group. And then I've got 2 important properties I want to watch here: membership processing status and membership last updated, which are both currently blank. So I want to keep my eye on this, at least initially, to have a sense of when it will have finished checking the attributes of Azure AD users to determine group membership. After a moment, if I click on something else and then click back on the overview blade, over on the right, when I check the membership processing status, it will eventually state update complete, and we'll have a date and timestamp for the membership last updated. So if I click the members item on the left, I'll see any members of this group, and we have two of them, Jen Hill and Marcia Lin. These are both users that have the department attribute set to a value of human resources. Why don't we just click on one of those users to open them up and take a peek? So in the profile blade, let's say for Marcia Lin, if we scroll down, indeed, department is set to a value of human resources. You can create dynamic device groups in Azure AD so that the membership of the group is determined automatically or dynamically, as opposed to you having to add devices to the group. The way that this works is you need to specify device attributes that you want to test with conditional expressions to determine whether the device should be placed in the group or not. Let's see how that's done here in the portal. I'm going to navigate to Azure Active Directory, and I'm going to click on Groups. You can create both dynamic user groups and our current focus, dynamic device groups. So I'm going to click the New Group button up at the top. I want to create a group that will contain Windows devices that are joined to Azure AD. So the group type will be Security. For group name, I'm going to call it All Windows Devices. And for the membership type, I'm going to choose Dynamic Device. I'll select a group owner that can fully manage the group, and under Device, and under Dynamic Device Members, I'll click Add Dynamic Query. I'll click on Choose Property, and what I want to do here in this list of device attributes is go down to Device OS Type. The operator here is going to be equals, and the value will be Windows. If I click outside of that, it'll add the rule syntax down below, which is shown as device.deviceOSType-EQ Windows. We could add multiple expressions here, but I'm going to leave it at that, and I'll click Save. Then I'll click Create to create our new dynamic device group. It can take a little bit of time for it to evaluate existing devices and looking at their attributes for a match. But I'm going to go ahead and open up our All Windows Devices group, and in the Overview blade, I can track the membership processing status and the membership last updated, which are both currently empty. So I'm just going to wait a few minutes and then click on something else and come back to the Overview blade to view those two properties. Before too long, when we check back, we'll have a membership processing status with the value of update complete. And if you look down below that, you'll see the membership last updated has a date and timestamp for when the device membership was evaluated. So I'm going to go ahead and click on Members over on the left. And we've got one member. It's a laptop computer that happens to be running Windows 10 that matches the condition or the expression where we were searching for a device OS type of Windows. Licenses get assigned to Azure AD users to allow them to partake in the use of specific features. Now, we can also assign licenses to Azure AD groups, which by extension trickles down to the group members to assign licenses to them. So the way that we do this in the portal is as follows. First things first, let's open up Azure Active Directory to navigate to our Azure AD tenant. Next thing I want to do is over in the left-hand navigator for my Azure AD tenant, I'll click Licenses. Now from here, I'm in the Overview blade, and on the far right, I can choose Manage Your Purchased Licenses. So what's important to look out for here are the available licenses. Of course, that's compared against the assigned licenses. You need to make sure you have available licenses, otherwise you have nothing that can be assigned. Now what we could do is click on a specific license within here, and on the left, we're looking at licensed users. I have a few licensed users already shown here, but we could click the Assign button to assign additional individual users, but we're really here talking about groups and license assignment. So I could click License Groups over on the left, and from here I could click the Assign button. Go ahead and do that, and I'm going to click the Users and Groups option, because from here I can scroll through Azure AD and I can select users or groups that I want to add. For example, here I'm going to add the Project A group, and I'm going to click Select. For the assignment options, this is going to vary depending on the type of license that you are assigning. In this case, it's an Enterprise Mobility plus Security E5, so we have some Active Directory security type of options. So for example, maybe I want to turn off Microsoft Intune device management. So I'm going to go ahead and click OK and Assign. Now here I've navigated to the members of the Project A group, one of which is Jen Hill. That user already had a license assigned, but then there's a user here, Marcia Lynn. So what we can now do is open up an individual user here, go into licenses. We could have done this actually to assign the licenses in the end. Currently, there are no license assignments found. Well, when you assign licenses through groups, it can take a few minutes for it to propagate down to the members. So I'm just going to stay here and periodically click on refresh, and I just did it and it popped up right in front of me. We have a listing for the Enterprise Mobility plus Security E5 license. The state is active, and it was inherited. The assignment path is showing that it was inherited from the Project A group, because that's where the group assignment actually took place. In Azure, you can set a group owner that has full management capabilities over an Azure AD group, such as adding and removing members. So to check this out here in the portal, first thing I'll do in the left-hand navigator is scroll down and jump into Azure Active Directory for my current Azure AD tenant. Next thing I'm going to do is click Groups in the left-hand navigator. That'll expose any groups we have over in the right-hand panel, one of which we have is called Team 2. If I click on a group and open it up, in the navigation bar for the group on the left, we'll have the option of clicking on Owners. Notice it's plural. We can have more than a single group owner to manage the group. On the right, currently, we have a message stating that no owners have been found. So I'm going to go ahead and click the Add Owners button up at the top. I'm going to add user Cody Blackwell, an existing user I already have in Azure AD, and I'll click Select. We could add more than one owner, but at this point, what I want to do is sign in as Cody Blackwell, whether it's signing into the Azure portal or even signing into myapps.microsoft.com, where group owners have the ability to manage the owners. Either way, we could see whether or not Cody can manage Team 2. So I think we'll use myapps.microsoft.com in this particular example. Once user Cody Blackwell has signed in to that site, one of the options over on the right is Groups, which I'm going to click. This is going to open up a new web browser window where in the left-hand column, we've got a heading labeled Groups I Own. And down below, we have all the groups that this user can manage or owns, and we can see that Team 2 is listed here. If we were to click Team 2, from here, we would be able to start working with members of the group shown over on the right-hand side. We've got a plus button that we could click on to add members, either by searching by name or email address. So if I search for user Jen, for example, in Azure AD, it finds someone called Jen Hill. So I can select that user and click Add, and I've successfully added a member to the group because, in this case, user Cody Blackwell is the group owner. So group owners then reduce the burden on the help desk potentially by being able to manage group membership. The Azure AD Group Self-Service option allows users to request membership in groups, thereby bypassing involving Azure technicians or perhaps help desk personnel. To get started with this, I'm going to go in the portal, and in the left-hand navigator, I'm going to navigate to Azure Active Directory, and then on the left, I'll click on Groups. That's going to open up the Groups navigation bar, and on the left in there, I'm going to click General. There are two options that will show up at the top right I'm interested in. The first is labeled under Self-Service Group Management. Owners can manage group membership requests in the Access panel. The Access panel being a part of the myapps.microsoft.com webpage that users might normally sign into to gain access to their web-based apps. So I'm going to go ahead and choose yes for that. Below, we have a second option that's relevant. It says restrict user ability to access group features in the Access panel, and that's set to yes. I don't want to restrict that from users, so I'm going to select no for that particular option. And the next thing I'm going to do is click Save to save that setting. Now I'm going to navigate back to my Azure AD tenant, and we're going to use a group as an example. So let's start by going to the Groups view. I've got a group here called Team 3, which I will open up, and I'm going to go into the owners. Currently, there are no group owners. Well, let's start by adding an owner. Click Add Owner at the top, and I'm going to add an existing Azure AD account, a user by the name of Cody Blackwell. And I'll click Select to add that user as a member. And if we check the members view, we have no members currently in this group. I've signed into myapps.microsoft.com as user Cody Blackwell. Within that, we have the Groups option shown on the right, so I'm going to go ahead and click on Groups. And on the left, under Groups I Own, user Cody has the ability to manage Team 3 as we see listed here. So I'm going to click on Team 3 to open up that group, and I'm going to click Edit Details because the current join policy for that group is only the owner of the group can add members. We want to change that for this particular group. So I'm going to click the Edit Details button, and the group policy at the bottom, I'm going to change that. We could set it to this group requires owner approval. So in this case, the owner is Cody. Cody would have to approve any requests to join the group, or this group is open to join for all users. Why don't we choose this group requires owner approval, and I'll click Update. And that is reflected back on the previous screen, where previously the join policy was that only the owner could add group members. Now what we're going to do is sign in to myapps.microsoft.com as a different Azure AD user that's going to request membership in the Team 3 group. So in this example, I've logged in as a different user by the name of Lucas Brenner. Now the next thing we'll do here as Lucas is click Groups over on the far right, and we're going to click the Join Group link. From here, we're going to select Team 3. Team 3 is the group we just modified the join policy for. So I'm going to click the Join Group link, and the business justification field, I can specify here, need access to Team 3 apps. And I'll click the Request button. So the request will have been sent then, which needs to be approved in our specific configuration by Cody Blackwell. So there's a message for Lucas here. Your request has been sent to the owner of the group. I'll click OK. Now we're back into myapps.microsoft.com, but this time as user Cody. So Cody's going to go into Groups. Now we're back in the myapps.microsoft.com webpage as user Cody. So Cody's going to go into Groups over on the right, which opens up a new window. And there's a notification in the upper right. And if we click on that, it's the fact that Lucas Brenner wants to join Team 3, and we can see the business justification listed. We can either approve or deny. In this case, Cody's going to approve that group membership request. So I'll click the Approve button. Now, if we go back in as Lucas Brenner and click on Groups on the right, what will happen is Lucas Brenner will be shown as being a group member for Team 3. There are times where you might want to add multiple users to a group or even remove multiple users from a group using a file that contains the user information. So this is true when it comes to bulk updates. So we could do this quite easily in the portal. So for example, here in the portal, I've already navigated to my Azure AD tenant. And so what I want to do on the left, because we're talking about groups, is click on Groups. Now within that, over on the right, I've got a group named Team 4. And if we take a look at the current membership of Team 4, we have no members in the group currently. Now we have the option of adding members up at the top, and also we have a remove option for individual users. We can also remove members, so plural, using an import file. So for example, if I click the Add Members button, from here, we can select individual users. However, that's doing it manually. We also have the option of importing members. When I click Import Members, that opens up the bulk import group blade over on the right. Step 1 allows me to download a CSV or comma-separated value file format template that I can then populate, which I've already done. So here's the contents of my file. So in cell A1, because I've opened this in Microsoft Excel, I've got the version string, so v1.0. Then I've got the column heading below that for the member object ID or user principal name. There's an asterisk to the far right because this is a required attribute. It's the only one in this sample file. So I've got two user email addresses shown below. These are existing users that already exist in Azure AD. So I've added their email addresses or their UPNs, their user principal names, so they become members of the group. So this doesn't create new users. We're referring to existing ones that we want to add as members of that group. So in step 3, I can click the selector icon to the right to upload my CSV file. I've done this, and there's a message stating that the file uploaded successfully. So I'm going to go ahead and click Submit to submit this request to import those users from that import file. We can click to view the status of that operation. Currently, it's not been started, it's not completed, but we do have an upload date and time. So depending on how many users you're talking about in your group member import file will determine how long this takes. We can just click the refresh button and track it here. So I have a message under status stating that it completed with no errors, and we've got a completion date and time. So let's click on members over on the left to see if those two users are shown as members of this group. And indeed, they are. So now that we've got members of the group, the Remove Members button up at the top has become available. When we click that, that would allow us to do a bulk group member removal given a CSV file with the user principal names or email addresses of the users that we want to remove. So essentially, it's the opposite of what we just done to import group members. You can join a mobile device to Azure AD to take advantage of the ability to authenticate to access apps that might be made available to users. So here I'm going to join my Android smartphone to Azure AD. I'm currently in the settings of the phone. So now I'm just going to scroll down until I get to Accounts, and I'm going to tap on Accounts. From here, I want to add an account, so I'll tap that, and I'm going to scroll down and tap Work Account. So that opens the Workplace Join screen. I'm going to go down, and in the username field, I'm going to specify the user principal name or the email address for one of my Azure AD users. Specifically, in this case, user C. Blackwell, Cody Blackwell. And I'm going to go ahead and sign in with that account. So now that that's done, I'll tap Join, and it says Joining Your Workplace. So next, of course, I'll be prompted to specify the password for that user account. So I'm going to go ahead and do that. I'll then be asked to name a certificate that it will create automatically. So I'll just go ahead and accept that. And then I get a message about the Microsoft Work account installation being successful and the certificate installation being successful. So we've now joined this device to Azure AD. So the next thing we can do is check that that mobile device was registered as a device in Azure AD. So here in the portal, I'm going to navigate to my Azure AD tenant, where I'm then going to click on Devices on the left. And we'll notice that we have a new Motorola Moto X Play Android device being shown in the list of devices in Azure AD. We have a version string for the version of that Android operating system running on that smartphone. And we also have a listing of the user, in this case, Cody Blackwell, as being the owner. That's the person that signed in to join that device to Azure AD. And just like with other joined devices, like our Windows 10 laptop shown above, we can select our mobile device and we can choose to disable it by clicking the Disable button at the top to prevent it from being used to access applications that are available through Azure AD. Now, while we're here, if I click Device Settings over on the left, it's important to make sure that users have the ability to join devices in the first place. I've got it configured here, set to All. That's for users may join devices to Azure AD. I could select specific users, but I've just opened it up. Also, the other thing that could be interesting is Enterprise State Roaming. If I click that over on the left, we can determine if users should be allowed to sync their settings and app data across devices. Now, in our case, we've got user Cody Blackwell with a Windows 10 device registered with Azure AD and an Android smartphone. So for a consistent experience, maybe settings and app data should be synced across those devices. So I'm going to choose Selected, and I'm going to go ahead and browse for that user. I'm going to click Add. We're interested in user Cody Blackwell, so we're going to filter for that account in Azure AD, select it, and continue through by clicking OK, and then save. So we've enabled enterprise state roaming for that user account. Here, I've signed into myapps.microsoft.com as user Cody Blackwell. If I click on his name in the upper right, I can go ahead and choose Profile, where I will have a listing of devices shown at the bottom, of which we have two. We have our Windows 10 laptop, as well as our Motorola Moto X Play device. We have the ability to even disable those devices here from the web browser interface. You can create and manage enterprise applications within Azure Active Directory. This allows you to grant the permission to use an application, which would then be available for the user, for example, in the myapps.microsoft.com webpage. So to get started here in the portal, I've navigated to my Azure AD tenant, and so in the left-hand navigator, I want to click Enterprise Applications. This will give me a list of any existing enterprise apps, and I could click the New Application button up at the top. I could choose application you're developing if we've got a developer team, software developers building a custom app. We can make a reference for that here in Azure AD. We could make a reference to an on-premises application through an Azure AD application proxy, or we could specify a non-gallery application that we want to make available to users. So either way, we'll have an application shown in the Enterprise Applications part of Azure AD. I've already got a sample one here called Sample App 1. Well, once you've added an application here, you need to make sure the appropriate users are, number one, licensed to be able to use it. Now, that will be important for some types of applications, like for Office 365. But in this case, for Sample App 1, I can just go into the properties of that enterprise app. And on the left, what I want to do is click Users and Groups. This is where I determine Azure AD users or groups that I want to have access to this application. So I'm going to go ahead and click the Add User button up at the top, and I'm going to click on Users and Groups. I'm going to search for a user, Cody. I'm going to add user Cody Blackwell as a user of this app, and then I'll click Select at the bottom, and then Assign. So what it will have done in this particular case for the role assigned for that user is it's referencing default access. Depending on the app, you may have different roles that can be assigned to groups or users that are added. In this case, there are no specific roles for Sample App 1, so as a result, the role assigned is default access. So the next thing I'll do is sign into the myapps.microsoft.com website as user Cody Blackwell. Once that's been done, we can see we're signed in as user Cody in the upper right. We'll have access to apps, including the one that was just added, shown here, Sample App 1. So, in this course, we've examined how to work with Azure AD groups and group settings, including the creation of groups and the management of groups. We did this by exploring how to manage Azure AD groups using the portal, CLI, and PowerShell. We looked at how to restore deleted Azure AD groups, how to join a Windows 10 computer to an Azure AD domain, how to manage Azure AD device settings and disable a device from connecting to Azure AD. We looked at how to create an Azure AD dynamic membership user and device group. We then examined how to assign licenses to a group, how to work with group owners and enable self-service group membership, how to use bulk options to add and remove group members from a file. We looked at registering an Android device with Azure AD, and finally, how to configure an Azure AD enterprise application. In our next course, we'll move on to explore Azure AD security management, including the use of Azure AD Connect, domain services, and MFA.